and welcome, I'm your Code Monkey. Welcome to the free advanced section for my complete C# mastery course. By going through this course, you'll be able to make games, websites, apps, robotics, and literally anything. C# is an extremely versatile language. This complete course starts from the absolute basics like how code executes line by line and what is a variable, then covering some intermediate topics like what are interfaces, generics, and events, and how you can use them to build some really awesome things. You will also learn the theory behind how to choose good naming rules, clean code guidelines, and learn about design patterns. And finally, in this advanced section here, this one covers some very interesting topics like reflection, async programming, and multithreading. This free YouTube video over here, this one contains all of the video lectures for the advanced section. Like I said in the previous video, my goal was to publish the video lectures here on YouTube for free if the premium version sells above a certain number of copies. And I'm happy to report that it has indeed sold above that threshold. That's why this free video is here right now. So thanks to everyone who can afford and who did pick up the premium version. I've already posted the 2 free videos with all of the video lectures for the beginner and the intermediate sections. And now here we have the advanced section. The premium version of the course has all the video lectures for all the sections, and also has a bunch of really nice bonuses. So speaking of that, here are the bonuses for the premium version. I came up with some that I think are really awesome, and definitely worth it if you can't afford it, while at the same time not putting any knowledge behind the paywall, so even people who can't afford it, they can still learn from the free video lectures. They really just need to do a little bit of extra work themselves. The premium version is really just selling convenience, making it really easy for you to truly gain the knowledge. The premium version comes with a companion project. This is a Unity project that contains a bunch of extra content. Basically, the video lectures, while being pretty massive themselves, they're still really only half the course. The other half of it is inside of this project. It has a bunch of custom edited windows to guide you through each lecture. And each lecture has a section on frequently asked questions. These are common questions that have some really detailed answers that provide even more details on what is covered in the lecture. Then there are some quizzes. These are multiple choice questions. Again, all with very detailed answers. It's really not just correct or incorrect. If you pay close attention to each lecture, you should be able to get most of these right. But whether you do or don't, by reading the extra explanation that will help you truly learn that topic. Then the interactive exercises, I'm really happy with this feature. I think this will really help you learn. Learning by doing is always much better. And these exercises encourage you to put what you learned into practice instead of just blindly watching the video lectures. I designed a ton of handcrafted exercises for all the lectures to help you put into practice and truly learn the contents of each lecture. There are all kinds of exercises. Some are about spotting and fixing errors, others are about asking you to define some function or class or implement some kind of logic. There are some where you just write code, and some where you write code and then play the code in Unity in order to complete the exercise. Then each exercise also contains a hint just in case you get stuck, or a solution in case you get really stuck, as well as a video walkthrough of me going through that exercise and completing it while explaining everything in detail. So if you're the kind of person who gets stuck in tutorial hell, then I truly believe that this will really help you escape it. In order to learn, you need to actually do things, and these exercises encourage you to do that. They encourage you to do it as opposed to just blindly watching the video lectures. Then the companion project also has a companion window. Basically, this window is also listening to a bunch of errors, and if it finds one, it will help guide you in the right direction. I manually wrote a ton of text for when it detects lots of errors, all of them based on common errors that I see people ask about in comments in my own videos. So this should help prevent you from getting stuck in your learning journey and allow you to get help instantly. Then the course also has an AI to help you answer questions. This one was trained on the contents of the course and my own knowledge, so it should be very accurate and helpful. But more than that is simply the fact that it is extremely fast. You post a question in the course comments, and within a few minutes the AI will respond with probably a very good answer. Although of course, I myself will also still be answering all the questions manually. The goal with this AI is really speed, so you get a response almost instantly, and then within the next few hours I will manually answer myself. Then a simple bonus is how the premium version has the course split into lectures, as opposed to here on YouTube where it will be one giant video. It has to be that way due to how the YouTube algorithm works. This is a small thing, but it can be helpful, especially if you take your time to slowly go through the course just like you should do. Remember that the only goal is really that you are actually learning yourself. It does not matter how quickly you go through it. So separate lectures help with that so that you can pause and actually try out your knowledge before going further, and you don't have to memorize specific timestamps. And over here on YouTube, the videos have the normal YouTube ads as usual, whereas the premium version has no ads, so there's nothing to interrupt you while you're learning. Another 2 great bonuses is the private Discord and the live study group. You get access to a private Discord with a really nice community of people all on their own learning journey. I'm there myself as much as I can to answer questions or really just chat. And every week I also do a private live QA. You can join me on the live stream and ask anything you want, and I'll do my best to help. So these are the nice bonuses that I came up with that I think are really nice and really awesome while not taking away anything or putting any knowledge behind the paywall. If you can afford it, then I highly recommend the premium version. These bonuses will help you truly learn, and learn much faster than the 10 years that it took me. But if you can't afford it, that's okay. Like I said, there's no hidden knowledge hidden behind the paywall. You really just need to put more effort in yourself in order to actually apply the knowledge that you gain. So whether you get the premium version or watch free lectures, I really hope you'll learn a lot. Also, just in case you're new to my channel, so a bit about me and my credentials or why you should listen to what I have to teach. For me, I've been programming for over 25 years and specifically using C# for over 10 years. I'm a professional indie game developer with several successful games published on Steam covering a wide range of genres. My games are usually focused on complex systems since I am primarily a programmer. It's what I really love to do and what I love to teach. Also, a couple of years ago, I started over here this YouTube channel making free video tutorials to basically share my knowledge to help you learn how to make your own games. There's already over 800 free videos over here on this channel if you want to continue learning beyond this course. Or look at my other courses. If you want something on making a specific game, you can watch my free Kitchen Chaos course. In there, we build a game from start to finish, and then on a second video, we add multiplayer onto it. Then for something more intermediate, for that, check out my turn-based strategy course. This one includes a really nice turn-based strategy game with actions and enemies and all kinds of things. Or if you're an advanced user, if so, then check out my Unity Dots course. Unity Dots is an extremely powerful, very advanced toolset that can help you write code that runs literally 100x faster. Or in general, for Unity, you can check out my Ultimate Unity Overview course. This one covers over 70 tools and features that Unity has. Also, even though this video is for advanced users, let me reiterate my usual advice for pretty much anyone trying to learn. That's really just take your time, take it slow. Remember, this is your learning journey, it's really no one else's. So the only thing that matters is that you learn. It does not matter how long it takes you. It does not matter if someone else learns faster. You're really not in competition with anyone but yourself. Remember, you are not expected to go through this entire course in 1 week or even 1 month. Like I said, this course contains knowledge that took me over 10 years to gather. So take it slow, take your time, really just focus on learning. And just one final request, if you find this video helpful, if it helps you on your learning journey, if so, go ahead and hit the like button on the video and subscribe to the channel. It's a tiny thing, but it really does help. Alright, so let's get to it. Hello and welcome, I'm your Code Monkey. Alright, so here let's see a quick overview of everything we're going to learn in the advanced section of this C# course. This is going to involve a lot of very interesting, very unique topics. We're going to start off with an interesting advanced topic that I actually only started seriously using just recently. It's reflection. I had to learn this myself in order to make the exercise for the companion project. Reflection is how you can dynamically inspect your code and work with it without directly calling any functions or reading any fields. Next is going to be a simple but interesting one. It's how you can make some function extensions. This allows you to extend a type with more functions without having to modify that type itself. This is really useful when you don't have access to the type itself, when you don't have source code access. Then we're going to learn about static constructors. These are kind of like the normal constructor, but they run just once for the entire class. After that, we're going to learn about the typeof keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then a lecture on nameof. This one helps you get a string name for some kind of type. This is really useful to help you avoid strings in your code. Next is the sizeof operator. This one lets you get the size of your types. Like for example, you can see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps you know how much memory your code will use. Then a lecture on default. Simple and very useful way to get the default value of some type. If you do the default of an int, you get 0. If you do the default of a bool, you get false. If you do the default of some object, you get null, and so on. So using this keyword is much better than hard-coding some default values. After that, we're going to have a lecture on expression-bodied members. This is a really interesting, very compact way to write simple short functions. There's no need to write all the usual function boilerplate code. This one is basically just a lambda. After that, we're going to see a lecture on records. This is a super simple way to create immutable types to organize your data. Next, we're going to learn about the null conditional operators. This is how you can easily test for null before doing something, like for example, before firing off an event. Then a lecture on the null coalescing operator. This one lets you quickly test against null, and if it is null, return a default value. After that, we're going to learn about the ternary conditional operator. This is an excellent, super compact syntax for making a very simple if. You have the condition with an if and an else, so it's all very tiny, very useful. Next, we're going to learn about the main function in a console app and how to pass in some command line arguments. This is a really important one because there are many interesting programs that you can build that don't need any kind of UI. So a simple console app that you can control with some command line arguments, that one is always going to be an excellent option. Then a lecture on Nullable. This is how you can make any type support null. Even value types like int or bool. You can make them nullable to support null. This can be much better than having to predefine some special value, something like -1. Next, we're going to see a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create a new object. This one is basically just a pointer, meaning it is insanely performant. Then a lecture on Bitwise Operators. This is how you can work with individual bits of data. In this lecture, I'm also going to teach the basics for how binary works. Next, we're going to learn about Enum Flags. This is how you can turn your enums into bit masks, which then allows you to make some interesting combinations. Then a lecture on Preprocessor Directives. With this, we can give orders to the compiler itself. We can define symbols and include or not include some code in the compilation. Next, a lecture on the keywords ref, out, and in. These are really useful. They help you get more data out of a function than just a single return type. And they also help you work with types as references, even if they are valid types. After that, we're going to learn about data boxing. Now, this does not have anything to do with punching people. It's really all about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we're going to learn about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields on that type, on that object, even if they don't really exist. That validation logic is only going to run at runtime, not at compile time. So this dynamic, this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, you can make your own custom types, support access through an index, just like a list or array. You can add whatever logic you want and make it read-only or read-write. Next is a lecture on attributes. With this, you can add metadata to your code. Then that metadata can represent whatever you want. You can use reflection to analyze it and do something to it. After that is a lecture on anonymous types. Really interesting, quick way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that is the next lecture on tuples. These are very similar. They also allow you to organize some data without first defining a type. In this lecture, I also covered the differences between anonymous types and tuples. Next is going to be a lecture on using IDisposable. This is a really interesting code block and interface that helps you make sure you don't forget any kind of cleanup code. After that, we're going to learn how to create custom override operators. Using these, we can add support for our own classes to do things like addition or multiplication. We can define the logic of what exactly it means to add two custom player classes together, and also define the logic for comparing two custom types, meaning defining the logic for what exactly does it mean to do an equals. Next is a lecture on LINQ. With LINQ, we can easily do query operations on any collection of data, whether it be a list or array or some XML or some kind of database. We grab that data, then we can query for some conditions and select just a few elements. We can sort some things, we can do a union and so on. If you're familiar with SQL, then LINQ will be quite familiar. Afterwards, we're going to learn about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop the components. Here, I'm also going to talk about the other visual program tools, things like WPF and .NET MAUI, as well as how Unity itself doesn't have to be used just for making games. You can make normal applications with Unity. Next is going to be a lecture on DLLImport, the library import, how to use extern and work with the Windows API. So this one is going to be a great lecture to learn how to interact with external libraries. Then a lecture on asserts and unit testing in general. With this, you can validate your own code to make sure everything is behaving exactly as intended. Next is going to be a lecture on writing unsafe C# code and working with pointers. Now this is a very, very advanced topic. Technically, if you know what you're doing, you can make some impressive stuff with unsafe code, but C# has a safety for a reason, so definitely only use this wisely. Then we're going to learn about asynchronous programming, specifically how to use async, await, and task. This is how you can have some code that takes some time, like for example, contacting a web server, and keep waiting for a response without blocking your program. This is extremely important in making sure your program feels nice and responsive. After that comes a super important advanced lecture. This one is all about multithreading. This is how you can take advantage of all the cores in the CPU to make them all do work at the exact same time. When done properly, you can get some insane performance improvements, but it is also very, very easy to make mistakes. So this one is very much the definition of an advanced topic where you must know exactly what you're doing. And yep, all of that concludes the advanced section of this course. As you can see, we're going to learn about a lot of very advanced, unique topics. Some of them you're going to use quite often, and some of those probably less often. But just by learning about them, learning that they exist, that will help you whenever you need to use them. And of course, remember how you can always come back to this course at any time. You'll really not expect to memorize all of this. Personally, I Google things all the time, and now actually I have this course in my own words. So anytime that I need to relearn some syntax, I'm really just going to rewatch the lecture to learn myself. So if in the future you want to re-remember something, like for example how async programming works, you can't just come back here and watch that lecture. Alright, so this is everything we're going to learn. So let's start learning some advanced topics with the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about reflection. This is a really interesting topic for how you can analyze and run code in a dynamic manner. So reflection is a name for a bunch of functions that you can run on the types themselves. Like for example, over here I've got an exercise class, and inside I defined a myFunction function. And yep, all this is valid code. Now up here, constructing an instance of exercise, and through that I can simply call my function, and yep, everything works. So no errors, all perfectly fine. This is the usual way for how you call some kind of function on some type. However, another way is using reflection. And the way we do that is first we access the type itself. So we do that using the typeof keyword, and then we use the class name. So in this case, I want to access the things on the exercise class. And then just by pressing dot, over here we can already see a bunch of really interesting functions. So get member, get interfaces, get nested type, get properties, and so on. So we've got all kinds of things. In this case, we're looking for a function. And again, technically the terminology in C# is a function is called a method. So it's called a get method. This one takes in a string for the name of the method that we're looking for. So in this case, we're looking for something called myFunction. So yep, just like this. And now this one is going to return an object of type method info. So method info. And this one, by the way, exists inside system.reflection. So let's add that using. So the method info for the myFunction method info. Okay, so basically now this contains the data that relates to this function. And now using this, we can invoke it. So we can call the invoke function. And this one takes in an object for the target. So in this case, let's use our created exercise. And then for the parameters, in this case, this function takes no parameters. So let's just put out an empty object array, just like this. And if that's it, this works. So let's just put a console.writeLine over here, just test it out. Test it out that we're calling myFunction. So we should be able to call it over here and also over here. So let's run. And if there it is, exactly like that, the function ran twice. So yep, here you have two very different methods of running the same code. And over here, you might be wondering, where exactly is this useful? I mean, just calling the function directly, that sounds much easier. Now, reflection is actually a topic that I myself had to learn quite a lot in order to make the interactive exercise for this course. For example, this exercise on the class lecture, the goal of the exercise is to define a player class. And basically, in order to test if the student has completed this exercise, the code needs to check that the class does exist. So for example, over here on this testing code, let's do the exact same thing. So let's assume the exercise, the goal over here is to define a player class defined inside of this one. Now, if it does exist, then obviously we can just access it. So we can just access the exercise type, that works. And if over here we define a public class player, if we do this, then yep, over here we can access player. And yep, so this does work, this is valid code. So we could do a typeof in order to find. So if this type is not null, if so, then yep, then the type has been defined. However, by using this code, remember how in the beginning of the exercise, the player class does not exist. So if I raise this as to what this would be on the state in the beginning of the exercise, if so, obviously this code does not compile because there's no such thing as a player class. Basically, we cannot write code assuming something is going to exist when in reality it does not exist just yet. So really the solution to this, and the solution for the validation logic for pretty much all exercises, the solution is to use reflection. Like I said, reflection is really just a name of various functions that work directly on the types. So for example, we can access just the exercise type, just like this. And then let's just do a dot. And now we can see a whole bunch of things. In this case, for this exercise, let's say we want to find a defined player class. So for that, we can use the function getNestedType. And this one takes a string of names. So let's look for a class named exactly player like this. Now we can indeed write this code, so there are no errors, because again, we're just using a string in order to identify the player class by the name itself. So this is valid code, we've got no compiler errors. And this function is going to return an object of type type. So we can do type player type, we can do this, and then we can do a console.writeLine if this one does exist. So let's just print out just the player type. So let's see this. And if there it is, it prints out nothing because there's no player type. But if over here we define it, so public class player, if we define it like this, and yep, now it does indeed find that class. So by using reflection, we can write some code that tests if something exists before that thing actually exists. Alternatively, instead of looking for a specific type, we could also use the other one, so typeof for the exercise, and we can call getNestedTypes. This one grabs all the types. It returns an array of types, so we can just do a simple for each on all of this, type, and all of these. We can look for them, and then let's just print out the type, all the types. So over here, if we've got the player, then some kind of unit class and some kind of enemy class and so on. So if we test this, we should be able to see all of them. And if there it is, we've got the first player over there, then player, unit, and enemy. So on pretty much all of the reflection functions, you always have one to look for a very specific thing or one to look for all of them. And also on both these functions, you also have all kinds of filters. So there's a function that takes some binding flags, and these binding flags are really just filters. The main ones that I used quite a lot in the exercise was looking for static things. So for example, on static, or for example, this one non-public. Because for example, if we don't assign this, and let's say we mark these as private, if we do it and we run this code, and if there it is, our cycle only found the player class because it is the only one that is marked as public. So in order to find things that are private, if so, we need to use the binding flags. In this case, to find that one, we need to look for non-public. And by the way, if you want to implement multiple filters together, if so, you just need to write a pipe. So that's just a single pipe. This is the bitwise OR operation. So do this, and then we can add another one, like for example, looking for static. So right now, since we defined the filter, this is only going to find things that are non-public or static. Meaning in this case, it will not find the player, but it will find both these. And let's just erase this just to not get confused, and let's test. And if there it is, it's done like that. Finds the unit and the enemy, but no player. So yep, you can use either of these methods in order to find a specific type somewhere. So for example, some kind of player type. Okay, we have it. So we have this player type right here. We can just test this one against null. If this one is not null, then the type does exist. And if it does exist, then again, like we saw previously, we can find and call some kind of function. So for example, over here, public void, call it my function. And then by using the player type, which by the way, another note, we can get the player type either like this, like we did, or also again, using the typeof keyword. This one returns a type. So basically player type or typeof. In this case, since exercise.player, since this one exists, we can do this. So basically both these have the exact same thing. Okay, so then using the type, we can call get method, and let's find our function. So let's find the my function. This one returns a method info, my function method info, and then we can invoke it as usual, except over here we need an object. So let me just do a new player. I'm going to talk about how you can dynamically create objects in a little bit. So over here, new exercise.player. And then this one has no parameters, so an object, an empty object array. And yep, so this is basically going to run this. So console.writeLine, and we can run my function, and we can see, and yep, exactly, it found the player and ran the function on the player. So yep, all this works. And again, over here, we don't have any direct calls over here to my function. If we select this and we find all references to this, nope, we do not find any references because the code is not being directly referenced. Instead, we're referencing only through reflection. Now, like I said over here, the second parameter, this one is for all of the parameters that this function takes. And just in case you don't remember, object, this is the base C# class. This is basically the base type that all of the C# types inherit from. So this can be anything. So for example, we can define a function with an int parameter, and then over here we can call it like this. So we can do this, and then print out that one, and let's see. And if it does work, my function and did receive that one. Although of course, we need to pass in the correct type. Since over here, this is an object, this has no limitations. So we could pass in, for example, a boolean, and there it is, we have an error. We passed in a boolean, which cannot be converted automatically into an int32, which is what the function expects. So even though this is of type object, obviously the types need to match whatever this function expects. And through the method info, we can get pretty much all the info for this function. So for example, through that one, we can get, for example, the return type, and this is going to return, over here in this case, it's going to return void. Or alternatively, we've got all kinds of things to get the parameters. This returns an array of parameter info, which again contains all the data for all the parameters. So the type, the name, and so on. Again, all of these are things that I use in making pretty much every interactive exercise. There are various exercises that require you to implement a specific function that returns a specific type with a specific number of parameters. So that's pretty much how all of that code works. If you want, you can actually inspect the code for the exercise completion. So you can start an exercise, like for example, this one on defining a player class. So the goal on this one is to define a player class and then define some functions inside of it. And in the project files over here, you can see inside the exercise folder, you see a bunch of files related to the exercise that you have enabled. So in this case, let's open up the exercise scene tester. And yep, over here, if we scroll down, we can see all kinds of reflection being used to make this exercise work. So for example, over here, it's going inside the exercise class and looking for the nested types in order to find the player class. And if it does find it, then it goes inside all the methods within that player class in order to find a say hello method. And if so, then basically, yep, the exercise is completed successfully. For another practical example, you can, for example, just look at the Visual Studio IntelliSense. So if we write some regular code like exercise.player and then put a dot. So for example, if over here we construct a brand new player. So we have a player and then we access the player and we do a dot. And yep, over here, this is basically using reflection. Visual Studio is going through the entire type over here behind the dot, and it shows all the fields, all the functions, and all the events related to that type. So using reflection, you could build something like IntelliSense. Another thing is how code in C# is grouped into assemblies. So for example, let's grab the type of our program type. So that's the default one up here. We can grab that one and grab the assembly. Let's just do a console.writeLine on this one. So let's just print this out and see. And if there it is, that is the name, that is the reference for our assembly. Which again, inside that assembly, that returns an assembly. So inside that one, you can then put a dot. It can get all the types, all the files, all the things, everything that exists within that assembly. Also, if you want to look for any types inside of an assembly, of course, as usual, you can cycle through the types and print them all. But if you're looking for a specific type, if so, then over here on the name, you need to write it exactly as the assembly writes it. So if we print to see what this one up top writes, yep, this one says CodeMonkey C# course, which is the namespace, then the program, so we're inside the program class, and then for example, the exercise class, and then the player class. Again, note the dots and the pluses. If I wanted to get the player type over here, if I were to just write exercise.player, so if instead of this, I just write this, so just exercise.player, if I do this, then nope, it does not find it. In order to find it, over here when you call getType, it needs to be called with the exact same full name, including the namespace. Including the namespace and also including over here the dots and the pluses. If we do this, then yep, now this one does find it. So one more thing is like I mentioned a while ago, which is dynamically creating objects of a certain type. So for example, over here, we constructed a brand new player and we use that to invoke the method. But again, if this code was written before the player class existed, then this would not be valid code. So we need to also dynamically create an object of that type. So over here, we have the player type that we dynamically grabbed. And now with this one, we can create it. And for that, we use the class called activator, exists inside of system. And then we call create instance. And then we can either pass in strings for the names, or if we already have access to the type, let's do that one. So let's just pass in the player type. And yep, this one is going to construct a brand new player object. This one is going to return of type object, because again, we're running this before, let's say, the player class is defined. So we need to use the generic object, so player object. But then again, over here on the invoke, this one also takes in an object for the target. So we can pass in the player object. And yep, so now this one is going to create an instance of our player type. So it's going to create a brand new player object. And then we're going to use that player object over here to invoke the function. So if we run this, and yep, everything works as usual. Now, yet another interesting thing about reflection is how you can bypass access modifiers. So for example, over here for this function, instead of making it public, let's make it private. So in this case, even if you have access to this code right now, if so, if we go inside exercise.player, if we construct a brand new player, and then we go inside player and try calling my function, and nope, this does not work, because again, like it says, this is inaccessible due to its protection level. So if you have a private function, you cannot call it, you cannot access it through regular code, that's the usual thing. However, you can still run it over here through reflection. So if we run this code, it still works. We just need to make sure we find the actual methods over here for the binding attributes. And we need to make sure to find the function. So over here when looking for it, since this one is private, let's make sure to add the binding flags for non-public. And also for this one, we also need to add the instance, because this is an instance function. So if we run like this, even though the function is private, yep, that one still ran the function. So by using reflection, you can run private or internal code. Now again, do keep it in mind, this is probably not something you should do in your own code. If you make something private, then you probably want it to actually be private. But for example, if you're making some kind of testing code, if you're doing test-driven development, if so, you probably still want to test your private functions. So if so, then reflection can be a use case for it. Or another example is when working with some APIs, like for example the Unity API, where some functions might be marked as private or internal. So in this case, where you cannot directly modify the code and you really need to call that function, if so, remember how you can do it through reflection. Related to that is also doing things like modding and plugins. You can allow your game to dynamically load a DLL at runtime and then use reflection to run the code inside that library. So that's reflection. It's a very interesting topic, definitely very niche in terms of use cases. Like I said, I really only had reason to learn about it right now in order to make the exercise for this course. So it's probably not something you're going to use regularly, but do remember that it exists. Remember how there is a way to dynamically run your code if you need to. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about function extensions or extension methods. This is a really interesting C# feature that allows you to extend classes without having to modify the code in that actual class. So usually if you have some kind of class, like for example over here I've got a myTransform, If you have it and you want to add some kind of function to it, usually you just modify the class and write the function inside of it. So for example, a public void move right, and then over here would take the position and increase to the right, something like this. Okay, so yep, that works. Here is the function. And up here, if we have something of type myTransform, if so, then we can go inside of this and we can indeed call the move right function. So yep, this works. This is perfectly valid code. We have modified the class to add our custom function and then we call the function. However, what happens if you can't modify it? Like for example, let's say I do want to implement this kind of move right function. However, instead of making it work with my custom myTransform type, instead of this, I want to work with the built-in Unity transform type. Now that type is sealed, I cannot modify it. So I can put transform for some kind of transform and we can try going to the definition. So here it is, except this class is compiled, meaning we do not have access to modify this. So the method of just writing the brand new function directly inside this class, this does not work because we cannot modify this class. So that's exactly where function extensions come in. Which again, remember how function and method are pretty much interchangeable names. So if you look in the C# docs, what we're talking about here is actually technically named extension methods. So extension methods or function extensions. This is basically how you can add extra functions to some kind of type without having to modify that actual type. We just need to follow a bunch of rules to make it work. The first thing we need is to be working on a static class. So let's make a static class. And then usually the naming rule is to name it something and then add extensions onto it. So in this case, we want to add some function extensions to the transform type. So let's call it transform extensions like this. That's the first rule. The second rule is the function needs to be defined as static and be public. So over here, a public static void, call it move right. And finally, the third rule, for this one over here inside the parameters, the very first parameter, this one needs to have the this keyword. It needs to have that and then be the parameter of the type that you want to extend. So in this case, we want to extend the transform type. So let's put it transform like this. And if that works, so this is now a valid function extension. And now inside of here, we can do our regular code. So for example, we can do exactly what we were doing. So let's go inside this transform and modify the position and do a new vector3 and just move it to the right. And if there it is, this is our function extension. And now up here, when we have access to a transform, like for example, the transform that this object is attached to, we can go through that one and we can call the function move right, and yep, it does work. And we can see over here, IntelliSense is telling us, yep, this is an extension function. So we can call this, and yep, this works perfectly. So we've got no errors. Basically, what is happening here is this keyword over here inside the function. This says that this first parameter is special. Basically, it assigns what it was called on and uses that over here on the first parameter. So basically, over here, this is doing the exact same thing as if we were to manually go inside the transform extensions, call the move right function, and pass in this transform. So both of these are doing the exact same code. The only difference is this one is much easier to use. So yep, as you can see, like this, we have added a brand new function onto this type, onto our transform, without having to modify the transform type itself, so we don't need any access to it. We just need to know the type, and we can write an extension, and then we can write some kind of code that works directly on that type. And of course, over here, after using this special parameter, so this parameter, this one has to be the first one, but afterwards you can add whatever you want. So let's say, for example, a float amount, and over here we modify this one by the amount. And then when calling it, we just pass in, for example, 3. And yep, this works. So we call the function extension, which is going to call this function. For the transform, it is going to use this one, and for the amount, it is going to use this one. And again, this works on any type. So over here, we are making a function extension that is extending the transform type. But for example, let's do another one. Again, we just need to make sure to mark it as static. And let's extend, say, the bool type. Let's make is true. This one returns this, bool. And for example, just return if the boolean is true. So yep, again, all the rules are being followed. It's inside a static class. The function is static and has this keyword. So now up here, bool, and we can set it to something. And then bool.isTrue. And yep, this does work. So yep, we can add function extensions to some custom types. Or we can add to built-in types, can be a boolean, can be an int, can be literally anything. All of this works so we can easily extend any type with any functions we want. This works for extending classes, but also works for extending value types, like we saw over here, the bool. So we can also extend structs, and this also works for extending interfaces. So if you want to add extra logic to a type, but either you cannot or don't want to modify the original type, that's where function extensions or extension methods come in. It's one of the best ways to make some helper utilities functions that you use a lot and make them super easy to use. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the static constructor. This is a really useful way to run some kind of initialization code where you can be perfectly certain that it will always run. Okay, so you're already familiar with the regular constructor. So we have the class and then we have a constructor, and this code is going to run whenever a new object of this type is constructed. So basically before you use this type at all, before you use any functions or fields, before that you can make sure that this code always runs. And static constructors are basically the same thing, but just in a static context. And the way that you define them is super simple. You just use the static keyword with no access modifier, so no public, no private. This cannot be either one of those. You cannot manually run a static constructor. It always runs automatically. And then it must have the same name as the class, so player. And it also must have no parameters, so a completely parameterless constructor. Also, you can only have a single static constructor, and it cannot be inherited or overloaded. So it has a ton of limitations, because like I said, this one runs automatically. So that is why we cannot have any parameters over here, because the compiler is going to run this automatically whenever we need to. And basically this will run either when an object of this type is created, so for example before the constructor, or also when any static data or any function is accessed. So for example, let's do a console.writeLine here, just to see when this runs. So the player static constructor. And if we run like this, so we have our player class, we've got the constructor, the static constructor, and up here we are just constructing a brand new player. If we run this code, if there it is, it ran first the static constructor and secondly ran the constructor. So the static constructor always runs before the object is constructed. Now let's say we have some kind of function, so a static void for some kind of test function. And over here, same thing, let's do a console.writeLine on our test function. Okay, and now up here, before we construct, let's go inside the player and call the test static function. Let's do it like this, so let's run. And if there it is, again, same thing. The static constructor ran, then the test function, and then the constructor. Also note how the static constructor only ran once, so when we construct an object, it did not run a second time. Or alternatively, if we have some kind of field, so a static int for some kind of int field. If we have this, and up here we read it, so let's do console.writeLine. Let's write line on the player.I, so our static field. So by default, if we don't assign any value, this is going to default into 0. So over here, if we set I equals something, let's see what this one is going to print. So is it going to print the 0 that is over here by default? Or is it first going to run this code and basically print 56? So let's test. And if there it is, exactly like that. So as soon as we access the static field, as soon as we do that, before it actually runs that code, it is going to run the static constructor. So first runs that one, then prints the value, which in this case was assigned the static constructor, and then again runs the function and the constructor. And same thing, the static constructor only ever runs once. Meaning that the static constructor, this is really excellent for doing any initialization logic that this particular class might require. One example is exactly this, is if you have a static field and you want to make sure to initialize with some data. If so, you have two options. So basically over here, when you define it, you can also assign it some value, or alternatively, you can assign it on the static constructor. Both are valid options, pretty much just like on a regular constructor. You can also have some kind of regular field. So you can have that one, and over here you can assign it some value, or inside the constructor you can assign it some value. So you've got these two options for non-static context, and you also have these two options for a static context. Now the static constructor, this one can also be very useful for debugging. You can basically place a log over here, and it will let you know when this class is used for the very first time. Whereas if you were to place the log only on the constructor itself, if so, then this would only run when an instance of this type is created. Whereas for the static constructor, that runs whenever any object is created, or when any static element, like a field or a function, when any of those are accessed. So the static constructor, this one guarantees that it always runs the very first time that this class is used in pretty much any way. It is also important to know how in the context of multi-threaded code, the static constructor is guaranteed to be thread safe, meaning if you have multiple threads and all of them try to access some kind of data inside of this class at the same time, if so, the .NET runtime ensures that this class is locked and make sure that the static constructor runs only once, no matter how many threads try to access it at the exact same time. So the static constructor is relatively simple to understand. Definitely use it whenever you need to ensure some initialization logic happens, and ensure that it happens in a static context and not just on a per object basis. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the typeof operator. This operator lets you get the type object of a certain type. Okay, so typeof. Now, we've actually already used this a few times in the reflection lecture and also on the one on typecasting. The way we do reflection is by accessing the type, and I don't mean by accessing the type name itself. So if we call just player, if we do this, nope, we are not accessing the type itself. This is not valid code. In order to access the type object, meaning the object of type system.type, the way we get that is with the typeof operator, which works sort of like a function. So we write typeof, then parentheses, and then the type within it. And if we do, then we can see that this does now return an object of type system.type. Like it says here, this represents type declaration, so class types, interfaces, arrays, values, enumerations, and so on. So this is the base type that references pretty much any type you can create. So now with this type object, then over here you can do all kinds of things. So you can get nested types, nested functions, and so on. So this is how you access the reflection that we already covered. Whenever you have some kind of function that requires a type object, meaning system.type, if so, then this is what you want to use. Like for example, when working with some Unity code, if you want to get the component attached to some kind of game object, you use the getComponent function. And this one actually has two versions. One of them is this one with the angle brackets, meaning this one is using generics. This is actually the version that I normally tend to use. So just put this, and then inside you put the type that you want to get. So just like this, it's going to get the component of type player. However, alternatively, you can also use the other version. So this one over here, which is non-generic, and note how instead of having a generic parameter, this one receives a parameter of type. So this is where you would use it. If you were to use this and you just type in player, if you do just this, then nope, this is not valid code. Again, that's the difference between having an object of type player as opposed to accessing the type directly. So in order to make this work, in order to use a function that receives a parameter of type, for this one we use typeof, and yep, now this does return the correct thing, and this will return a component of type player. This is the one thing that you definitely need to remember. This is something that drove me crazy for a long time until I finally memorized it. Whenever you see something that takes a type parameter, whenever you see that, always remember you have to use the typeof. Because yeah, for me it has happened many times where I see a function like this, I try to use it like this, and I have no idea what is wrong. And the reason that is wrong is exactly that. We need to do typeof in order to get the object of type, and now this does work. Or alternatively, like we saw on the lecture on typecasting, you can, for example, create an object of that type. So for example, making a brand new player. And another way to get the type of type player, if you have an instance of that type, you can just call the function getType, and yep, this is going to return the exact same thing. So if you have an object of a certain type, you can call getType, and if you don't, you can do typeof and then pass in the class name itself. So yep, that's typeof. It's very useful when you need to get the type object to use in some kind of code. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the nameof operator. With this one, you can get the string name of a certain type or field or function. Okay, so nameof. This is an operator, meaning you use it sort of like a function, so it's similar to the typeof that we already saw. So you write nameof, and then inside parentheses, you put the name of something that you want to get the name of. Now, the main benefit of this operator is to avoid using strings, which is something that I always highly advise you to do. You should never use strings to identify something. So if you want to reference the player class, if so, do not type a string just saying player. So don't do this, instead do something like this. So player class name, you do nameof of the player class. So instead of using hard-coded strings, use nameof to avoid using strings directly in your code. This also helps avoid issues with refactoring. So if you have a hard-coded string kind of like this one, if you do this and you refactor, so instead of player, let's call this just a general unit. If so, then yep, now this literal string, this is now completely wrong. Whereas with nameof, if you modify the name inside of here, the name of the actual type itself, if so, then what returns from this is going to be updated. Now, this works for classes, but also for fields and functions. So for example, let's actually do a log, just see what this says. So let's do a console.writeLine. Let's print out this one to see what this says. And let's also rename this back into player. Okay, let's test. And if that's it says literally player. This gets just the string name for the class. Whereas, for example, if you do typeof in order to get the player type, and then you convert that one automatically into a string. Let's see what this says. And if you get the type, then you get the whole thing in order to get to the type. Whereas with nameof, you get just the name of that class, that type, that something. So this works with types itself, like these, but it also works for fields and functions. So we can do this, print out the player speed, and print out is grounded. And if we run this, and yep, this returns exactly the name of those elements. So it can work with classes, with fields, with functions, and pretty much anything. One thing this is great for is, for example, for debugging. So for example, if you want to validate some kind of function, so over here, let's say a public void set speed in order to set the player speed. This one, let's receive an int for the speed, and then set this.speed equals this kind of speed. However, for debugging, for some kind of validation, we can add some extra logic here. We can say, for example, if speed equals 0, If it is, let's say this is an invalid value. So if so, let's do a console.writeLine. Let's print out to the console error. And then instead of hard coding saying speed must not be 0, instead of hard coding this, because again, if we were to modify this for the something like set speed and so on, if we were to modify it to something, then a hard-coded string would not update. Whereas if we have the name of here, so name of and pass in this speed parameter, so this parameter name, if we do this, yep, now this will indeed work. So up here, let's create a brand new player and call player.setSpeed, and let's set it to 0. And if there it is now, that is correct. So error speed must not be 0. And if we were to refactor this, so speed to set, if we do this, and yep, now it correctly sets the parameter name exactly as it should be. So this can be really great for making your documentation a little bit more robust. Again, anytime you can avoid using hard-coded strings, that is always a better approach. And technically, this one also has a nice performance bonus. For example, if you already have a player, you can technically go and call getType, and then for the type, you can just access the name. So this works, and this will pretty much print out the exact same thing as here. So let's actually do that. So console.writeLine. And if there it is, this one prints out player exactly the same. So the one performance bonus is if you do this, if you access the object, you get the type and you get the name, or alternatively, you would just do typeof of the player type and then grab the name. Doing that, that code would actually run at runtime, whereas over here, the name of, this one is executed at compile time, meaning that when the code goes to compile this code, when it does that, the compiler replaces this line of code over here with a literal string. So as soon as you compile, instead of this code being right here, it will replace it with exactly this. So this is a tiny change, but still a nice bonus. So it's a tiny bit more performant. Alright, so that's name of. If you ever need to get the string name of a class or field or function or anything, then use this instead of hard coding a string. This makes your code more maintainable and less error prone. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the sizeof operator. This one lets you see the size in bytes that are used in memory to store a certain type. Okay, so let's see the sizeof operator. Now this one returns the value in bytes of a certain type. Like for example, we know that ints are stored in 4 bytes, so if we have an int I, we know this is going to take 4 bytes. And we can test that. Let's do a console.writeLine, and let's print out the size of. This is an operator, so we use it kind of like a function, so kind of like the typeof and nameof. And this one takes in the type, so let's put in int, and let's see. And it picks out like that, 4 bytes. So we can see the size of an int. We can also see, for example, the size of a boolean. And yep, a boolean is only true or false, so this one only takes 1 byte. Or for example, let's see a ushort, which is a much smaller version of storing whole numbers. And yep, this one, unlike the int, this one takes just 2 bytes. Or on the other hand, we can see, for example, a long. And yep, a long takes 8 bytes. So yep, basically this one lets you see how many bytes a certain type occupies. Now this is extremely important for memory management. Memory management becomes really important when you're working with some very memory limited devices. Like for example, if you're doing something on some very old mobile devices, or maybe some IoT or embedded devices, or perhaps if you're syncing data in a multiplayer game. If so, usually you want to limit how many bytes you send over the network as much as possible. The less you send, the less it's going to cost in terms of bandwidth. So knowing that a ushort is much smaller than an int, that can be very helpful if the number you are trying to send across the network can fit within a ushort. Or it's also useful if you're doing some specific low-level memory management where you need to allocate some unmanaged memory manually. This way you know that, for example, if you have 4 ints, you know how big that will be in memory. So as we saw, you can see the size of all of the built-in types, so int, bool, short, and so on. This way, if you have to store, let's say, 1000 ints, you know exactly how big that will be in memory. However, you cannot use sizeof on classes. So for example, if I put here of the type player, nope, this one does not work. So we cannot use sizeof in class like it says here. Player does not have a predefined size, therefore sizeof can only be used in an unsafe context. Now there is a lecture in the advanced section later on using unsafe. This basically removes all kinds of protection that C# has by default. So that's one option is you would use unsafe and then put this inside an unsafe. And if this would indeed work, you just need to enable unsafe compilation. Or alternatively, if you need to know the size of some kind of class, for that, you can go inside the Marshall class, which exists inside this namespace, system runtime interrupt services. And inside you do have a size of, although this one has a bunch of strange limitations that honestly I'm not very familiar with. I'm definitely not an expert when it comes to marshalling data, dealing with bytes and all of that stuff. But over here, if we don't include this attribute, then this throws this error. It says cannot be marshaled as an unmanaged structure. No meaningful size or offset can be computed. And with that attribute, it does work, it does store it in 4 bytes. But then if I were to add something like a public list of ints for some kind of int list, if you do, then yep, that shows that same error again. So honestly, I'm not entirely sure how to make all of this work. I believe you have to use the marshal as and then marshalling this field as some kind of unmanaged type, and then you have to select the one that is related to whatever type you're trying to marshal. But like I said, I'm not an expert in marshalling, so I'm really not entirely sure how this whole thing works. But basically you can use the standard sizeof to get the size of any of the built-in types. And then for classes, either use marshal.sizeof or put it inside an unsafe context. And for structs, this one also works. So you can do marshal.sizeof of some kind of struct that has some kind of data. Again, it can't have any kind of managed data like a list. But if we do them like this, give this print, the size of that struct is 8 bytes, which makes sense since it has. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the default operator. This one is really useful for when you want to assign a value to initialize something, but without giving it a specific value. Okay, so default. Now we've actually already used this keyword in 2 scenarios. So for example, we use it in some kind of switch. So you define something, do a switch on that something, and then do all kinds of cases. So case some kind of number, run this code. And if not, if it does not match any, then run the default case. So basically this is the code I will run if the value does not match any of the other cases. And the other scenario where we've also seen the default being used, for that was on the lecture on the optional function parameters. So if we have some kind of function, public void set speed, and this one receives an int for the speed, and if we want to make this an optional parameter, if so, we just have to do equals and then default it to some kind of value. So you can default it to a fixed value, or you can use default, the default keyword, which will return the 0 equivalent value for that type. Now there are actually 2 ways to use default, the shorthand and the normal way. Now the normal way is using the operator default, kind of like a function. So we do default, and then for example, we pass in the type, so let's say int. Let's do a console.writeLine on this to see what this says. Yep, there it is, 0. Like I said, default will return the 0 equivalent value of that type. So in the case of an int, the 0 of an int is indeed just 0. However, if we try to see the 0 equivalent of a boolean, yep, this one prints false. In booleans, you have either true or false, where true is usually equal to 1 and false is equal to 0. So for the 0 equivalent, it returns false. And then for class types, like for example, a player class, for that class types, the default is going to be null. Remember the lecture on value types versus reference types? Value types always have to have a value. So when we do a default on something like an int, which is a value type, when we do that, we have to get a value. But references, like the player class, these can simply have a reference that points to nothing, meaning null, so default of any kind of reference type is going to be null. Now this is the quote-unquote normal way of using default. Use it as an operator with parentheses and then put the type inside of it. However, another way is just to let the compiler infer the type. For example, if we just define a float variable, if we do this, and then for assigning, we just assign it to the keyword default. And yep, that's it, no parentheses with float, just like this. And yep, this does work. So if we print out df, and if there it is, a float does default to 0, which is actually the exact same thing we are doing down here on the optional function. So we can just write default, or we can write default int, and yep, both these work exactly the same. Now, another place where default is very useful is when working with generics. So for example, if we have some kind of class for some kind of box, and this box stores an object of type t, then over here, let's do a public going to return t, and let's call it getDefault. So on this function, we want to return the default value that is stored inside of this box. Now, by being generic, that means we don't know what type t will be. Maybe it's going to be an int, or maybe a bool, maybe a player, we really don't know. So over here on this function to get default, we can't really just return 0, because again, t might be something like a player, and you cannot convert a player onto a 0. It can also not be false, it cannot be null, and so on. So in this, if we want to return some kind of default value, again, we can just use the default keyword, either with the shorthand or default t for the longhand. And yep, so now if we create a box of int, bool, and player, so for example up here, let's do a console.writeLine, let's do a writeLine, let's create a new box, let's do a box of ints, and then let's call the getDefault. Let's see what this prints. Let's create a box of ints, then a box of bools, and finally a box of player. Okay, let's see these 3 boxes. And if there it is, 0, false, and then null. So the same code now returns different default values depending on what generic type we use. Or alternatively, when using the ref and out keywords, I'm going to cover these in detail in a future lecture over here on the advanced section. If we were to do an out bool is set, something like this. Basically, the out keyword means that this parameter is an output parameter and must be set before the function ends. So again, for these, if you want, you can define some kind of default value. You can default to that, or you can just use the default keyword. So if you ever need a default value for something, instead of hard coding some value, you can just use the default keyword. It will use the 0 equivalent value of that type. Usually that is either the number 0 or false or null. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about expression bodied members. This is a way for you to write C# code in an extremely compact manner without having to sacrifice readability. Okay, so expression bodied members. Like I said, this is a very compact way of writing some code. For example, if I have some kind of player class and inside I have some kind of player name, and then I have a function that returns the player name, so get player name. So I can do this and then simply just return the player name. And if that's it, a very simple function. This is the regular normal C# code. However, we can make this quite a bit more compact by using expression bodied members. Basically, if you are familiar with the lambda anonymous functions, then this is basically the same syntax. So we define the function, and then instead of opening a code block, instead of that, we do a little arrow, and then we just put what we want to return. So in this case, just player name, just like this. So if that's it, this is the whole syntax, super simple. So basically this and what we had previously, both are doing the exact same thing. The compiler basically sees that this function returns a string, so it automatically adds a kind of return statement here. So this one does do the same as the other version, it just returns the player name. Now this method, expression body members, this is really only meant for extremely tiny pieces of code. In fact, you can't even do a code block with this syntax. So if I try opening and closing a code block, nope, this is not valid code. You cannot do a code block with this syntax, which means that this feature can really only work with single instructions. You cannot use this on things that require multiple instructions. You can use it like this in order to return some data from a function, but you can also use it to set some data. So for example, a set player name and receives a string for the player name, and we can do the little arrow and set this dot player name equals this player name. And yep, there you go, another perfectly valid function. Again, with some limitations, this one can only have a single instruction. So if you need to do multiple things, you do still need to use the regular normal C# code block. But for super simple things like just getting and just setting, then this makes the code quite a bit more compact. In fact, one place where I've used this quite a few times is for function pass-throughs. Like for example, if you have some kind of class, and that class is really just meant to be a layer of abstraction for another class. For example, when I made a turn-based strategy game, I had some kind of level class, and inside that one, I was using the actual underlying grid system. And for some functions, I really just wanted to pass that function call onto the underlying grid system. So for this use case, this super compact function pass-through, this is a really great option. So here we can see how this works for functions, but it can also work for properties. So for example, if we have a public string player name, just a regular property, if so, we can do the get, and now normally we would write a code block. However, we can do the same thing, just a little arrow, and in this case return player name. So this is a read-only property, or we can also assign the set player name equals value. Yep, this is also valid code. Or you can actually also use it in a constructor. So if we have public player, define a constructor with some kind of string for the player name that receives on the constructor. So here we can do the little arrow, player name equals player name. And yep, this is a valid constructor code. However, again, the same limitation. This only works if the constructor has just one instruction. So for example, if over here we had two fields like vector3 for the position, if so, we couldn't set the player name and then set the position on the same line of code. So expression bodied members are really good for making some really compact code, but as always, you should never sacrifice readability for compactness. So personally, I really like how this has a whole bunch of limitations, which means that it can really only ever be used in situations where it should be used. If you have some extremely simple get and set functions, then this can be quite useful without having to sacrifice any readability. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about C# records. This is a super simple way to create immutable types to organize your data. Okay, so records. The basic usage is actually incredibly simple. So first you write the access modifier, like let's say public, then we write the record keyword, and then some kind of name for this type, like let's say person, and then we open the parentheses, and we write our parameters. So for example, something like first name and last name. And yep, that's it. Just with this, we have created our person record. So as you can see, if you need to organize some data, it can be similar to just define a simple record as opposed to defining a whole class. So for example, something like this, so person class. If we had this, we would then have two properties, so one for the first name with a get and a init, meaning needs to be initialized, and same thing for the last name. So yep, basically over here, we have the exact same thing written twice. We have two pieces of data, which in the case of records, the underlying compiler, these are actually auto-implemented properties, and they are also immutable, meaning they only have a get and have no set, and also they need to be initialized. So yep, this super simple record is exactly the same thing as this. You can see how this is quite a bit easier to write whenever you need some kind of structure to hold some data. And then to construct a brand new person, you really just find person, and then you can do new person, or really just open up the new like this, and then pass in all the parameters. So in this case, let's say code monkey. And if that's it, here is our brand new person. So we easily defined in just one line of code and easily created in this one. Then with this, let's do a console.writeLine in order to see person what this says. And if there it is, the toString automatically writes out the actual type, so person, and then all of the parameters and all the data they have. So yep, this is how simple records are. And now by default, records are indeed like this, meaning they are immutable, they have no set, they cannot change. Here, if we try creating a brand new person and then go inside the first name and modify it to something else, nope, this does not work. This one can only be set once it is initialized, it cannot be modified afterwards. However, if you really need to, technically you can make it mutable. You just need to define the record, and then instead of doing a semicolon, you just open a code block. And now inside you can define all the properties, so for example, first name. And on this one, let's put it with a get and with a set in order to make it mutable. And we just have to do equals first name in order to make sure that the value that it receives over here is the same one that is set to this property. So yep, like this, if we now do a person and go inside person and modify the first name to something else, yep, now this is indeed valid code. However, records really are primarily meant to handle immutable data, so you really should avoid doing this unless absolutely necessary. The fact that they are immutable is indeed part of the purpose. Immutability is really great for handling static data, especially when working with things like multi-threaded code. If you have multiple threads, all of them accessing an object that is mutable, it can cause all kinds of strange issues, all kinds of race conditions when multiple threads try to write to the same field at the same time. Whereas if a field is marked as immutable, meaning that data can only be read, that eliminates all those issues. Now if you want, you can also do something that is called non-destructive mutation, which really just means creating a brand new record based off another record. So for example, over here we can do person, call it person2, and we can start from data contained inside person, and then use the keyword with, then open some curly brackets, and now here overwrite any of these. So for example, let's say last name, set it to gorilla. And yep, just like this, so now we have person and we have person2. And yep, there it is, the first one code monkey, second one code gorilla. Now this is technically called non-destructive mutation because in reality it doesn't really mutate the original data. This one still stores the exact same thing, basically just creates a brand new one using the parameters from the previous one. Also over here we are really just using the record keyword. But what this is really doing is really the same thing as writing record class. So by default, records are going to be classes. However, if you want, you can also make it a record struct. Yep, this also works. So your records can be either classes or structs. However, in terms of equality, they mostly behave like structs. They mostly behave like value types. Meaning if we make this a record class, and up here, let's create two persons. So let's call it and person3. So here we're doing new twice, so technically these are two objects. So if person was a class, these two would be different because they are different objects. However, if we do a console.writeLine, if we do that and we check person equals person3, if we check this, yep, this one does return true. Now in a normal class, if this were a normal class, this would return false because these two are technically separate objects. However, since this is a record class, because that, the equality behaves more like struct, meaning it checks the underlying values for the equality. Again, this is because records are really primarily meant to be used for data organization, so the equality logic is all made based on that. Then if you want, you can also handle inheritance with records. So for example, we can do a public record, let's call it unit, and inside let's do some kind of float for some kind of speed, and then we can have a public record for some kind of player. This one receives a string for a player name and also a float for a speed, and this one then extends unit, and for the parameter, it passes in the same speed parameter. Yep, that's it, this is valid code. Also, one more note, technically records were only introduced in C# 10, and Unity is actually currently on C# 9. However, it does support records, but in order to make it work, it requires a slight workaround. So here I have some Unity code, and if I define, let's say some kind of record for a player, receives a string for the player name. So this is a record. However, if we do, we see this error. So predefined type system.runtime.compilerservices.isExternalInit is not defined or imported. So in order to make this work, in order to make records work inside of Unity, for that we basically need to create this type. So we need to put it inside of this namespace. So we need to create a class inside of a namespace. So let's do a namespace and name it like this, exactly like this. So system.runtime.compilerservices. Let's open and close. And then inside we need to define a class. And the class has to have this exact name. So isExternalInit. And define a class just like this. So it's all completely empty. It really just needs to exist. And if it does exist, then yep, this is now valid code. All right, so records are an interesting way to very quickly define a type to hold some data. Instead of defining an entire class or a struct, you can very quickly define a record and have it with the perfect accessibility for some immutable data. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about non-conditional operators. These are two operators that help simplify your code by eliminating the need to do some null checks. Now, this is actually something that we already used in the events lecture. If you remember, for events, before you invoke the event, before that you need to test whether the event is null or not. Otherwise, it will throw a null reference exception if there are no listeners. And the compact way that I showed you for doing a null check is with this question mark. This is what is called a non-conditional operator. And basically, the code is executed from left to right. So when the code reaches the question mark, at that point it checks the left side. If this left side is null, if so, then this instruction terminates right here and just moves on to the next one. However, if the left side is not null, then it continues executing onto the right side as if this question mark was not here. So basically the question mark, this does a null check at this point. And on the right side, you can write any code with the safe assumption that the thing on the left side is not null. Also, when I say that the instruction terminates here if it is null, what that means is that this whole thing gets evaluated into null. So for example, up here, if we do a console.writeLine, let's do a function to print something. So a public string, get player name, and let's just return a string. So something like this. And up here, let's just construct a player. So player, and actually let's leave it in null. And now we do player, then the question mark, and then get player name. So if player is set, if so, then it's going to return the player name. But if the player is not set, then this whole thing is going to evaluate into null. So if we run this, if there we go, it's empty, meaning that it's actually null. So we can test and verify equals null. And if that is indeed true, so if the left side is null, then this whole thing evaluates into null. Whereas if this one is not null, so over here, let's just construct a brand new player. So this one is not null. If so, then yep, it runs the entire thing and calls the function. And by the way, like we saw here, you can call any function after the question mark. So the standard that I showed you for the events is using .invoke, but that's just a event-specific thing. However, the question mark, the non-conditional operator, this one is not limited to just events. So as you can see, it works over here for the get player name and also works for fields. So over here, if we have a string player name, if we have this, and up here we can call the same thing, dot player name, yep, just like this. So basically, it's only going to access this field if the left side is not null. And also, you can have multiple of these in a single line. You can chain them together. So for example, if the player, if over here it had some kind of player for another target, if so, then you could do player question mark in order to make sure it only runs if not null, target, another question mark to make sure that it runs if it is not null, and then call take damage. Over here, pretty much the same rules apply. So basically, as it gets to this question mark, it checks the player. If the player is null, then it terminates the whole thing with null. But if it is not null, continues running the right side, and then it gets to this question mark and checks the left side. So if the player.target, if that one is null, if so, then again, it terminates over there. But if it is not null, then it's going to call take damage on the player.target. So the same rules always apply regardless of how many non-conditional checks you have. Now the second non-conditional operator is pretty much the same, except it's for index accessing. So for example, if we have a list of strings for some kind of player name list, if we have this, we can do, for example, player name list, do a question mark, and then the square brackets to access on some kind of index like this. So let's do a console.writeLine on this. And here the same thing will happen. So if the list is set to null, if so, then when it gets to here, it's going to stop evaluating. Whereas if this one is not null, so if it has something like, for example, let's say just one element, if so, then yep, it is going to go inside the list and grab it on this index. Like this does print CodeMonkey. And of course, you can combine both of them. So you can combine the one accessing strings and the one just accessing properties and fields. So instead of a list of player names, let's do over here a list of type player. So player list, and we have a new one. And over here, let's construct a brand new player. So now on this, we can go inside the player list. We can do the question mark and then the index, access on index 0, then do another question mark and call some kind of take damage function. So it checks the player list. If it is not null, continues running to the right side. It checks the one on index 0. If it is not null, continues running to the right side and runs the take damage function. So if over here, this element on 0, if this one is null, then it would safely stop the execution right here. However, this will still throw an error if the index 0 is out of range, so do be aware of that. And since the home point of this whole operator is doing null check, it can only work on nullable types like reference types. So if we put, for example, int I and set this something, then I question mark dot compare to, nope, this is not valid. The question mark operator, so the non-conditional operator, this one cannot be applied to an int. Again, that's because int is a value type, so it cannot be null. However, if we make this into a nullable, so we add the little question mark, if so, then this does now work. So we can call toString, yep, this works. If you don't know this syntax, this is Nullables, and I'm going to cover Nullables in a lecture later on in this advanced section. Alright, so that's the two non-conditional operators. Quite useful for very easily doing some null checks, and especially useful for making your event invocation much more compact without sacrificing readability. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the null coalescing operators. These two will let you easily test for null and return a value, or test for null and do some logic. Okay, so the null coalescing operator. Now this one is defined by two question marks, and the simple use case is for testing if something is null, and if so, returning some kind of value. So for example, here we have some kind of string player name, and then we've got a function to get the length of a certain string. This one receives the string as the parameter and just returns the string.length. And then over here, we're trying to get the player name length by passing in the player name onto that one and then printing it out. However, if we run the code like this, without assigning the player name to anything, if there you go, naturally we have a null reference exception. If we don't assign any value to a string, then that one is going to be null. So over here, we can add some kind of a null check. So let's find the player name, then if player name, if it is null, if so, let's put this one equals get the string length and pass in just an empty string. If not, then let's assign the player name length equals our string length. So we do a null check, and depending on that, we get one or the other. So let's see. And if now it does work, so without assigning an actual player name, just return 0. So no more errors. This code is working, and we can do exactly the same thing, but in a more compact manner using the null coalescing operator. The way you use it is, for example, by writing the player name, then two question marks, and then basically here we want whatever this is going to evaluate to if player name is null. So for example, we can do this, meaning that this will either evaluate to player name or an empty string. So if we use this instead and put it over here and just have one of these, yep, just like this. So basically this one, this instruction here, what it does is it evaluates the left side, left to the question marks. And if this one is not null, then this whole thing is going to evaluate to just this value. However, if the left side is null, then this whole thing is going to evaluate to whatever it is on the right side. So basically, if player name is not null, then it's going to call getStringLength to the player name. But if player name is null, then it's going to call getStringLength with an empty string. So now if we test, and if there we go, no errors, and it does return 0. And now if we give the player name something, so let's say CodeMonkey, and if now the exact same code also tests for the null check and now gives me the actual length of the actual string. So here we are doing exactly the same thing we were doing previously with the null checks, but in a much more compact manner. And I can also link multiple of these together. For example, let's define here a string for a default player name, and let's assign it to something. Then over here we can do player name, double question mark, default player name, double question mark, and 0. So you can chain multiple of these together. If we run this code, there you go, it does return 7, which is exactly the length of this string. So basically this is going to execute from left to right. So if this one is not null, then returns this one. But if this one is null, then goes to the next one. And if this one is not null, then returns this one. However, if this one is null and this one is null, then returns this one. So this operator is really useful for very quickly doing a null check and returning a non-null value. Instead of doing if-else testing for null, you can just write this and everything works perfectly. By the way, on the right side, instead of just returning a value, you can also run some logic. So for example, if player name is null, you can throw a custom exception with a custom message. Now the second operator, that one is the null coalescing assignment operator. In terms of syntax, it's exactly the same with double question marks. The only difference is that it has an equals at the end. So for example, if we have some kind of player class and a player field, if we try running some code on the player here, let's just do a player.toString, so let's do a console.writeLine on this. If you do this, then naturally this one will throw a null reference exception because player is indeed null. So as a way of doing some kind of initialization, we can write player, then double question marks equals, and then new player. Basically what this does is it's going to check the player variable. If that one is not null, then nothing happens, just continues executing the code afterwards. However, if player is null, if so, then it's going to construct a brand new player and assign it back onto this variable. So this operator can be really great for initialization. Like for example, let's say the player down here has a list of other players to target. And now usually if you have this kind of thing, you can either initialize this list directly on the constructor. That means that the list will be constructed as soon as the player is spawned. However, you can only initialize it when an enemy is added. So if you have a public void add target player, this one receives a player for the target player. And now here, if you just go player target list and add the target player, if you do this, then naturally this is going to throw a null reference exception because this one does not exist. So before this, you can do double question mark equals new list to initialize the list. So basically, if the left side is already initialized, if this one is not null, then this line of code is going to do nothing. But if the left side, if the list is indeed null, if so, then it's going to evaluate the right side, which is going to construct a brand new list and assign it. So this operator is great for initialization, or really just any kind of null check where you want to run some code only if the left side is null. Also, what we covered in the previous lecture, the non-conditional operator. Like I said, that one returns null if the left side is null. So for example, we can do player then question mark in order to make sure we run the code on the right side only if it's not null, then call some kind of function like getPlayerName, and then have double question marks and say unknown player. So basically what this is doing is if the player is not null, then it's going to go inside the player object and call getPlayerName is going to return that. However, if the player is null, if so, then this whole thing is going to evaluate into null, and then we have a null, then double question mark and something, so it's basically going to return this one. So if player is null, it's going to return unknown player, but if it is not null, then it's going to return the player name. And by the way, since the whole point of this entire operator, since the point is to do a null check, naturally it can only work on nullable types, like reference types. So if we define an int, if we do this, then naturally this does not work. Whatever's on the left side has to be a nullable type. However, if we make this instead of a regular int into a nullable int, if so, then yep, now this code does indeed work. I'm going to cover nullables in a lecture later on in the advanced section, but basically they allow you to make any type like a bare bones int and make it into nullable. So that's the two non-coalescing operators, another very compact way of doing a null check, in this case to return some value or do some logic if something is indeed null. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about the ternary conditional operator. This is how you can write some super simple if-else statements in a really compact manner. Okay, so this is another simple way to write more compact code. Here I have a function with a regular normal if. It's called getPlayerStateString, just as an if the health is above 0, if so, then it returns an alive string, if not, returns a dead string. So yep, like this, if the player has 100 health, if it works, the player is alive, and if over here set it to 0, and if it works, the player is dead. So this code works. However, a much more compact way to write literally the exact same thing is like this. We just write the condition without the if keyword, so in this case, health above 0. Then we write a single question mark, and then whatever we want to return if the condition is true, so in this case we want to return the alive string, and then we write a colon, and then what we want to return if the condition is false, so in this case we return dead. So you can do this whole thing and then just return it. Basically this entire thing, this is going to evaluate into this code if this condition is true, or this code if this condition is false. Which literally means that over here in just this one line of code we have the exact same logic we have down here. So it really is this simple. Anytime you want to do a super simple if-else, then you can just use this. It is more compact while also being very readable. Now, technically, you can also use it to run some logic. So you write the same thing, and then on the right side, instead of just a normal value, you can run some kind of function with some kind of logic. So technically, this is valid. However, you have to make sure to either assign it to something or return something, because otherwise, like this is not a valid assignment, not a valid instruction. So technically, just to demonstrate how you can run some more custom logic like call a function directly inside of this format. However, for this usage, I would say this is maybe sacrificing a little bit of readability. So personally, I would really not use this. I really only ever use the ternary conditional operator for super simple if-else statements just like this one. And for these, yep, the ternary conditional operator is definitely an excellent way of making them really nice and really compact. So if you can use them without sacrificing readability, definitely go ahead and use them. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about the main function in a C# program and how to receive command line arguments. This is very important to know when making normal console apps, doing things that do not have a UI. By using command line arguments, you can still control what exactly you want your program to do. Okay, so we've already been using console apps a lot in this course. It's the easiest way to write and run some C# code. We just make a console app project and we end up pretty much with this code. Then if we run this, yep, there you go, there's our super basic console app. Now, by default, it creates this main function. This is our program's entry point, meaning as soon as the program starts running, it will automatically call this function and start running it line by line. It continues doing that until this function terminates, at which point the entire program ends. By the way, in case you're wondering, so how do game engines work if the entry point is just a normal function that runs line by line and eventually terminates? If that's the case, how does a game engine run logic on every single update? And the answer is actually quite simple. So game engines, or really any program that lives for more than just the duration of whatever it is doing, usually they have some kind of while loop. So up here, while, either while true do something, and if so, then update some kind of update function. Then when the player presses the quit button, at some point it just breaks out of this cycle, which then terminates this one and terminates the entire program. So it can obviously be more complex than that, but that's the general gist of it. All programs have a single entry point, and then if you want, inside that entry point you can have code that runs constantly non-stop, and at some point the function ends and the program terminates. So main, this is the starting point, and it actually has some very specific requirements. The main one being how it has to be named exactly main. It cannot be called something else. It cannot be called start, or even something like main with lowercase. If we do this and we try run, nope, it does not run, we have an error. Here in the error we can see the program does not contain a static main method suitable for an entry point. So the starting main function needs to be named exactly main, exactly like this. Then another very important requirement is how it has to be static. You cannot make this non-static. If we do, yep, there you go, same error again. Main has to be a static function, and that makes perfect sense. So the reason why it has to be static is because when the program first starts, at that beginning you have no objects. There's no instances of anything. So you can't really start by calling a non-static method inside an object because no objects exist. So that is why main has to be static, so that it can be called in the very beginning of the program when no object exists. Then this function also has to be inside some kind of class or struct, and that one can either be static or non-static, both of them work. Main can also have an access modifier. You can make this either private or public, doesn't really matter. Next, for the return type, for this one it can take many forms. So first one is like this, it can simply be void, meaning we don't need to return anything. Or if we want, we can return something, and when we do, then it simply won't execute any more code. So it can either manually return or just let the function end normally. Alternatively, we can make this return an int. Usually this is done if you want to return some kind of exit code from your program. And usually if you return an int, returning 0 usually means success, means the program ran correctly, so there were no problems. And if not, if something went wrong, then you want to return some kind of number that refers to some kind of error code. And the other two options for return types are task or task with a generic. This has to do with asynchronous programming. It's how you can have your program execute some logic without blocking the main thread. I cover asynchronous programming in the lecture on async and await if you want to learn more on that particular topic. So here, just know that main can return tasks, it can be async, but in most cases you are probably going to do either void or int. And if you do return int and you return some kind of value here, you might be asking, so if the main function returns something, how exactly do we know what this returns? If we test the code like this, here at top we don't see anything, but here on default console, at the end it says this message, it says our executable exited with code 56, which is exactly the number that we set. Alternatively, we can also execute our program manually. So here I've got the command prompt opened, and over here we can execute the program manually. So just run the executable, and yep, it does say hello world, but we don't see any return code. Now for that, it is actually stored in an environment variable. To access an environment variable, we use the percentage symbol. Then it is named error level, another percentage symbol. So if we want to print this, let's just do an echo on this. And yep, there it is, 56. So whatever value you return from here, you can access this one in order to get exactly what is the error code. So that's the main return, so either void or int, that's usually what you do. And the other important thing about main is over here, the parameters. Here it can have either no parameters, so this is perfectly fine, or you can have some parameters. You can have a string array, and usually by convention it is named args for arguments. So this will contain whatever arguments you use when running the program. For testing, let's print out the size of this array, so console, let's do a write line, let's do the args.length. Also, by the way, here, this array, this args, this one is guaranteed to never be null, so there's no need to test for that. Here, let's print out the size of the array, and then let's just cycle through it. So a string r in args, and let's just print it out. So a console.writeLine our arg. Okay, so like this, if we run it just over here inside Visual Studio, then we are not passing in any arguments, so naturally it is 0. But now here we are in the command prompt to run our code. And if we run just like this, again, no arguments, it does return 0. Okay, correct. And then for calling it with arguments, we just add a space and then add whatever arguments we want. For example, let's pass in the number 32. And if there you go, it does work. It did receive one argument, and the argument is number 32. Now here we can include as many arguments as you want of any type we want. So for example, for a string, we can include the quotation marks, say code monkey, and then we can include maybe a boolean, so maybe true. And if there it is, 3 arguments, 32, code monkey, and true. In terms of arguments, usually what you might see are some kind of flags. So for example, have a -debug. This would start the program in debug mode. Or alternatively, you could have an argument like mydata.csv. So this would be the file that the program would open to do some kind of analysis. Arguments are really extremely useful when you don't have any kind of UI. When you just want the program to run and just do whatever you want it to do based on whatever arguments it gets. Just like this, don't need any UI, and you can still do quite a lot of things. Now, one very important thing here is how arguments, this one is an array of strings. So over here, when we execute our code with the parameters 32, code monkey, and true, technically that's a number, that's a string, and that's a boolean. But in reality, all of these are strings. So if we want to get an actual number and an actual boolean, if so, we need to parse them. Now, all of the built-in types, they have a parse and try parse function to do that. So for example, for the first one, int dot, let's do a try parse. we can try parse, and for the string, let's grab the args, and the first parameter was the int one. We can do out int, and let's call this the int argument. So you have just like this, basically try parse, this one will return true if it does succeed in parsing and false if it doesn't. And alternatively, we have the parse, and this one assumes that it will succeed. Now I covered these two functions in a bit more detail on the lecture on data types, how you can convert from types back and forth, like converting from a string onto an int and so on. So you can do, for example, this, and then for a bool, let's parse out the one on index 2, and then we can print those. So let's print out a right line, print out the arg int, our int argument, then the second one is actually going to be a string. So let's just grab the one index 1, and then for index 2, that one is going to be our arg bool. So let's see, here run our code, and yep, it did work. We did get the int32, the string code monkey, and the boolean true. So this is how you can convert a string into whatever type you want, and then you can do whatever you want using these. Now, there's actually another alternative for getting some arguments. Technically, you don't have to include the string array over here. You can remove this, and if you do, then you can basically go inside the environment, and inside there's a function called getCommandLineArgs, and this one does exactly the same thing. So let's receive a string like this, args. So like this, our main does not have any parameters, but still, let's try. So here, let's run it. And if it worked, although we got one extra argument, so the very first one is a path to the DLL. So you can either include it directly over here or grab it from this. And this can be quite useful if you don't have access to actually modify the main function. If you can't modify it and it's stuck with no arguments, you can still use this to grab whatever arguments were used. And finally, if you have multiple classes in your code base, for example, let's do a public class, another program. And in this one, if we also define a static void main function as well, if we do this in test, nope, here we have an error. It is saying the program has more than one entry point defined. This is how you can only have a single entry point. There can only be one. You can't have multiple possible entry points. Now we can still do this. We can have a different class that also has something called public static void main. We just can't have two entry points. So if we have this, two classes that both have a static void main, if so, then we just need to define which one we want to be our entry point. So here, let's do a console.writeLine. Let's call it another program. And the way we modify that is over here on the right side. Let's go on the Solution Explorer. Then let's right click on the project. Important, it's on the project, not on the solution. So right click over there on the project. And let's go down into properties. And then it's over here under general that we see the startup object. This one, like says, defines the entry point to be called when the application loads. So it's over here that we can select, and it's basically going to show us the classes that have a main function. So let's say we want to start off from the another program. Yep, just like this. Now let's test. And yep, now it runs and ran exactly starting from that one. All right, so that's the main function and command line arguments. With this, you can see how you can have quite a bit of control over even some very simple console apps. You can make some very complex programs that do lots of things depending on the arguments they are given. So always remember how you don't necessarily need complex GUIs. For a lot of programs, like just a simple console app, if you just include some arguments, it will likely be simpler and work just as well. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about Nullable. This is a special built-in type that lets you make any type nullable, even value types like int and bool. Okay, so in a previous lecture, we already learned the difference between value types and reference types. How reference types, like for example a class, they can be set to either null or an instance of that class, but on value types like an int, you cannot set it to null. So over here we can define a player field and set it to null. This works. But if we define an int, nope, this one does not work. Here we have an error. Cannot convert null into an int because it is a non-nullable value type. However, C# does have an interesting thing called Nullables, which lets us make anything support null, even value types. And there's two ways to do it. One is very simple. We just add a question mark to the end of the type. Just like this, yep, this one is now a nullable, and now we do not have the error, we can now set it to null. This works with any type, so here we can make a nullable int, we can make a bool nullable. This works. We can also define some kind of struct, define some struct, and over here, if we just have the struct cannot be null, but if we make nullable, yep, that does work. So we can really make anything support null by adding the little question mark, by making it into a nullable. Now this can be really useful if the variable is only used in certain scenarios. Like for example, let's say we had the player and this was some kind of strategy game. So this would be some kind of player unit. And inside you would have an int for some kind of attack damage that the player could deal. And we could define some kind of value if we wanted the player to actually deal some damage. Or alternatively, we could define it as null if we wanted the player to not be able to deal damage. Like let's say they have no weapon equipped. Setting it to null makes more sense than defining the attack damage as either 0 or -1. That makes it a little bit confusing that this specifically means no attack damage, whereas null makes it much more straightforward. This means we have no attack damage. Or alternatively, nullables can also be very useful as function parameters. So for example, let's say we have some kind of setup function. We use this to set up our player. And in here, we can receive an int for the starting health. And if we do it like this, then this one is a mandatory parameter. If we wanted the player to keep whatever health was set in the prefab itself, meaning if we did not want to override it with any kind of starting health, if so, we can just define it as nullable and then default it to null. Again, that would make a lot more sense as opposed to making a normal int defaulting to 0 and then having to remember that, okay, if the health is 0, that means do not override what is on the prefab. Instead, we set it to null, and this one makes quite a lot more sense. So nullables can be quite useful to make literally anything nullable. And if it does have a value, if it is not null, you can just cast it and use the value. So for example, up here, we got our I. It can be null or it can have some kind of value. And to grab that, let's say int attack damage. We can grab the value and simply just cast it. Yep, just like this. Although, of course, this one is going to throw an error if we have null here. So if we do this, yep, naturally we have an error. So in order to do this, before we cast it, we can check if I is not null. If so, then let's actually grab the value. And if it is null, then don't do that. Alternatively, instead of checking it against null itself, if so, we can go inside this one. And inside we have this really interesting property called hasValue. This one, like name implies, is going to be true if a value has been set and false if it's null. So we can check if it has a value. If so, then let's cast it onto our value. Or alternatively, we can also do something instead of doing a cast. So instead of a cast, we can go inside and we can grab direct value. And this one is going to be of whatever type it is, the type that we made nullable. So yep, just like this, no need to test directly against null, no need to cast it, just like this, everything works. Or yet another alternative, we can go inside our nullable, and inside there's a really nice function called getValue_default, and this will either return the value or some kind of default. So we can use this function that returns a default value. So if we put it something like this, like a 12, let's put a console.writeLine on this. Okay, so let's see what this one returns, considering how this one is null. And of course, it returns 12. So that's how we define nullable and how we interact with it. But like I said, there are two ways to do it. This is just one, adding the little question mark. And the other one is to much more explicitly use the Nullable class. So there's a class called Nullable, just like this. It takes in a generic parameter, so we can do Nullable of int just like this. And if that's it, everything else works exactly the same way. It also supports null, it also has the hasValue and the value, it also has this function. Really writing this or adding the little question mark ends up the exact same thing. This one's really just a shorthand, both do the exact same thing. In reality, this class is really just a wrapper around some kind of value. So it has a boolean and has the actual value. So it's essentially just a class with two fields instead of being just one. And then if you want, nullables can also work very well in combination with the null coalescing operator that we saw in a previous lecture. So we can define, let's say, an int nullable, call it a, set it to null, then int b, and let's set it to either a, if a is not null, but if a is null, let's set it to, let's say, 56. And if this works, so b will be set to the value of a if a has a value. If not, if a is null, then it will set to the default value. Alright, so that's nullables. Whenever you have some code with some value type and you want to make it support null, then go ahead and use it. It is super simple. You just add a question mark at the end and all of a sudden your code, your field now supports null. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about span in C#. This is a really interesting type that lets us do operations on slices of arrays and do so in a super fast performant manner. Okay, so let's see span. This is a really interesting type that was introduced to C# just a few years ago. It allows you to grab a slice of an array and do it super fast and importantly without any memory allocations. That's a crucial part of it. So for example, let's say we have an array of numbers. So an int array for the number array, and we have just a new one, and then just have a whole bunch of numbers, so a whole bunch of random things. Okay, yep, just like this. Now let's say we want to sort this whole array, but we only want to sort the numbers in the middle. We don't want to sort the edge ones. Now one way you could do this is by making a subarray. So you define another array for the subarray. You would define it a new int array, and basically just use the length minus 2. So go into this one, length minus 2. You do this, then copy all of those elements, so only these elements, then sort out this array, then copy them back onto the numbers array. Yep, you could do that, technically that would work. But doing that would also require creating a brand new subarray. This requires allocating additional memory. Depending on how constrained you are in terms of resources, that might be a problem. It allocates new memory, which of course also then has to be garbage collecting. So once again, another potential issue for performance problems. So in order to solve that and many other problems, for that we have the span type. A span is really just a slice, or it can actually be an entire array. But importantly, in creating a span, we don't actually allocate any new memory. It is a very special class that is all handled with pointers to the original memory, all done in the background. So the way we create it is actually very simple. We define something of a span. This one is a generic, so let's use a type. In this case, we want the span of int. Let's call it our int span. And then if we want this span to have the entire array, we can just equals it, so equals number array. And if there it is, that does work. So now this span, again, this one is not constructing anything. This one is not constructing a new object. Instead, this span now simply has a pointer to the entire original array. So you can do this if you want the entire array, or in our case, we only want to sort the ones in the middle. So let's grab a subarray. So we can do a new span. This one has a whole bunch of constructors, which first of all receives an array, so that's a number array. And for the start, like I said, I want to start after 1, so let's start on 1. And for the length, so over here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements, minus 2. Let's grab the length of 6. And if that's it, so here we created an int span. So that's a span. It's basically a pointer in memory that is super fast and is pointing just to these elements. And inside the span, we can do whatever we want. Like for example, we can just call the sort function. That's it, very simple. And importantly, by calling this, we don't need to actually update the original array. So we don't need to cycle through the span and update the new array elements. We don't need to do that because, again, this span isn't actually holding any data itself. It's really just a pointer to the original data. So by modifying the data inside of this span, we are also modifying the original data inside the array. So if we do this and then we print out the values, so let's do a for each int number in the number array. Let's do this, and in console.writeLine, let's print out the number. So this should say 5, then all of these should be ordered, and then should have a 10 at the end. Let's see. And if correct, so 5, then 0, 2, 12, so these are all sorted, and at the end we have our 10. So if we sorted all the elements, but just ones in the middle exactly as we wanted. And very importantly, we did not have any new memory allocations, which in turn also means we're not going to have any garbage that needs to be collected, which in turn means that our program will be much more stable and much more performant. Then with this span, you can also have all kinds of functions for working with this data. For example, you can copy just a slice onto another span, or copy this entire slice and convert it into an array. You can do a slice of another slice, or you can fill it all with a bunch of elements. And again, all of this applies to the original data. Remember how the span itself isn't actually holding any data, it's really just a pointer to the original data in memory. So in this case, we made a span that takes all the elements in the middle. Now if we call it fill, and we fill it with some kind of value, let's see. And if there it is, just like that. So the original array still has the first and last one unchanged, but the ones we selected, those have been filled with one number. So span is really great for manipulating slices of arrays, again, without any memory cost. Then if you want something even more efficient and you only want to read, if so, then you can actually use a read-only span. And if this one is really the exact same thing, but limits you to read-only, so you can't write to it on this one, you can't fill it. But if all you need is read-only, if you just need that and you need extreme performance, then this one can be a great type. Now spans work on arrays, and a string is really just a char array. So for example, if we have a string, and inside we have some numbers. Let's say, for example, that we worked with some code that contacts a website and that received this string with these values. Now let's say that we want to parse these values. So one way would be to do a substring. So you do str.substring, and over here put the start index and the length. That would work, but once again, we are wasting memory to allocate this temporary string. So if we are building a performance critical application, and we don't want to allocate any more memory than we need to, again, we can use a span to slice a string. Although in this case, for a string, for this one, using a span doesn't actually work. If we do span char for the char span and do equals str, if we do this, nope, this one does not work. It cannot implicitly convert that one into that one. For strings, it only works the read-only span. And if this one does work, so here we have a span, which again is really just a pointer in memory to this data. So now let's say we want to parse out these values. We can go inside this one. Let's grab a slice on 0, go for a length of 2, and this is going to give us our first number, so we can do int.parse. Let's parse out this number for the int for the number 1, and then for number 2, really same thing, let's slice, starting on 3, and go for 2 more values. So yep, then let's do a console.writeLine, let's write number 1 and our number 2. Okay, let's see. And if there it is, we do have our 2 separate values. And importantly, just like this, we did not spend any memory allocation cost. Whereas if we had done substrings in order to do the exact same thing, we would have quite a little bit of a cost. Now, one practical example for how this could relate to game development would be perhaps some kind of inventory system where the UI has various pages to show all the items. So you would have some kind of array with all of your items. And then for displaying each page in the UI, instead of creating a brand new temporary array, instead of that, you can just very easily grab a span, just grab a slice of that array, that item array, and use that to display it on the UI. Alright, so that's span. It's a very interesting type for grabbing slices of an array or doing some operations on it without having a memory cost. This is a very useful type in some performance and memory critical applications. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the bitwise operators in C#. This is how we can do operations on individual bits of data. Okay, so like we covered on the beginner lecture on data types, C# has a bunch of built-in data types. You've got things like short, int, long, and so on. All of these, they all store whole numbers, but their ranges differ. For example, a short can only store 65,000 numbers, then an int can store about 4 billion, and a long can store an insane amount. The difference in all of these is how exactly they are stored in memory, meaning how many bytes or how many bits they actually use. By the way, remember how 1 byte equals 8 bits. So over here, a byte, this one literally uses just 1 byte, so 8 bits, whereas a short uses 16 bits, an int uses 32 bits, and a long uses 64 bits. So for example, here we have a byte in memory. We have 8 bits, meaning 8 zeros or ones. This is how memory actually works. It's all binary in the end. So for example, here we have the number 0, then here we have the number 1 in binary. This is a 2, this is a 3, and so on. Now, in case you don't know how binary works, basically every single position on this number, every position represents 2 to the power of something. So this one represents 2 to the power of 0, this one 2 to the power of 1, power of 2, and so on. And those powers equal these values. So this digit over here represents 1, this one represents 2, this one represents 4, and so on. So in binary, you basically just add ones or zeros to whatever number you want to build, and then you just multiply it by whatever is the value on that digit, and simply add them all together. So in this case, this one is a 3, so we've got a 1 over here on the 2 position. So 1 multiplied by 2 is 2, and then a 1 multiplied by 1 is 1, then you do 2 plus 1, and you have 3. If, for example, we wanted to store the number 13, if so, we would have a 1 over here on the 8 position, so that makes 8. Then we would also have a 1 over here on the 4, so that makes 12. And then we would have a 1 on the 1, so yep, this one is 13. This is how you represent 13 in binary. So it's really all just ones and zeros. And the goal with bitwise operators is to basically let you manipulate these bits individually. These are the 4 bitwise operations we can do. We can do an AND, we can do an OR, an XOR, or an exclusive or we can negate. For example, up here we have the number 2, and down here we have the number 3. If we want to do an AND operation between both these, if so, then we just do a normal Boolean operation on each bit, meaning that both of them have to be 1 in order for the output to be 1. So over here we do 0 and 0, and the result of that is going to be 0. This one is also going to be 0, 0, and so on. Then we get to this one, 1 and 1, both are 1, so this one does relate to 1. And then we've got 0 and 1, that one does equal 0. So this whole thing equals a 2. Doing a bitwise AND operation between the number 2 and number 3 equals the number 2. So over here in our code, we can define just number 2 and define the number 3, and then do a bitwise operation. So we do A and B. Now importantly, it's this one, just 1 ampersand. It is not 2 of them. This one is a Boolean AND, that is not what we want. We want just 1 ampersand to do a bitwise operation. So yep, like this, let's do a console.writeLine on this one to see what this returns. And if there it is, the number 2, exactly as intended. So what we are doing here is doing an AND operation, but applying the AND to the bits themselves. Another operation we can do is an OR. So this one outputs 1 if either bit is 1. So all of these that are all zeros, these are all going to end up as 0. Then over here we've got 1 or 0, so one of them is 1, so it becomes 1. Then 0 or 1 also becomes 1, and 1 or 1 also becomes 1. So the end result of doing an OR operation between numbers 5 and 3, the end result is the number 7. So yep, let's verify it. Here in the code we have numbers 5 and 3, and now let's do a bitwise OR operation. So just like this, again, just one pipe, it is not 2 of them. We do not want to do a Boolean, we want to do a bitwise OR operation. So let's see like this, and if it's not like that, we do have a 7. Another operation we can do is an exclusive OR. This one outputs 1 if either bit is 1, but not if both are 1. So in this case, all of these are zeros. Then this one, 1 XOR 0, that does equal 1. 0 XOR of 1 equals 1, because again, one of them is 1 and the other one is 0. But on this one, where both are 1, the XOR does equal 0 on this one. So the end result of this one is the number 6. Again, here in the code, let's verify it. So between number 5 and 3, let's do an XOR. And to do that, we use this little symbol. Apparently, this is actually called a caret. In Portuguese, we just call it a hat. So it's this one if we do an XOR between these two values. And if there it is, we do have our 6. And finally, we have the negate. This one, like name implies, simply inverts all the bits. So a 0 becomes a 1, and over here 1 becomes a 0, 0, 1, 1 into a 0. Here in the code, the way we do a negation is we add a little tilde. We add a tilde before our number. So this is going to negate the number 5, let's see. And if there it is, the number minus 6. By the way, the reason why the number is negative is because of something called 2's complement. This is how the first bit, the leftmost bit, that one is used to denote either positive or negative values. That is also how back here, if we look at all the types that C# has, you can see how we have both signed and unsigned versions. Basically, the signed one, the leftmost bit, is going to define whether it's positive or negative, whereas the unsigned ones, those don't have a concept of positive or negative, so they can only start from 0 towards some positive maximum. Okay, so these are the main bitwise operations, but we can also construct numbers directly from bits. For example, let's say we want to construct here the number 4. So in binary, number 4 is really just a 1 on this position. It's a 1 on the third position, meaning the one on index 2, so this is index 0, index 1, index 2. In order to construct this number, we can use a bit shift. So this is where we start the number, usually 1, because it has zeros on everything except a 1 on here. We start with this one, and then we shift it by several places. So in this case, we want to shift by 1 and 2, and we end up with our 4. Now here in the code, like I said, usually we start with the number 1, and then doing a bit shift, we do 2 angle brackets, so 2 less than signs, and then the amount that we want to shift. So in this case, we want to shift by 2 places. So yep, let's see. And if there it is, this equals the number 4. We can also shift in the opposite direction. So let's pick the number 8, let's shift towards the right, and shift by 2 places. And if there it is, we end up with number 2. So manipulating bits is really interesting, but you might be asking yourself, where would you use this in a practical manner? Now, the main thing this gives you is the ability to store a bunch of data in a really compact manner. So you can have each of these bits represent something, like for example, attributes on a gun. For example, let's say that this bit over here, this one represents that the gun deals fire damage. Then this one, let's say that it deals damage over time. And this one perhaps is it causes stun. So with just a single number, with just a single byte with 8 bits, with just that, you can actually store quite a bit of information. So we can store that the gun deals fire damage, deals stun damage, and deals damage over time. Or more practically, Unity actually uses this a lot in layer masks. As you probably already know, game objects belong to a certain layer. You can change the layer here, and you can add a bunch more layers. Also note how there's a specific limit of 32 layers, so from 0 up to 31. That's exactly why, is because the layer, this one is a bit mask. It's a 32-bit bit mask. And in the code, when you do something like a physics raycast, when you do this, note how one of the parameters is an int that represents a layer mask. This is a bit mask, it is not just a single number. So for example, if you want to hit all the objects on layer 6, if so, you would not put a 6 here. Instead, you would define, for example, an int for the units layer. Let's say it's layer 6. And to construct an int for the layer mask, the way you do this is by doing a bit shift. So in this case, 1, and bit shift to the left by the units layer. So just like this layer mask would mean that it would only hit objects on the units layer. Or for example, if you want to hit units and buildings, so let's say we have another for the buildings layer, and this one is on layer 9. If we have this, we can bit shift this one onto the left, and then do an OR operation with 1 bit shift to the left by the buildings layer, and doing an 1 operation. Again, basically it makes 1 when either of them is 1, so it essentially combines 2 layers. And doing so, this layer mask would then hit things on units and or the buildings layer. Or alternatively, instead of all this, Unity actually already has a built-in layer mask type. So up here, let's just make a type of type layer mask. Let's see. And if there it is, we can see a layer mask. And over here, this one shows a really nice drop-down menu, so you can easily select all the layers that we want. So for example, select the attackable layer, select the UI layer, the water layer, and so on. So here you can very easily select all the layers that you want, and then Unity automatically constructs a bit mask based on all these layers. Then another place where bitwise operations are used quite a lot is with Enum Flags, and that's actually what we're going to cover in detail in the next lecture. Alright, so here we learned about bitwise operators, how we can manipulate individual bits in our data. This is an excellent way to store some data in a really compact manner. With just a single byte, you can store quite a lot of information. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about Enum Flags. This is a special thing you can add to your enums to make them work like bits, which enables you to do bitwise operations on them. Okay, so in the beginner section, we already covered enums. So here's a basic enum that represents various abilities. Now let's say we want to use this to define what abilities our player has. We can easily define a field of this type, and we can say, for example, that the player can jump. Okay, that's it, pretty simple. But now let's say we want the player to be able to both jump and shoot. Like this, we can't actually do it. We can't do something like ability jump plus shoot. That doesn't really work. We can't add it onto here. we can only override it. So inside of this one, we can really only store a single ability, but that's exactly where Enum Flags come in. First of all, we just had the flags attribute. So up here, an attribute for flags. And this one, by the way, exists inside of system. So we have that attribute, and then over here, we define numeric values to all of these enum values, meaning we use equals and then some kind of number. Now, specifically for this use case, we want to use powers of 2. That's very important. So for example, for none, let's assign it to 0. For jump, let's assign it to 1. For sprint, let's say 2. Shoot, 4. And fly, let's assign it to 8. Now, on the previous lecture on bitwise operators, we already covered binary. That's exactly what we're doing here. In fact, like we mentioned on the previous lecture, over here, instead of using numbers, which can seem a little bit confusing, instead of that, we can just use bit shifting. So you can do 1 bit shifted by 0, and that makes a 1. Then 1 bit shifted by 1, bit shifted by 2, and so on. Yep, just like this. So we mark that as a flag, and we define the values as power of 2. Now with this, we can actually solve our original problem. So we want the player to be able to both jump and shoot, and with this, we can now combine our enum values, so we can make a jump, or, and this is the bitwise or, so again, just one pipe, or ability.shoot. And if that's it, if we now do a log on this, so let's do a right line on the player abilities, if there it is, the player can jump and shoot. So here we have the player abilities field. That's just one field, just a single field, but it is actually storing 2 separate pieces of data. It stores that the player can jump and can shoot. So here we define it. Now let's say that we want to check if the player can jump. If so, we can just go inside the player abilities, and we can use the hasFlag function. So let's say if the player can jump, let's go log on this, like this, let's test. And if there it is indeed true, the player can jump. Or alternatively, since over here really we are just working with bits, because this we can really just use some basic binary math. So if we want to check if the player can jump, if so, we can just take our jump ability, so just like this. And then we can do a bitwise AND operation, doing an AND with our player abilities. And basically the output of the bitwise AND, this one is going to be 1 when only both these are 1, which in this case means it's only going to be jump. So we can just compare if this one equals ability.jump. Let's put this one inside parentheses. So let's see if the player can jump, and if that is true, the player can indeed jump. So enum flags are really super useful for combining multiple options in a single enum field. It is just like the layer mask that we saw in the previous lecture. How Unity has this type, which lets you select multiple layers. So here in the editor, we see this field, and we can easily select as many layers or as few as we want. And here Unity also already supports the flags enums. So if we do this and we expose the field of our flag enum, then up here in the editor, we do indeed get a drop-down menu where we can select as many or as few things as we want. Now, another thing we can do with enums, not necessarily related to flags, is we can actually define the underlying type we want this enum to use. By default, this one is going to use an int, meaning it is actually going to use 32 bits. But if you want to limit memory as much as possible, if so, we can actually define what type we want this to use. And you do that by adding a little colon, and then define this one as a byte. So yep, now storing a field of this type is just going to occupy a single byte. Now, naturally, byte means 8 bits. So if you want to store it as a byte, you are going to be limited. So yep, like this, if we define more than 8 possible values, yep, here we do have an error. Basically, a byte can only store 8 bits, so we cannot add 9 possible values here. If you want more of those, then you can use a short or just default int. Then yet another interesting thing you can do here is you can also define some combinations. So you can define one for shoot and fly, and you can do equals shoot or fly. And yep, again, this one is going to do a bitwise OR operation, and it's going to combine both the shoot and the fly tag, and both them inside of this one. Okay, great. By the way, I should also mention that technically the flags attribute, this one is not really required for this. You just need to assign the binary values and all of this works. But if we don't assign the flags, if we don't do that, let's see what this one is going to log. And if there you go, that one just logs the number 5. Whereas if we have the flags attribute, yep, that one logs the proper readable thing, jump and shoot. So you don't necessarily need it, but adding it makes it very easy to read. Alright, so that's enum flags. It's a great way to store multiple enum values in a single enum field. This is really excellent whenever you want to store combinations of values instead of storing just a single one. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about preprocessor directives. This is how we can give some instructions to the compiler itself, which are run during compilation time and not during runtime. Okay, so preprocessor directives. With this, we can tell the compiler some things. The simplest thing we can do is just define some symbol. For that, we need to do it at the very top of the file. So over here, we start with a number sign or a hash sign. Then we write define, and now we can define whatever name we want to give to this symbol. So something like testing. And usually as a convention, you write the symbol names in all uppercase. So that's it. This defines a symbol. That's all it takes. It doesn't equal to anything. It's just a symbol. Symbols either exist or don't exist. So they're not variables that hold any data. They are just defined or undefined. So here we define the testing symbol, and then anywhere else in our code base, we can do an if. So for example, let's go over here. Let's do again the number sign, then write if, and then whatever symbol we want, like let's say testing. And then to terminate our if, we do an if. And yep, just like this. So now, for example, we can put some line of code inside of this one. Yep, just like this. And now what this is doing is basically telling the compiler to either include or not include this line, depending on if the testing symbol, if that one is defined. Like this, if we run our code, if there it is, it did say testing. But now if we remove this define up here, right away Visual Studio even helps us by graying this out. It means this code is not going to be included in the compilation. So right now if we run this, and if there it is, now we do not see that message. Essentially, this code right here, this does not exist at all in the final program. This if over here is adding some instructions to the compilation itself, and since the symbol is not defined, this code will not be included in the final program. It literally does not exist. One very common use case for this is for debugging. So you can add some complex code for supporting debugging, doing all kinds of log messages and so on, but you might not want that code to be using up performance in the final build. So you define a symbol in order to make some kind of debug build, and then you remove that define when you make the final build so that the debug code does not run. That's one of the main ways that preprocessor directives are used. And just like in pretty much any kind of programming, if we have an if, we also have an else. So you can write else and then do whatever we want. So for example, over here, let's say not testing. And yep, right away in the colors we can see, so this one is not going to run because testing is not defined, whereas this one is going to run. And if we go up here and if we define our testing symbol, and yep, now this one does run and this one does not run. So you can make an if and an else, just make sure it always ends with an end if. Or alternatively, we also have elif. This is basically else if. So elif if something, let's define a testing2, and then let's do an else. So up here, let's put testing2. And yep, so if we define testing, then it runs this one, okay. If we don't define testing, then it goes into this else if and checks, does this one exist? It does not exist, so it runs this one. Whereas if we define our testing2, if so, then yep, it runs this one. So all of this, some simple if-else logic, just like you're used to. And right now you might be thinking, okay, so what exactly is the difference between this and just writing a normal if? So just a bool testing, let's set it to true, if testing, if so, then do something, if not, don't do it. So the difference between this and this, the difference is that the normal if, this one will be included in the final program. This if will only be evaluated at runtime, so only when the code is actually running. Whereas this one, for preprocessor ifs, these are evaluated during compilation times. And whatever does not match the if, like this one is simply not included in the final build at all. So this code literally does not exist at runtime. The compiler evaluates the ifs in order to figure out if something should be included or not. And after the code is compiled, all of this does nothing. All of this is replaced by just the things that are included. So this one is a runtime if, and this one is a compile time if. Another important thing about the define is how it only applies to this one file. So here we have this file, and I created this brand new one. So it's a completely separate file. And over here, let's define the testing and just do our normal testing, just like this. So yep, it does run on this one. But now on this one, if we try doing the same thing, nope, here this code will not run, will not be included. That is because this testing symbol is not defined anywhere in this file. It is only defined on this one. So the defines are on a per file basis. But we also have options for project-wide defines. There are two main ones that are automatically defined by default. One of them is called debug, and the other one is called release. These are the two automatic configurations. So up top here we have a drop-down menu. This one is for the configurations. And by default, it always starts with a debug and a release one. And doing so, these automatically create defines and applies it to the entire project. So here with this set to debug, if we have the if debug, this one is going to run. And same thing on this other file. If we define this as debug, yep, this one also runs. So this debug define applies to the entire project. Like I said, one common use case for this is for debugging. So rather than defining a debug symbol on every single one of your files, instead of that, just use the built-in configuration manager to use this debug, and then when making the final build, you swap it over to release, and doing so, all of this debug code will no longer be included. So setting to release both does that and also creates a new release. So yep, this is a super easy way to enable project-wide defines. And if we go on the configuration manager here we can click on this and we can add some new ones. We can add, for example, testing, and now we don't need to define a testing anywhere, and we can do if testing, and yep, it does work. Then over here, if we just write if and we press space, we see a bunch of autocompletion. So we can see a bunch of defines that are created by default. For example, these over here are related to the .NET version, the .NET Core version, and so on. So with this, you can write some version-dependent code. For example, some code that depends on a specific version, like only works on .NET 6 or greater. So you can do this, run that code, and then have an else. And if the project is not set up with .NET 6 or greater, you can then fire an error, log a message, or do something like that. Now, another place where we can create project-wide defines is in the project properties. So over here on the right side, let's open up the Solution Explorer. Let's right click on the project. Important is over here on the project, not on the solution. So right click over here, go inside Properties. And then over here, let's scroll down under Build. Yep, just like this. And up here, we have a bunch of custom symbols that we can add. These are related to the configuration builds that we saw. So we've got debug, release, and our testing one. And again, these are project-wide, so these will work on all the files. So over here, like C# course, just add it. And yep, there you go, it's enabled. And over here on any of these, I can search for C# course, and yep, it does work. And again, project-wide, so it works on both that one, as well as on this one. Okay, great. Now, other defines are the ones inside of Unity. So here's a script inside that Unity project. And over here, we can write if. And again, we do see a whole ton of defaults. There's a bunch for all kinds of interesting things. And the main ones are really just over here for the versions. So you want to write some code that requires 2018.1 or newer, any of these. You can make it based on build, so it has to be on a standalone Windows build and so on. Or actually one that is really important when making tools is this one for the Unity editor. With this, you can either include or not include some code that is specifically related to the Unity editor. Then in Unity, we can also add project-wide defines. So let's go into Edit and down here onto Project Settings. Then over here, let's go on the Player tab and let's scroll down under Other Settings. Let's keep scrolling down. And if here it is, we've got the script compilation, so the scripting defined symbols. And if it's over here that you can add whatever symbols you want. You can write anything, and again, these will be global defines that apply to every script in your entire Unity project. Okay, so that's defines in if, but there are more preprocessor directives. One that I use every once in a while is one that is called region. You write this, and then optionally you give it some kind of name like functions, and then at the end you write and region. Any of this creates a region, and importantly, over here in Visual Studio, this one creates a collapsible menu. So it can collapse or expand. This can become quite useful in large files for organization. So for example, you could make a region for all of your fields and make end region, then make another region for all of your statics. You could have it like this, and even on a giant file, things will look quite manageable. Another simple one is both warning and error. So we just write error, some error. And if that's it, very simply, this creates an error. So it says some error. And if you look down here on the error list, yep, we have an error. So this is basically a compilation error. We cannot compile like this. And as for when would you use it? Well, you can actually combine this with the if. So for example, let's go with if. So for example, if we are not using .NET 8, if so, then spawn some error. If not, then don't spawn that error. So these can be quite useful for validation on your project. And related to that, we have another one, and that other one is the warning. And this one, really the same thing. So this is a warning. This one is not an error, so it does not stop compilation. It's just a warning. So down here on the error list, if we include warnings, yep, we see this is a warning. And related to that is another very useful one for disabling some warnings. For example, let's say we have some code here and we define some kind of variable, but we never initialize it, we never use it. And let's say this was actually intentional. Right now, if you do this, we see the little squiggle line. So this is a warning. It is saying the variable is declared, but never used. And down here on the error list, yep, we do see that same thing. If we wanted to disable this warning, if so, then we can just write pragma warning and then disable, and then the actual number for the warning. So over here, let's mouse over and see. Okay, so this is warning 0168. So up here, disable 0168. And if there you go, it does disable that warning. So that one no longer shows up as a warning anywhere. So if you have some warnings that you know are not a problem, you can use this to suppress them. Or alternatively, you can just do just this, pragma warning disable, and this is going to disable every single warning. Also, this does not have to be written just on top of the file. You can write this anywhere. So for example, right before this line, we can write this one. And then let's say we want to ignore literally just this warning and nothing else. And then afterwards, we can write pragma warning restore. And now if we write a similar error, if there it is, now this one does show up the warning. So it only suppresses the warnings directly within both of these lines. All right, so that's preprocessor directives in C#. It's how you can give instructions to the compiler itself, which mainly allows you to write conditional logic that will run at compile time instead of at runtime. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about ref, out, and in keywords. This is how you can output more data from a function than just a return type, or how you can pass in something explicitly as a reference instead of a copy. Okay, so here's some simple code, and we have a basic function. It's called getUnitState and returns a state. That's it, pretty basic. But now, let's say we want to return more data from this function. Let's say I want to return also the unit health and the unit name. So over here, I can't really just add a comma and then add the health and then add some kind of name. This does not work. This is not valid code. Also up here on the return type, I can't just add an int then a string. This does not work, not valid code. Functions can really only have a single return type. Now, by the way, just a quick mention for those of you who already know tuples. Technically, over here, you can make this return a tuple. I cover tuples in another lecture in this advanced section, but for now, let's ignore tuples. So for now here, all we can do is return just a single type, so we cannot return multiple pieces of data. Now, one way to solve this problem is to make some kind of class to hold whatever data we want. So up here we can define a class, let's say unit data, then inside we have a state, then inside we have a health amount, and we also have some kind of string name. So we can do this, and then over here we can return this type, and on return we construct a brand new one of that, set the state equals some kind of state, set the health amount, and set the name. So if this does work, and just like this, we are indeed returning multiple pieces of data, all composed inside of one type. So this works, this is a perfectly valid option. But if we don't want to constantly have to define a brand new separate type to do this, if not, then there's actually a simpler method. Over here, we can define a parameter for our function, like let's say an int health amount. And unlike this is a normal parameter, so it's an input parameter. However, we can now add the out keyword, and just like this one now turns into an output parameter. Meaning that over here in this function, we can assign this parameter to some data, and we are going to receive that data over here when we are calling the function. So by using over here the out keyword, we are defining this parameter as an output. So just like the return type, that is the standard normal output you have from any function, just like you have that one, using the out keyword is another way of getting some output from a function. So inside of this, before our return, let's set health amount equals something, and if just like this is our function. It has a return type, it returns state, so that's the normal thing. And then we're also using this parameter as an output parameter. Then up here, when calling that function, we just need to include this parameter. However, importantly, this is an output parameter, it is not an input. If it was an input, we would write some kind of number here, that would work, that would be an input, but this is not an input. In the case of an output, we define some kind of variable, like int health amount. By the way, it doesn't have to have the exact same name, you can name it whatever you want. So we define that variable, then over here we pass in that variable, and importantly, we have to write the out keyword. And yep, just like this. So we define the variable, and we didn't give it any value directly to the variable, we just defined it. And then we pass in that variable using the out keyword onto the function, and then the function does whatever it does. Now, by the way, if we were not using an output parameter, so let's make this one an input parameter, so it's just a normal parameter. And if we do it like this, then we have an error here. It says use of unassigned local variable. If we're using a variable as an input, we have to give it some kind of value, we have to initialize it to something. But when it's an output parameter, we can indeed pass in just an uninitialized variable. Yep, like this does work. The reason why this works is because this variable is guaranteed to be set inside this function, so it doesn't need to have any value preset before calling the function. Now here, after calling the function, let's do a console.writeLine. Let's print out what's inside the health amount, and let's see. So again, here we are initializing and not giving it any value, passing it into the function. Then the function is doing some logic, and then afterwards, let's log out and see. And if there it is, it does have the value 56. So we define the variable, we pass it in as an output parameter onto the function, then inside the function, that variable was set, and in doing so, it actually updated the value outside of it. Now this is actually really interesting. Right now, you might be remembering a previous lecture on value versus reference types, and how I said that value types, like int is a value type, when using value types as parameters in a function, these are passed in as a copy and not a reference. So normally, this would actually receive a copy, and modifying this copy would only modify the copy itself and would not actually modify the original data in memory. But that's exactly what the out keyword does. Even though int is a value type, by using the out keyword, instead of passing in a copy of the data to the function, instead it passes in a reference, even though again, the type is actually a value type. So that's how this function can modify the data we passed in, and if we exit outside, we see this variable is actually modifying. Whereas if we remove the out keyword, if we do it just like this, and let's initialize it so it doesn't throw that error. So let's see like this and see if it says 0 or 56. And if like this, it does say 0. Because again, without the out keyword, this one is just being received by this function as a copy. And over here, we are just modifying the copy and not actually modifying the original data. So that's very important. Basically, by adding the out keyword, we are converting this into a reference type. And doing so, anything we do inside this function will affect the actual original data. So the out keyword, this one lets you define parameters as output parameters instead of input parameters, which means, for example, over here for this function, we can actually make it return void. And instead, for returning all the data from this function, instead we can just do it all through output parameters. So let's put an out state, out int health amount, and an out string for the name. Then we just need to assign all of those before we exit the function. So state, let's put it on something. And for the name, let's put it on something. And up here, this one no longer returns anything, so none of that. Here we just need to write all of our output parameters. And by the way, here's a quick tip. You can do this. You can define a variable and then pass in the variable. That works. But we can actually shorten this. So over here, when we define our output parameter, we can define the variable right here. So just like this, out state, so out int health amount. And again, the names don't have to be perfectly exact. and out string name. And now we can print out the state, print out the health amount, print out the name, and let's see. And if there it is, we have our 3 pieces of data and all of them being returned by just this one function. All right, awesome. Now related to this, the other keyword we have is the ref keyword. So instead of out, we write ref. And this one is quite similar. It also defines this variable as being a reference instead of a copy. Then up here when calling, we also define ref. However, one very important difference is when we use ref, we need to initialize our data. So over here, this does not work. We need to define our state, initialize it with some kind of value, and then we can pass in a ref on that state, and yep, now it does work. So we call it, and over here, this function receives this one as a reference, and inside we can set it to whatever we want. And again, since it's a reference, it's going to modify the actual data. So in terms of behavior, ref and out are quite similar, but they do have some very important differences. Both of them have very specific rules you have to follow. So inside the function, an out parameter like this one, you have to set it before exiting the function. For example, here, if we don't set the health amount, yep, we get an error. It says the out parameter health amount must be assigned before the control leaves the current method. So if you have something with an out parameter, you have to assign it. And if you have multiple branches, so let's say bool, set it to something. So if something else something, if we have this and we have a return, and let's put the name before those. Yep, like this one does not have an error because we are indeed assigning health amount before this return, so before this branch ends. But on this one we have an error because we are not assigning it. So if we have multiple branches, multiple places where the function can terminate, if so, we need to assign all of our outputs, assign all of them before exiting the function. So this is why it's called an output parameter. Whenever the code calls this function, it has a guarantee that the output data will be set to something. That's why up here we don't have to initialize this one, but we can use it afterwards assuming it's been initialized. That is because we can indeed make that assumption. We know for a fact that if we pass in an output parameter to a function, this function has to initialize it with something before exiting, so afterwards we can assume this variable has been initialized. Whereas with the ref keyword, this one does not need to be set, so over here if I remove the state, nope, there is no error, no problem with this. We can receive it as a parameter and either do something with it or do nothing, or we can also do something in some branches, like for example on this branch, set it to that one, and on that one don't do it, that's perfectly fine. And then up here when it comes to calling that function, when passing in a state parameter, we have to initialize it. If over here we don't initialize it, then yep, we have this error, use of unassigned local variable. In order to use something as a ref, it has to be initialized before passing into the calling function. Again, the difference between these two is what happens inside this function. For an output, you are forced to assign it to something inside of this one, so you don't have to assign it before. But for a ref, you don't have to do anything inside of this one. You might or might not initialize it, so because of that, up here you have to make sure to initialize it. So these are compile rules. You have to follow them. If you don't initialize a ref, you get a compiler error. And if you don't assign a value to an output, you also get an error. So you have to always follow these rules. And for these two, the one that I tend to use most is really just the output. The rules for the output parameter are really great. They make it very clear that this one is an output parameter. For example, here we have some Unity code, and I'm sure you've already done many raycasts. And with this, yep, you've already seen an output parameter in action. So the raycast basically sends the raycast over to the physics system. It does whatever it does in order to figure out if this ray hits something. And whatever it hit, all that data will be contained inside of this object. So this is a great example for how you'd normally use out. This function over here returns true or false depending on whether it hits anything. And then based on that, it also returns extra data in this output parameter. Whereas the ref here, this one is used mainly for converting value types into reference types. So for example, let's say we have some heal function. In this one, we want to heal some kind of health amount. So we pass in the health amount and named for the heal amount, how much we want to increase it by. So if we do this and we do, for example, health amount plus equals the heal amount. If you do this, then obviously this is not going to work. Because again, this one is a normal parameter and it's an int, meaning this one is going to be received as a copy. So up here, we are only healing the copy and not actually healing whatever we want to heal. Whereas over here, if we set this one as ref, then even though this one is a value type, it will be passed in as a reference, and we can modify the data here, and it's going to modify the original data. Also, one interesting thing somewhat related to this is the discard keyword. For example, let's say on this getUnitState function, let's say on this one, the only thing we care about is just the name. We don't really care about the health amount or the state. If so, then instead of defining variables for it, we can just use an underscore. And yep, this right here, this is the discard keyword. This makes it so that this code is valid, so we did not define any health amount variable. This is valid code and simply means that when this code runs, it is simply not going to assign the health amount to anything, because over here it is never going to be used. So this is the kind of thing that can help improve readability. When running this code, we make it very clear that we care about the state, we care about the name, but don't really care about the health amount. And yet another related keyword is the in keyword. So over here, instead of something being out, we define it as in. And this one, like the name implies, makes this an input field. So it's kind of similar as to without it. So by default, this one is going to be an input field. But when you add the in keyword, now you are passing it in as a reference. So again, the same thing about value and reference types. And by this being marked as in, meaning input, it means it cannot be modified inside the function. So over here we have this error, cannot assign it because it is a read-only variable. Now, one scenario where you would use this would be in some performance-intensive applications where you're working with structs. For example, let's say we have a struct, and this is like a huge struct. It is something that takes up a ton of data, a ton of memory. If you have this, and then you pass it into some function, if you pass it in like this, then this function is going to receive a copy of this struct, which again, if this one has a lot of data and you call this a lot of times, you're going to end up with a ton of uses, a ton of wasted memory, because when you pass it in as normal, it is going to create a copy of that data. So to help solve that problem, to not use as much memory, here you can use the in keyword, and in doing so, no copy is created, because this one is going to be treated as a reference. So this function will receive a reference to the original struct data. Then inside here, you can access it, you can read whatever you want from it. By being an input, it makes sure that the data cannot be modified, and it makes it so that it does not receive a copy, instead it uses a reference. And if you did want to modify it, then of course, over here you would use a ref, and it worked just fine. Alright, so that's the ref, out, and in keywords. These are very interesting, very useful keywords. It's a super easy way to either output more data from a function, or to pass in something as a reference instead of a copy. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about data type boxing. This is an interesting feature of C# due to the fact that everything is based on the object type. Okay, so let's look at data boxing. Which, by the way, the name sounds like it has to do with boxing, as in punching people. But no, it's actually related to putting things inside a box. That's boxing. This is how you can put some data inside a box and then get it out. Data boxing is really just a term for converting something, usually a value type, onto an object type and converting it back. So for example, let's say we have an int and we have some kind of whole number, and then we can assign it to something of the object type. So create an object and assign it to int. And yep, this right here, this is data boxing. With this, we have now placed the I variable. We place this data inside a box, and the box is named O, and it is of type object. Like I mentioned, this is possible because object, this class right here, this one is the base type for every type in C#. Everything extends from this one. And specifically, data boxing usually refers to taking a value type, kind of like an int, or perhaps a struct, anything like that, and converting it into a reference type. This int is a value type, but it is being put inside a box. That box is an object type, and object is a reference type. So in memory, I just stores the value directly. It's an int, which is a value type, so it stores it directly on the stack. But then O, which is an object, this one is a reference type. So when we assign I to O, we are boxing it, so O then contains a reference, and a reference to the actual place where that is stored. Although also importantly, modifying I will not modify the value inside of O, and modifying O will not modify the value inside of I. That is because when it converts into a reference type, it converts a copy of the original data onto a reference type, not the original data. And in terms of performance, it's actually pretty important. Value types exist on the stack. The stack is super fast, super performant memory. Whereas the object, by having a reference, this one is going to be stored on the heap, which is quite a bit slower. Now, since we can box a value like this, we can also unbox it, meaning get the value out of the object box. And the way we do that is just with a cast. So let's go inside of O and cast it down into an int. And yep, just like this, super simple, it works. Now, of course, if we try casting it to the wrong type, let's say into Boolean, let's put here bool b. Yep, if we do this, we don't get a compiler error. That is because object, this one technically can be castable down to a bool. It just depends on what data is actually inside that object. But if we try this, we're going to see a runtime error, so let's test. And if there it is, a simple invalid cast exception. We cannot cast an object of type int32 onto a boolean. So basically, we need to know what data this object is holding. We need to know that so we can use the correct cast. And if you want to protect yourself from errors like this, you can just put all of this inside a try catch and catch for an invalid cast exception. So now as to when you would use boxing, we actually already saw one use case when using events, just like this when using the standard event handler. So this is the C# standard to use this delegate type. And this one, for the signature, we can see it as an object sender and the event args. So basically with this, with the sender being of type object, this means that it can be anything, it can be of any type. Usually when you fire off this event, you fire off whatever class is firing off this event, and then later on in the listener, usually you know what type is going to be fired, so you know which type to cast it to. Or another potential use case is doing something like, for example, a list of object. You can do this, do a brand new list, and then on the list, you can instantiate it with whatever you want. So over here, I can put an int, I can put a boolean, I can put a string, all of this does work. Because again, object is the base class upon which everything is extended from. So if we make a list of object, that list can store literally anything. Although this particular use case is definitely something that you would only very rarely use. Using object and data boxing, that's a really interesting quirk of C#. But in most cases, chances are there's a better way to do things. So in this case, making 3 separate lists for each data type, that would make quite a lot more sense. So while you can technically do this, you should really only do this as the last possible option. Alright, so that's data boxing. It's an interesting quirk of C# due to the fact that everything extends from object. Because that means everything is convertible to and from object. Just make sure you use it sparingly, only when you absolutely need it. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about dynamic in C#. This is a really interesting feature of C# that allows us to write code against a type that doesn't actually exist. Okay, so here let's see the dynamic keyword. Now this is a very special, very unique thing. We use it kind of like defining a variable. So we write dynamic, and then we give it some kind of name. Let's say just D. If there it is, with this we have defined the variable D, and it's of type dynamic. Now what dynamic means is we don't actually know what type this is. The type will only be defined at runtime. That's very important. So this is somewhat similar to var. So for example, if we say var v equals something, if we do this, we also don't specifically define a type. However, var, this one is being evaluated at compile time. So when the code is compiling this line, it looks at what comes after it and infers the type. So when it comes to runtime, var doesn't actually exist. When it comes to runtime, var is replaced by an int. Whereas over here with dynamic, at compile time, we still don't know what type this is. We're only going to know at runtime when this code actually executes. So that also means that within this type, we can do anything we want. For example, let's say this type is a new object, something like this. And then over here, we can call whatever we want. So we can call some kind of test function. And if there's no error, we can access some kind of field and do something. And if no error, that is because, again, right now we have no idea if this is right or wrong. Maybe when this code actually runs, maybe the object that is inside of this one, maybe that object does have a test function, or maybe it doesn't. For example, in this case, it will not work. Here we construct a brand new object of type object, and the object type does not have anything called a test function. So if we try running this, and if there it is, we have an error, a runtime binary exception. It is saying object, the type object, does not contain a definition for test. So you can write whatever you want after this, you can write whatever function name, field, property, whatever, and you won't get any compile time errors, but during runtime it will check, and if it does find some function or some property with that name, then it runs it. If not, then it throws that error. This is the really important thing about dynamic. It is how it only runs at runtime and not at compile time. During compilation, it assumes that whatever you did with this dynamic object, whatever you did is correct, it is what you wanted to do. Only in runtime does it actually try doing something, and if it can't, then it throws an error. So in order to see a positive result, for example, every object always has a toString function. So if we run this, if there you go, the program runs, no errors, everything is fine, because again, toString does exist within the object. But we only saw that during runtime. So now with this, you might be wondering, where exactly is this useful? It does seem a little bit strange. I mean, right here, if this is what we want to do, then naturally, instead of making this dynamic, we would make it object. And that way we can't write something like this, we get a compiler error. So if you want to do this, and obviously using dynamic doesn't make any sense. If you know the object type, then just use the object type. However, where this is particularly useful is when dealing with something like JSON data from a web server. The data schema might change over time, so you might not be able to define the exact type over here. For example, here we have some simple JSON. So it's just an object, inside it has an assets, and this asset is actually an array. And within the array, it has 3 separate objects. Those objects have a type field, a name field, and a path field. So let's say, for example, we receive this JSON from some web server. Like for example, maybe some modding site, and this is the data that we need in order to install our mod in our game. Here with the JSON, now the first thing we do is convert it into a dynamic object. And one simple way to do that is with the Newtonsoft JSON library. That's the most popular, very capable JSON library. In order to install it, let's go over here on the Solution Explorer. Let's right-click on the project itself. So not on the solution, right-click on the project. And then down here, let's go into Manage NuGet Packages. And up top, just go into the Browse tab and then search for JSON. And there it is, the main one, Newtonsoft.json with 5 billion downloads. So yep, let's go ahead and install this one. And then with that package installed, over here we can use the class JObject, which exists inside of this namespace, Newtonsoft.json.LINQ. We can use this and we can call the parse function. This one takes a JSON string and returns an object. So let's parse our JSON and let's put this inside a dynamic object. So dynamic, let's call it JSON dynamic. And yep, just like this. And now here we can do whatever we want inside of this object. So for example, we can go inside of this one, we can access the assets. And again, note how we have no auto-completion because once again, dynamic does not know what type this is going to be. So let's make sure to write it properly. So assets, and assets is going to be an array. So let's access the first element on that array. And then let's just access the type. So it should be this one, it should say texture. So this, let's put this inside a console.writeLine. Let's print out this and see exactly what it says. And if there it is, it does say texture. Alright, awesome. So you see how here we define some structured data, but we have no class, no struct, we have no actual type defined that matches up this structure. But thanks to dynamic, we were able to load it onto a dynamic object, and then we were able to go inside it, write all the names for all the properties, and get whatever data we want. So it works perfectly fine for accessing something, but if we access something that does not exist, let's say, for example, that we go on assets instead of assets, let's call it asset, which does not exist. Yep, of course, we get the same error. So if we want to test if a dynamic object has a certain function or property, for that we have two methods. So one option is using reflection. So we can go through JSON dynamic, we can call getType. This is going to return our type for this, and then we can call getProperties. And yep, we get an array of property info. So the same as with any other type of reflection. You can watch a lecture on reflection for more on this method. Or another alternative is to simply try to access it. So for example here, let's try reading this. So string for the type name. We read this and we read inside of asset, which does not exist. And if this one naturally throws an exception. So this is how we can test it. We can put this inside a try catch. And let's catch for that one. Catch for a runtime binder exception. And if it happens, then that property does not exist. So you can do this to go one by one throughout your dynamic type in order to figure out what exists inside of there. Then dynamic can also be a return type of a function. So here, let's do something and return dynamic, some kind of test function. And then here we can return whatever we want. So we can return an int, we can return a boolean, we can return a float. All this does work. Or we can even actually return an anonymous type. Yep, this is perfectly valid code. By the way, I cover anonymous types in another lecture. And then up here, we can simply call test and grab whatever returns from there. Then inside that one, we can access, for example, the name. Let's do console.writeLine. And if there it is, and it does work perfectly. Now, before we end this lecture, let me also give you just one quick tip that is somewhat related. It's related to JSON here. Like I said, the goal with dynamic is that you don't know exactly what the schema is. If you don't know that, then use dynamic. But if you do know, so if you know your JSON is always going to have this format, if so, then you should create an actual class with all of this data. But doing that by hand is actually quite tricky. You would have to write some kind of class, call it JSON data. Then you would also have to define another class for something like asset single. Then on this one, you define a string for the type, the name, and so on. So you can write it manually one by one, which when you have some complex JSON, that can actually be quite laborious. Or alternatively, Visual Studio actually has a super simple, super helpful answer. You just copy your JSON, the JSON that you receive from whatever web server, whatever you have, just copy it onto the clipboard. And then up top, go into edit. Then let's go into paste special and paste JSON as classes. And if there you go, it automatically creates this. So it creates our single asset that has a string name, path, and so on. And if these were Boolean or a whole number, then it would change the type here. It would not make it all string. And then for our root object, so that's the main object, just has an array of assets. So you have just a quick tip when dealing with JSON. If you don't know the data schema, then use dynamic. But if you do know it, then use that in order to get the actual type and then work with it with the actual type. All right, so that's dynamic. It's a really interesting feature of C# for working with types where you don't really know what the type is until runtime. This is super useful when contacting something like a web server and getting data without knowing the schema beforehand. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to create a custom class indexer. This is how you can access some data in your classes using an index, kind of like an array or a list. Okay, so here let's learn and build a custom indexer. Here we have a very simple player stats class. This one just stores various stats. Then up here we are just constructing it, super simple. And now let's say we want to access these player stats kind of like an array. So I want to access, for example, player stats, access it like this on index 0, and I want this to give me the strength amount. If we try doing it like this, then we have an error. It is telling us we cannot apply indexing with these square brackets. We cannot apply that to this type, the player stats. So let's build it. Now the way we do it is actually like a normal property. So let's go over here. First for our property, let's make it public. Then we can make it return anything. In this case, let's make it return int. And now here's the important part. Instead of having a name kind of like any other property, instead of that, we have to name it with a this keyword. We do that, and then we add these square brackets. So basically, this property is what is going to happen when we try to access this specific type using square brackets. Then inside these square brackets, we put our indexer, and for the indexer, we can use whatever type we want. Let's go with int just for simplicity, and then name like index. Yep, like this. Okay, so this is our definition. And now, just like with any other property, we can define a get and a set. So let's do a get. So get, open and close the curly braces. And then for the get, we just need to return something. So in this case, depending on the index, we want to return a different field. So let's do a super simple switch, do a switch on the index. And in case we receive 0, let's return the strength. In case we receive 1, let's return dex. And in case we receive 2, let's return wisdom. And in case we receive anything else, so on default, let's just throw a new index out of range exception. Okay, yep, just like this, we no longer have any compile errors. So we define it kind of like a property with the special keyword this. Then we put our indexer. Inside, we define the get, and we do whatever logic we want. So now here, yep, this one no longer has any errors, so this one is now perfectly valid. So let's try doing a print on this. So console, let's write line, let's write our strength, and it should say 12, so let's see. And you're correct, it does say 12. So by this, we are accessing our custom player stats type, we are accessing it with a custom indexer, and everything works great. All right, awesome. So this is working, and just like with any property, we can make this read-only, meaning only define a get. Or if we want, we can make it read and write by also implementing a set. So let's do the exact same thing. So a set, just like any other property. Let's do a switch on our index. And in case we are on index 0, then let's set the strength amount equals the value that this one receives. Then same thing for all the other ones. So case 1, case 2, and then the same default. And if default, let's throw an exception. Okay, yep, just like this. So now up here, let's read the player strength. And then let's write to it. Let's write something. So let's set it to like 99, and then let's read it again, and let's see. And if there it is, the first one says 12, yep, makes sense. Then we override it, and then that one prints out 99. So yep, everything works, super simple. So here we have our custom indexer. So we have a custom type, and we define this logic so we can access it using simple square brackets, and then we can run whatever logic we want to get whatever values we want. As you can see, it's really simple to build, and it lets us use our custom type kind of like it was a list or an array. However, down here, the index, this one doesn't have to be an int. You can use whatever you want. So for example, we can actually use this stat enum. So let's find a stat for a stat. Then up here, same thing, just do a different switch and doing case on stat.strength, do something and so on. Yep, just like this, everything works perfectly fine. We just refactored and made this one receive a stat instead of an int. So now we go up here and instead of using an int, which, by the way, the reason why this isn't throwing an error is because every enum is automatically convertible into an int. But over here, we want to use a proper player stat. So let's use it. Let's say we're working with strength. Let's print that one out. And on this one, same thing, print the strength and print the strength. Okay, let's see. And yep, same thing, it does work. So over here, we can see how the indexer, the type over here can be whatever you want it to be. And yet another thing this also supports is multiple indexers. So we can add, for example, an enum and then an int for some kind of index. And yep, this works. This is perfectly valid code. Then you can use both of these in any logic you want inside of any of these. So for example, this could be really useful if you're accessing some multidimensional data to receive an index for the X and Y. All right, so that's how you make a custom class indexer. With this, you can make your custom classes much more usable in various scenarios by making it really easy to read or write some data, just as if it were a list or an array. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about attributes. This is how you can add some extra information, some metadata to your code. Then you can read that metadata and do whatever you want with it. Okay, so let's learn about attributes. Now you probably already know exactly what are attributes. If you're a Unity dev, then you've certainly already seen the one that is called serialized field. Here I'm running this code just on the C# console, so that's why it's throwing an error. This is a Unity specific thing. But anyways, usually you use this one, then use some kind of private field. So like a float for a move speed, something like this. And by using this attribute, it means that this field over here, this one will be shown in the inspector, even though it is marked as private. So basically this attribute over here, this one is adding extra metadata to something, in this case to a field. And then the Unity inspector is running different logic depending on whether this attribute exists or not. So that's really what attributes are. They add extra metadata, and then you can do something based on that metadata. And attributes can also be applied to pretty much anything. So we can apply it over here into some kind of field. Then we can also apply it to a function, to a class, and so on. There's a bunch of built-in attributes. Like for example, one of them is serializable. This makes it so that this type becomes serializable. Then if you want, you can mark some methods as obsolete. If you do and you mouse over an object, it says that it is deprecated. Then you can also use DLLImport to import some external libraries and a bunch more. But beyond the default attributes, you can also create your own. And doing so is quite simple. Let's say we want to define an attribute to mark a bunch of classes as being of a certain type. So we want to mark classes themselves as being like a unit, an object, and so on. We want that to be part of the class metadata as opposed to storing some kind of enum field. So the way you construct a brand new attribute is, first of all, you define a class. So let's make a new class. Then you give it a name. In this case, we want to mark certain classes as being of a certain object type. So let's call this isObjectType. And then for attributes, you append the word attribute, so attribute. So isObjectType attribute. Okay, great. This is our class, and then we just need to make it extend system.attribute. Yep, so this one is now marked as an attribute. Then inside we can define a constructor. So isObjectType, we have the constructor. Inside, if we want, we can make it parameterless, or we can actually receive some data. In this case, let's say we want this attribute to receive the object type. So up here, let's also define enum for some kind of object type. Then we have like unit, like object, prop, and so on. And over here, let's receive a field for our object type, just like this. And then we simply store it. So up here, a private for that one, like that. And on the constructor, we just set it, this one equals this. Yep, that's it. Here is our very simple attribute. And like we saw, attributes can be applied to almost anything, but you can also limit that to certain specific use cases. The way we do that is by adding an attribute to the attribute itself. So over here, let's add one. Let's add the one that is called attribute usage, this one right here. And if this one takes a parameter, we can see that it is valid on, and we can see we have all kinds of possible options. So we can make this attribute valid just on assemblies, modules, classes, structs, just on constructors, on any kind of method, fields, and so on. So you can really define where your attribute should be applied to. And also note on the values for all of these. So that one has a value of 1, that one has a value of 4, 32, 4096, 16, and so on. Note how they are all power of 2. So if you've seen the previous lecture on bitwise operators and bitmask, then you already know, yep, this is a bitmask. Each of these occupies a different bit. So because of that means we can also do all kinds of combinations. So for example, for this one, let's say we want to apply to classes or structs. So we can do class, and then we can do the bitwise OR. Again, important, it is not a Boolean OR. Nope, just one pipe, just a bitwise OR. So let's make it apply to classes or structs, meaning it works on either of those. And yep, that's really it. Now to apply to something, for example, let's make some kind of player class. So class, some kind of player. The player is meant to be a unit. So we can apply our attribute. We can use isObjectType. Note how we don't include the attribute, so just the name is object type. And then since we added the constructor, over here let's put object type, and let's say this one is a unit. And yep, that is it. Although if we try adding this to, for example, over here to a function, if so, then we get this error. It is telling us this attribute is not valid on this declaration type. It is only valid on class or structs. So yep, just like this, we define a brand new attribute and we attach it to our custom class. So now the next step is for doing something with it. And the way that we run some logic and check for attributes is actually with reflection. Now I've already covered reflection in detail in a dedicated lecture. For example, for up here, let's try doing that. So let's do typeof in order to get the type of our player class. Then from that one, we can call the function. We can get all of the custom attributes. So get custom attributes. And we can either get all of them, or we can look for a specific type. In this case, let's look for just of our custom one. So typeof for the isObjectType attribute. So let's look for that one. And for inheritance, doesn't really matter, so let's put it on false. Yep. So now this one over here, like it says, it is going to return an array of object. The reason why it's an array of objects is because it's going to return potentially multiple attribute types, so they have different types. So up here, an object array for the attribute object array. And now you can cycle through this array and test if it is of that type. Now in this case, we already know it is going to have one of this type. So we can just grab the one on index 0 just for testing. Let's cast it onto our type. So isObjectType attribute. So we have our isObjectType attribute. And then with this object, we can grab whatever data we included inside of our attribute. So let's do a console.writeLine. Let's write line going to that one, and let's expose something to get the object type. So public object type, get the object type, and just return the object type. Okay, like this. And up here, let's call that one. And let's see, we are looking for the data inside the attribute on the player class. So this one should return unit. Let's see. And if there is, the player class does indeed have an attribute, and that attribute does indeed have data for unit. Okay, awesome. All right, so those are attributes. It is really just metadata that you can apply to a class or a function or literally anything. It is really just metadata, just extra information. So it's really up to you to define what that data means. Using this, you can do all kinds of analysis or build some helpful tools. Do anything that does any processing or any analysis on any of your types. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about anonymous types. This allows you to essentially create a completely brand new custom type on the fly without having to first declare it. Okay, so here let's learn about anonymous types. Let's say, for example, we want to define some kind of type that will hold a string for a name and an int for an ID. And one way to achieve that is obviously by defining a normal type. So we can do a public class, call it player, then inside define a string for some kind of player name, and then int for some kind of ID. Then up here we can construct something of new player, and then assign whatever that we want. And if that's it, this works. We define the type and then we use it. This is what you should do if this type is something that is widely used, something that you use in a lot of places. But what if, for example, you just need this type, you just need to organize this data just in a single place? What if it's used in just one tiny use case? What if you really just want to organize some data? If so, then for something super quick is instead of defining a normal type like this one, instead of that, you can just use an anonymous type. So let's not define this. And instead, for defining an anonymous type, first we write the keyword new, and then we don't write any type name, nothing like that, nope. Instead, we just open the curly braces right away, so just like a normal object initializer. And now here we can define whatever properties we want with whatever data we want. So for example, let's say name equals CodeMonkey, and ID equals 1. And yep, just like this, here we have our perfectly valid anonymous type. Then we can assign it to something. We can assign it to some kind of variable. But since this type has no name, we can't really write a name for the type. We can't write int or something like that. We can't write a type name because no type name exists. What we can do is simply use var. So var and then the name, let's say player data equals this. And yep, here we have our type. And if we mouse over player data, we can see, yep, here Visual Studio is telling us that this is an anonymous type. And inside it, we have a string for a name and an int for an ID. We can also do a log on this and see. So console, let's write line. And if there it is, name CodeMonkey, ID equals 1. So here we have constructed our anonymous type with our data. Then we can also access it, so we can go inside player data. And over here, yep, we can see autocomplete already shows us everything inside of this type. So it has the default functions that every single type in C# has. So get type hashcode equals into string. All C# objects, all C# types have these functions. And then it has the two specific properties that we just defined, name and ID. Now also, one very important thing about anonymous types is they are read-only. They are immutable types, meaning that we can read data, so we can access the name, we can print this, we can read it, but we cannot modify it. If we try modifying, nope, we have an error. It is telling us that the property name cannot be assigned to, it is read-only. We have this error because this is a property and it's a property with just a get defined. Also importantly, they are properties, they are not fields. That is why I named them in this way, using Pascal case instead of camel case. That is because anonymous types, the data that they store it inside properties and not fields. So anonymous types are really meant for read-only use cases. Like for example, you just want to organize some data in some nice structure. And if your goal is just organization, then you probably do want read-only, so this is perfect. If you want something with read and write access, then you should probably define a normal type, or a tuple, which is something somewhat related that we're going to cover in the next lecture. So essentially, anonymous types, those are all based on inference during compile time. You already know how var, this is a compile time feature. During compilation, the compiler looks at the variable. It looks at what var is being assigned to and use that to set the type. So if we do var I equals some number, if we do this, then when the compiler goes to define the type for I, it looks and sees what is being assigned to it. In this case, it's a whole number, so it defines I as being an int. And it's really the exact same thing over here for the anonymous types. The compiler infers the type for each of these properties based on the value assigned to them. So that's why this one is an int, this one is a string. And then the compiler constructs a brand new entire type just to store this data. So literally the compiler in the background is storing something like what we had previously. So something like a class, player data, with a public string name. And this one is a property with just a get no set, and a public string ID with again also just a get no set. So when we do this, the compiler is auto-generating a type just like this one. And then it assigns that type, that instance of that type, assigns it over here to the player data. Now we can actually see the type for this. We can go inside player data and call the get type. Again, the standard function that every single type has. Let's do a console.writeLine on this one to see. And if there it is, we can see this one is of type, anonymous type. And inside has two parameters. It has a string and an int. So this is the type. It's an actual type. It's a normal type just like any class, any struct. But it's simply auto-generated during compilation. Now this is quite different to what we covered in a previous lecture, the one on dynamic. When you make something dynamic, this one is all based on runtime data. Meaning during compilation, it does not run any checks, it does not create any types. Meaning it does not validate any data at compile time. So over here we can access name, which does exist, but we can also access something that does not exist. Again, because dynamic is only handled at runtime. Whereas var, and anonymous types, this is handled during compile time. And if so, over here we have validation, and we know, okay, this type does not have anything called test. So if you ever get confused about anonymous types, do remember this part. It helps a lot in understanding how they work. If you look at it from the point of view of the compiler looks at this data and uses that data to infer and create types. So for the data inside the anonymous type, this can be anything you want, as long as the compiler can infer the type. So for example, you cannot define here something as null. This does not work, this is an error. It is an error because null can be anything, it can be pretty much any type. So just like this compiler has no idea what type to make this name, but we can, for example, define a class, a normal class, and then up here do something like this. And yep, now this does work. Another thing we can do is put anonymous types inside other anonymous types. So over here, let's define a type, let's call it message, and we do a new anonymous type, and just say something like message. Yep, so here we have our nice anonymous type, and then inside player data, we can also add that. So we can add message equals our message anonymous type. And then through this one, we can access message, and inside we have the actual message. Also, instead of writing message equals message, if you're defining a new anonymous type with something that is already stored in a variable, you can just write that variable. And doing this, it will essentially name this property with the exact same name as this variable. So if we go inside player data, we can see, yep, we do have a message there. So when using other data to create data inside our anonymous type, we can just pass in the variable that stores that data and we don't have to give a specific name. Then, like I said, anonymous types are read-only, meaning you cannot create and modify it. So over here, player data, set the name equals something. Nope, this does not work, this has an error. But what we can do is use a with expression. We can use that to create a new type based on another one. So for example, we can construct a new player data. Okay, great. And then we construct a new one. So var player data 2. And for this one, we can base it on the original player data based on that one. And then we write the keyword with, and then we can open and close the curly braces and modify some data. So let's say name equals Ironman. And yep, just like this. So basically this is going to start with the data inside of player data and then applies an override to the name. So here, if we do a console.write line on both these, so on player data 1 and player data 2, if there it is, so the first one is CodeMonkey idea 1 with message, and the second one has the same ID, the same message, but a different name. However, importantly, we did not modify the original anonymous type. We did not modify that one. That one is still read-only. We simply construct a brand new one based on a previous one. So here we can define an anonymous type with really whatever data we want. And then we can also define an array of anonymous types. So to create a new array, we do new, and then again, it's an anonymous array, so we don't define any type. Instead, just open and close the square brackets, then open and close the curly braces to initialize our array. And now here we can define our anonymous types. So let's do one. Let's say something like name equals something. Yep, just like this. And again, we can assign this to a player data array, just like this. And yep, here we have an array of anonymous types, and it has 4 elements, 4 with all of this data. Now, one very important thing is the anonymous types here, they have to have the exact same format, the exact same properties. If we add a different property, let's say an ID to just one of these, if we do, then this one does throw an error. So it has to have the exact same properties. And it's also important that they are in the exact same order. So if we have the exact same ones but are in a different order like this, nope, we still have an error. Again, that's because of what I mentioned, how the compiler is creating an actual type based on this data. And if we have one with a different format, then it needs a brand new type, and the compiler does not let us create an array using multiple different types. By the way, actually, there's one exception to that. If we make this an object array, if so, then yep, no, this one does work. Object is the base class for every C# object, every C# type. So if you make an object array, you can indeed store literally anything in there. I covered something like this in the lecture on data boxing. By doing this, we can store multiple object types, and we can see there are multiple object types if we, for example, put the cursor on it. And yep, Visual Studio automatically highlights the exact same properties on the exact same type. And note how these 3 are highlighted, but this one is not. That is because this one is a completely separate type from these 3. So when making arrays of anonymous types, do make sure they all have the exact same structure in the exact same order. So just like this. Now, one use case where anonymous types are very useful is when doing LINQ queries. I already covered LINQ in detail in a previous lecture. Essentially, LINQ is a way to do operations on collections of data, similar to how you do queries on a database. So here, for example, we have our player data array. Now let's say we just want to get the players just on the red team. So for that, we can do some simple LINQ to get that query. So let's go inside the player data array. And this one, let's call where to write a condition. And for the condition, we're going to have a player data. And we want to select just ones on the red team. So let's go inside player data and select the team equals red. Okay, so we do a query for where the player data team is red. And then let's just call select in order to select some elements. We're going to get the player data. And it's over here that we can construct a brand new anonymous type. Let's say that after getting the red team players, we just want to keep the name. We no longer care about the team. So here we can construct a brand new anonymous type. and you set the name equals the player data.name. Or again, the same thing that we saw previously, literally just put it player data.name. And yep, this constructs the anonymous type, and over here, just make sure this one is a lambda expression. Okay, so yep, so just like this, we can put the resulting thing inside of our, let's call it the red team array, and then we can cycle through it. So let's go for each var red team in the red team array. Let's do a console.writeLine, go inside the red team and just grab the name. Okay, let's see. And if there it is, CodeMonkey and Black Widow, which are indeed red team and red team. So yep, here we are cycling through some data, and for the selection, we are constructing a brand new anonymous type that holds just the data that we want. Importantly is how this code is actually quite readable, and we were able to do this without having to construct a brand new different type just to store the player name. If we had created a brand new type just for this one use case, if so, that would clutter our project, since this new type would only really be used here just in this one function. So with this anonymous type, it works perfectly for this use case without adding any clutter to our project. Now, like I said the words on this use case, anonymous types are excellent, so you should definitely use them where they make sense, but you shouldn't use anonymous types for literally everything. The rules they have actually make it perfectly clear how they are meant to be used. So first, remember how they are read-only. So you are only meant to use them as a way to organize some data temporarily, not something like long-term storage. They also cannot have any functions or events, just read-only properties. Then, since they are meant for small temporary use cases, you cannot store the anonymous type in a field, you cannot pass it on to a separate function. Although I should say, technically you can actually do that. If we make here a public static void test, and up here for the parameters, we receive something of type object. And again, object is literally anything, any type extends from object, so we can call test, pass in the player data, and this does compile. But again, this one really completely defeats the purpose, because right now we have no concept of what data is inside this object. So technically you can do this, but you definitely shouldn't. All the rules of the anonymous types, they are there for a reason. If you ever find yourself running into the limits of all those rules, then that's probably a sign that you should be using a normal type instead. Anonymous types are absolutely excellent for exactly what they're meant for. Small, simple data structures for organization. That's it. For pretty much anything else, just define a normal type. Now, one feature of C# that is quite similar to anonymous types are tuples. They also allow you to create types with no previous definition. They also allow you to organize and structure some data. We're actually going to learn about tuples in the next lecture, as well as a rough guide for when to use tuples and when to use anonymous types, and what exactly are the differences between them. Alright, so here we learned about anonymous types. This is how you can easily organize some data in a proper structure without having to first define a normal type. This can be faster and more readable. And the specific rules that you must follow, those ensure you only use anonymous types in the way they're actually meant to be used. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn about tuples. This is how you can basically create brand new types to organize some data without having to normally define it. Okay, so let's learn about tuples. And here in this lecture, I'm actually assuming you've seen the previous lecture on anonymous types. Those two are somewhat related, they solve similar problems, but they also have their differences. I'm going to cover those differences as we go through this lecture, and also a general conclusion of which one you should choose at the end of this lecture. So, just like anonymous types, tuples let us create a type with no name without having to previously define it. And to define a tuple, we have multiple ways. The simplest one is to use var, so let's use var, call it my tuple, and then we do an equals, and then we open our parentheses, and inside we put our data. So let's say on this one, we want to store the string CodeMonkey, and then the int value 56. By the way, tuples need to have more than one piece of data. Otherwise, this one is really just a normal field. So this is just a string, and this is a tuple. Okay, so here we have our tuple. And right away, we can actually do a log on this and see what this creates. And if there it is, that's our tuple with CodeMonkey and 56. So we construct a brand new type, and that brand new type now holds these two pieces of data. We can mouse over the type and see. And yep, here we do see our tuple definition. It stores a string and an int. So this one over here, we are defining the type. And then we can use it, so we can go inside my tuple and access all kinds of things. And yep, inside we do see these two, item 1 and item 2. So item 1, this one is a string, and item 2, this one is the int. And here we can already see a difference between tuples and anonymous types. On the anonymous types, in there we had read-only properties, so properties with just a get. Whereas this is a normal field, because that means this one is read and write. So we can read this, we can read it with something, and we can also modify it, and it does work. Although here we also see one thing. We see that it is called item 1 and item 2. Those aren't very descriptive names, but thankfully we can actually give them proper names. So here when constructing it, we can give it a name. So we can write, for example, let's say name, then a colon, and then some kind of value like that. And now inside my tuple, we still have item 1 and item 2. We can still use those two, and that is not a compile error. So if we use item 1, yep, that one still refers to the string, But since we have proper names, we can also use those, so we can use the name and we can use the value. Alternatively, the name can also be inferred if we pass it in using a named variable. So string player name, let's call it CodeMonkey, and then int for the value with some value. And then up here, we just use our player name and we use our value. And then we can actually go inside and access, yep, the player name, the value, it is right there. So yep, all this works great. Then yet another way of defining tuples is with the types over here in our parentheses. Instead of using just var, we can define string and then int. And yep, this is our tuple definition. And again, with no name, we can access it through item 1 and item 2. Or of course, over here when defining, we can also give it names. So the player name and the value. And then if we go inside, yep, we do see it. Then tuples can also have a very large number of fields. So we can define, let's say, a var, call it big tuple. And inside, just open and close the parentheses, and we can write as many fields as we want. So yep, there's a giant tuple, and if we go inside big tuple and try to access it, yep, here we see item 1, 2, 3, all the way up to 20. Now, one main use case for tuples, and actually another big difference between anonymous types and tuples, is how you can actually use these inside functions. For example, returning some data from a function. Usually you have just a single return type. So you've got some kind of function, and over here you define the return type, but that can only be one thing, just one piece of data. Although, like I've also covered on the ref and out keywords lecture, using those you can return more data from a function, so that's one option, but you can also do that with tuples. So here for the return type, instead of just one type, we can define a tuple, so just put it inside parentheses. So just like a string and then an int. We can also optionally assign the names to these parameters, so like this, call it get tuple. And now inside we can return, and we can return a brand new tuple. Yep, just like this, and up here, var tuple equals get tuple. And if we go inside tuple, we can access the name, and if we do a console.writeLine on this one, yep, there's a tuple that we receive, exactly the one that came from the function. So this is one common use case for tuples, returning some data grouped inside a tuple. Or yet another thing tuples can do that anonymous functions can't, is actually being passed onto a function as a parameter. So over here on the parameter, same thing. Let's define a bool, b, and a float, f. And if there it is, this one is perfectly valid code. Now, one really interesting thing about tuples is the concept of destruction. This is how you can take your tuple that you have. This one, again, is a type that groups multiple pieces of data together into one anonymous type. And then you can essentially deconstruct it into separate variables. So here we have our tuple, and then we can essentially write the same syntax for defining a tuple, but without a name. So the parentheses, let's define our parameters. So let's say player name, and then for the value. And then instead of giving it a name, instead of that, we just do equals right away, and then equals our tuple. In doing so, what this is doing, this is essentially defining these two local variables, and then taking pieces from inside of this tuple and assigning them to these local variables. So this one is now a perfectly normal local variable. So we can do a console.writeLine on this one, and we can see, yep, that one does say Iron Man. So basically this line over here, this one is going inside the tuple, and inside the tuple it has a name and a value, and it grabs both those pieces and place them into separate local variables. So what we have here is very much the same thing as doing like string player name equals tuple.name and int value equals tuple.value. So basically up here in this one line, this one compact syntax, in this we are doing the exact same thing as here. Now if you want to simplify it even further, you can actually use var, so we can erase the types from here, and instead in the beginning write var. And if there you go, exact same thing. Var means the compiler will infer the types for both of these, and again, these are going to be in local variables. So whenever you have some kind of tuple, like some kind of function that returns a tuple, and you want to split it into multiple local variables and do it, then yep, that's where tuple construction comes in. It is really useful for breaking it apart to do whatever you want with each individual piece. Then these tuples that we've been using, these are actually called value tuples. So the actual class that we've been using is system.valueTuple. It is this one right here, actually the one with generics. All this syntax is doing, this is really just a shorthand for value tuple. We can actually verify that. So let's do a console.writeLine and let's print out the mytuple.getType. And if there it is, we can see, so this tuple is of type system.valueTuple and does have a string and does have an int. So as you can see, this is another difference from those anonymous types. Anonymous types create an actual anonymous type, whereas tuples, those are essentially new versions of that tuple generic. And C# actually has yet another type of tuple. This one is called the system.tuple, and there's some big differences between these two. First is how value tuples, those are value types, whereas this one, system.tuple, this one is a reference type. So that has all those normal implications regarding copies and references that we covered in a previous lecture. Another big difference is how system.tuple, this one is immutable, meaning it cannot change, similar to anonymous types, they are read-only. Whereas value tuples, these are mutable, we can modify them. And for value tuples, the data is stored in fields, whereas in system.tuple, that data is stored in properties, again, similar to anonymous types. So out of all these three seemingly related types, which one should you choose? And the official C# docs actually has a great page on it. So here are the key differences. So anonymous types, in terms of the access modifier, the sizeof is internal, whereas the sizeof is public. This has to do with if you are working with multiple assemblies. Then anonymous types, those are class. So again, reference types, same thing for tuples, but value tuples, these are struct, value types. Then with anonymous types, you can make a custom number name. So you can name it like player name, value, and so on. Same thing with value tuples, but you cannot do that with tuples. The construction, that really useful thing, that one is only available over here on value tuple. And for expression tree support, that's those lambda expressions that are mainly used in LINQ. For that, you can use these two, but not value tuples. Alright, so that's tuples. Really great way to create a type with some fields without having to define a normal type. They have a bunch of differences related to anonymous types. They are mutable and they are value types. So if you need to organize or structure some data, this can be a really useful tool. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to implement the IDisposable interface. This allows us to write some code with the using statement that will automatically dispose of any resources. Okay, so C# has an interesting built-in interface. It is called IDisposable. This one is implemented automatically by some classes, like for example the file class. So if we go inside the file class and we open some random file for reading, so open, then for the path, let's say myfile.txt, something like that. And for file mode, let's open just opening. So this returns a file stream. Yep, here we are opening our file. And what this is doing, it's using up some memory to open and load the file. Then we can do whatever we want from it. Like for example, let's go inside the file stream and let's read a bunch of bytes. So we read a bunch of bytes. And then after we do whatever we do with this file object, afterwards, we need to remember to call dispose. So need to go into file stream and call dispose. We need to do this in order to clear up the memory used by this class. If you forget to call dispose, that's a problem. You're probably going to end up with a bunch of memory leaks. So in order to help you not forget that, C# has a nice way of doing things. So instead of doing this, do that, then read all the stuff and manually call dispose. Instead of that, we can write over here using, then open the parentheses. Inside we construct our object. And then within the curly braces, we do whatever we want with our file stream. And that's it, then we close. Basically, by using this using statement, by doing this, this will ensure that dispose is called on this object right as soon as this code block terminates. And the reason why using exists, again, is because file stream, this one does implement the IDisposable interface. So this can be really useful for any class that requires any kind of cleanup. It can be memory or really just resetting some kind of state. And if you want your own custom types to also support this format, if so, then all you need to do is just implement the IDisposable interface. So for example, let's say we have a class for some kind of save system. We have something like this, and if we try using it in a using block, so using save system equals a new save system. If we try doing this, then nope, obviously we have an error. It's telling us this type being used in a using statement must be convertible into IDisposable. So let's add that over here. Let's implement IDisposable. Okay. And this one requires us to implement something. It requires us to implement the dispose function. And here, quite simply, we write whatever cleanup code we need. Basically, this function will be called automatically when this using code block ends. We can actually verify it. So let's add a console write line. Let's write a log and say dispose. Let's see. And if there it is, it did call dispose on our save object. So now here we can write whatever logic we want. Like, for example, on the save system class. Perhaps on the constructor, so public save system. Perhaps on this one, we would create some kind of file for opening. So we've got a private for a file stream. We would have this. Then over here on this one, we construct a brand new one. So we do a new file.open. Let's open some kind of save file. So you could do this, open it. Then we would have, I don't know, maybe some kind of function to save some data. So save player data. You would save some kind of player data, do something on the file stream, then do another one for like save object data and so on. So you can do that, and all these functions would write to this file stream, but you need to make sure to close it in order to properly save this file. And for doing that, we could run it over here on dispose, just call the dispose inside of this one. So yep, now this simple save system class, this one is very well made and very safe from any kind of memory leaks. So up here, all we would need to do is just call save player data, save object data, and everything works perfect. Yep, just like this. By the way, one extra thing, which is over here, this dispose function, this one is running some cleanup code. But if you forget to call this function, if you forget to put it in a using statement or manually call it, if so, there is one fallback you can use. You can use the class destructor. I covered that in the intermediate lecture on classes. Basically, to define the destructor is kind of like the constructor, except you start just with a tilde, then the name, so save system. And basically, this code over here is going to run whenever this object is deallocated. whenever it is garbage collected. So here, to make sure that everything works, just manually call dispose. And yep, that's really it. Super simple. Implement the interface, implement the function, and doing so, your class can now be used inside the using statement. Alright, so that's IDisposable. That's how you can use the using code block in your own custom types. It's a great way to make sure your custom types support any kind of cleanup logic. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to write custom override operators. These allow us to customize logic on doing various operations with our custom type. It allows us to support addition, subtraction, equals, and a bunch more. Okay, so here's some code. I've got a public class, resource amount. It stores a resource type and an int for the amount. Pretty simple. And up here, let's say I want to add one resource amount onto another one. So let's first make two. So resource amount, call it resource amount 1, and let's construct a brand new one. Let's say for the resource type, this one has wood, and for the amount, this one has something like 5. Okay, then let's make another one. So let's make resource amount 2. This one has wood, but has 12. Now what I want to do is actually add both them. So define another resource amount for the resource amount total, and make resource amount 1 plus resource amount 2. So basically I want the final result to have 12 plus 5 of wood. Except, nope, we cannot do this by default. If we mouse over, we can see we do have an error. So the operator plus, so for doing an addition, cannot be applied to things between resource amount and resource amount. So that is because our custom type, resource amount, this one does not support doing addition. But we can make it supported. So the way we do it is over here on the class. We define a new function. Let's make it public. Then for this one, it needs to be static. For the return type, let's return the exact same type, so also resource amount. And then we use the operator keyword. And then for the name of the function, in this case, the name is going to be the operation. So we want to do some addition, so let's use a plus sign. Yep, like this. And then we have our two elements as parameters. So we're going to have a resource amount for resource amount A, and another resource amount for resource amount B. And yep, this is the syntax. Now in here, we just do whatever custom logic we want. In this case, we want to add both amounts. So let's just return a new object, a new resource amount. And for the resource type, let's just grab the one from inside of A. And then for the amount, let's grab resource amount A.amount plus resource amount B.amount. And yep, that's it. And just like this, up here, our error is now gone. So let's do a log and verify that it does work. So a console.writeLine. Let's print out the resource amount total. Okay, let's see. And if there it is, the math is correct. So we've got wood, we've got 17 wood, so 5 plus 12, that is indeed 17. All right, awesome. So this is how you can support math operations in your custom types. And here, of course, you can write whatever logic you want. Like, for example, we can write some validation. So we can test, for example, if the resource type is the same. So grab the resource type, this one, and check if it is different from the one on B. So if these are different resource types, then over here, perhaps we don't just add them together. So perhaps we just return either A or B. So that's one valid option. Or perhaps we simply return null. That's also a valid option. Or perhaps we simply throw a new exception. This also works. Again, it's up to you to define whatever custom logic you want to do with all the operations of your custom type. And since we can implement a plus operation, as you might imagine, we can implement all the other ones. So we can implement this addition, we can do subtraction, we can do multiplication, and we can do division. All of them works exactly the same. So it's a public static function. It returns the exact same type. It has the operator keyword and then has the symbol for the thing and then has an A and a B. So this syntax up here, that one covers all of the math operations. But then we also have equals. For example, up here, let's put the amount both exactly the same. So both are 5 wood. And now let's do a console.writeLine. Let's print out resource amount 1 equals resource amount 2. If we test this, if there it is, this one shows up as false. And the reason why it's false is because it's really comparing two references. These are two brand new objects, so they are completely separate references. So that is why this equals is returning false. But we can also override this. We can do it if, for example, we want to compare the data inside of it instead of comparing references. So we want to compare if the resource type matches and the amount matches. If so, this one should return true. So let's do that. Let's override over here the equals operator. And that works very much exactly the same thing. So let's make public static. And since this one is an equals, we're going to return a boolean, then operator, double equals. And we've got the A and B. So resource amount A and another resource amount for resource amount B. And now again, here we do whatever logic we want. So in this case, let's compare just the data inside the object. So let's return, go inside resource amount A and make sure that the type matches. So resource amount B dot type. If these two match and resource amount A dot amount equals resource amount B dot amount. If both those matches, then this one does match. Now here we can still see that we have an error. And this is telling us that the operator, if we override the equals, we also have to override the not equals. So let's do that as well. And the syntax is pretty much exactly the same. And for the symbol is the not equals. And for this one, it's actually quite simple. We can literally just use the equals and invert it. So we can do return resource amount A equals resource amount B. So this right here is going to run this logic. And if we want the not equals, let's just simply invert it. So put inside parentheses and do a not. And yep, that's it. So with this done, now up here, if we have this one, now it should be comparing the amounts inside of it, comparing the actual data inside the object instead of comparing just the references. So this should now return true. Let's see. And if that is correct, it does return true. Okay, great. So this is working, although over here we also see a little squiggle line. So we have a warning here. It is telling us that we did override the equal sign, but we did not override the object.equals function or the object.getHashCode function. If we override these two, we should also override those. Now, this is technically not a requirement. As you can see, this is not an error. It's really just if you override one type of equality, you should really override all of it. So let's do that one. And here we can use Visual Studio to help us implement these. So over here, click on this little icon. Let's override the object.equals. And yep, it creates this one. And let's put the cursor there and override also the object.getHashCode. Okay, we have these two, so now let's implement them. And by default here, it already writes some pretty nice code. So first it does a reference equals, meaning it is testing specifically for references between this and the object that it is equating against. If they are the exact same reference, meaning it's the exact same object, let's just return true. Or if the object, if that one is null, that means we are comparing something against null, so let's make sure to return false. And then down here we can write our own custom equals logic. In this case, we probably first want to test for the type. So let's test if the object, if that one type is of type resource amount. If so, then it is the same type. And then we can just use this one equals that we override. So here we can just return this object equals, so we're going to use this operator, equals, then object. We just need to cast this onto a resource amount. And if just like this, so if the object that we're comparing against is the same type, if so, we're going to run our equals logic. And if not, then it's a different type, so let's just return false. And if that's it, this is working perfectly. Now, by the way, this one does show a warning here. It is talking about the nullability of the parameter object. This is actually a setting inside of Visual Studio. Depending on how your project is set up, over here the equals will either be object or will be object nullable. So in this case, the project is set up to this, so that is why that showed up. But yep, all the code is exactly the same. So this should now be working, and up here we can test that one. So instead of using the double equal sign, let's call the equals function. So compare that one to that one, and it should be true. And if there it is indeed true. Great. And then down here for the get hash code, for this one, there are several ways of generating a hash code. And the simplest way is just with the hash code helper class. This one has a function. The function is called combine. That basically combines a bunch of values and generates an entire hash out of all of them. So over here, let's use this. Let's combine both the resource type and the resource amount. So yep, combine those and just return. So this way, if we have the exact same resource type and the exact same amount, we should get the exact same hash code. So up here, let's do that same thing. So let's call get hash code on resource amount 1, then a space, then resource amount 2. Let's also get the hash code of this one. And even though these are two separate objects, because the data is exactly the same, these should match. And if there it is, that number is exactly the same. Okay, great. Now, finally, since over here we're on the topic of equality, there's actually one other interesting interface that we should probably implement. That one is called IEquatable. So this interface like here, like it says, it is used by generic collection like dictionary, list, and linked list. It is used when testing for equality on methods like contain, index of, and so on. So let's also implement this interface. Now for this one, it is actually quite simple. So over here in our type, let's implement IEquatable, and then it takes a generic, so equatable with resource amount, okay? And now this just requires us to implement one function over here, the equals. So let's implement this interface. So up here it is, it's an equal, so similar to this one with big difference. This one is the generic object equals, receives a generic, receives an object, whereas this one down here receives a resource amount. So here we can really just do the exact same thing, just do a normal equals. Since again, the project is set up to use these with Nullable, let's first compare it against Nullable, compare the other with that one. If it is null, return false, okay, but if it is not null, then let's just return this equals the other. And yep, that's really it. So now for testing, let's go up here. Let's construct a brand new list. So a list of resource amount. So resource amount list, construct a brand new list. Let's initialize it with something. So let's initialize it with a new resource amount. And in this case, let's go resource type. Let's go, let's say gold. And then for the amount, let's say 12. Okay, that's it. So we stored this object inside of this list. And now we can go inside this list and call contains. And again, the contains function, that one is going to run that logic. So you can call contains and construct a brand new resource amount. So let's do another one that is exactly the same, meaning it has the exact same data, but we are constructing a brand new object. So this reference does not match whatever reference is stored in there, but since we override the IEquitable, it is actually going to contain and compare all the data inside of it. So if we do this, let's do a console.writeLine on this one and see. And if there it is, says true, so it does contain that amount, even though the object is completely different. All right, awesome. So here we learned how to implement custom override operators. We can define custom logic for how to do math operations or do equals on any of our custom types. So this helps make our custom types behave exactly as we want them to, and enables a more straightforward usage by using normal operators as opposed to having to call custom functions. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about LINQ. This is a way for you to do queries on your collections in C#, kind of like the same as you would do with some databases. So if you already know something like SQL queries, then this is actually going to look quite familiar. Okay, so here let's learn all about LINQ. If you work with databases or simply do lots of data queries, then this is going to be extremely useful. LINQ is really just a collection of functions that works with collections of data. Importantly is how that collection of data can be almost anything. It works on lists, it works on arrays, it can work on databases, XML documents, and a bunch more. It works on anything that implements IEnumerable or IQueryable. Since lists and arrays already implement those, let's use a nice list for testing. So here I've got a simple player class, just has a string for the name and a team. Then I've constructed a new list and constructed a bunch of players. They got different names and they're on different teams. So right here, this is our data. Now we want to do some kind of query on this data. For example, we want to grab just the players on the red team. Now, one way to do this is obviously by doing a simple for each, cycling through this list, then construct a brand new list, and inside the for each, check out inside the list which one has a team equals red, and if so, add them to the other list. So yep, that would work perfectly fine, but we can also do it somewhat more simply by using LINQ. First thing is we need to go up top, and we need to add the LINQ namespace. So using, and it's inside system, and system.LINQ. Yep, that's it. This is the namespace that has all of the LINQ functions. So now, for example, down here, if we grab the player list and just write a dot. So this right here is the normal list of functions. So this is the normal list functions. And then over here on the sides, these are the function extensions. Most of these are actually LINQ functions. This is how LINQ is super easy to use. It is all based on extensions upon other types. So if you have any kind of collection, you can always find a lot of these functions. Now in this case, we want to do the simplest thing possible. Really just query this data for one specific condition. We just want to grab the elements where the team is red. So over here, one of the things we can do is use a where clause. And this one is like the name implies. It's going to select some objects where this condition is true. This one takes in a predicate, which is really just a func, so just a delegate. It takes in a player object as an input and outputs a boolean. So basically, if this output's true, we are going to select this player, and if it's false, then we don't select it. Now in this case, we want a very simple delegate, so we can just use a very compact length of expression. We can define the player, then our little arrow, and then for the condition, in this case, we want just player where the team equals red. And if that's it, super simple, this is our delegate, so this is going to do our conditional logic. And now this function itself, this one is going to return an IEnumerable. So if we want, we can just do a for each directly on this. Or if we want a more, let's say, standard type, if so, we can call something like either toArray or toList. Like the implies that we'll convert it to either an array or a list. So let's put this inside a list. So let's define a list of player type, call it the red player list, just like this. And yep, so here we have a list of our red players. Let's actually verify it. So let's do a for each player in the red player list. Cycle through all of them and just do a console.writeLine, do a log on our player. Okay, let's test. And if there it is, it found CodeMonkey and Black Widow both on the red team. All right, awesome. So in this super simple example, you can already see how LINQ is quite useful. Instead of having to do a complex cycle, having to make a brand new list to store all of our selected elements, instead of all of that, we just have a single line of code. And in this, we automatically query for all of our elements based on our condition and make our final list. So LINQ really is quite easy to use. If you want to do tons of data queries, then this is going to be much easier as opposed to using tons of for each with tons of conditions. Now inside, we've got the where, but we have all kinds of things. So here we can inspect all the operations we can do. For example, all. This one returns a boolean and determines whether all the elements satisfy a certain condition. We can do any to check if it contains any elements. We can grab just the first element of a sequence. We can grab an intersection between two groups of data. We can join them, we can grab the last, and so on. So as you can see, tons and tons of functions to do tons and tons of operations. And LINQ also has one very interesting thing. So we can do this. We can just run the normal LINQ functions. This is the LINQ method syntax. But there's actually another way. There's the LINQ query syntax. Now, if you know SQL, then this is actually going to look quite familiar. The query syntax, that one returns an IEnumerable. So let's make an IEnumerable of type player. So red player IEnumerable, okay. And now after the equals, instead of writing normal code, so first grabbing the list, Instead of that, over here, let's write the from keyword, and then we give the individual element some name. So in this case, we're cycling through player, so let's call it player. So this is going to be our local variable that is basically going to cycle through everything. And then in, and then we select the collection of data where we want to work on. So in this case, that's going to be our player list. And then we can do all kinds of operations. So once again, we can do a group, we can do a join, we can order, select, switch, and so on. In this case, we want a simple condition. So let's go with where. Then in our condition, let's do the exact same thing. So where player.team equals red. If the player's on the red team, then we want to select it. So let's just select this player. And yep, that's it. So this code over here is basically going to do the exact same query that we did up here. The only thing missing is really just the tool list. But here we have the IEnumerable, and if we want, we can then convert this into a list. But in terms of the condition itself, yep, these are doing the exact same thing. So this one grabs the list as the input, then cycles through the list and grabs each element and calls each element player. Then for each one, it runs this condition, checks if it is true, and if so, then simply going to select that element. So if you're familiar with SQL, then you're basically familiar with this. Here what we have is essentially, let's say, a select everything from some kind of player list database where the team equals red. So this is some basic SQL, and right here we have pretty much the exact same thing, but written in the LINQ query syntax. Let's just verify it and make sure that it says the exact same thing. So let's cycle through this one. And if they're the same thing, it did find both of them. Okay, great. So yep, these are the two methods for working with LINQ. We can either use normal functions, or we can use the special query syntax. Now, one very important thing about LINQ, it's how up here when defining the query, this line of code, this one isn't actually doing anything. This one isn't actually creating any new list or any new elements. It isn't actually running any kind of conditional logic. This line over here, all it does is just define the query. That's it. This one does not execute the query. The query is only executed down here on the for each. When cycling through all the elements of this IEnumerable, that's where it runs the logic for checking the condition, selecting, and so on. Meaning that LINQ has deferred execution. Writing the query, this one just defines it. It does not execute it right away. Only later on, when actually cycling through the collection, only later on does it actually execute the query. Now, this can be quite important if you're limited in terms of performance. You can safely create the query pretty much whatever you want, and then you can wait until later in order to actually run the query. Or if you want, you can actually run it across multiple frames. So IEnumerable, you can manually get it whenever you want. It doesn't have to be inside of for each. So you could run this over multiple frames, which could be helpful if you're cycling through a massive database. Although also another quick note, which is up here when using this method. When using this one, same thing, it is not going to execute just to find the query. But when we call toList, naturally this is indeed going to run the entire query right away and put it inside a list. And like I said, LINQ works with just about any collection type. So here we're working with a list. This one would also work with some kind of array. It would also work with, for example, something like XML. So for example, if we have some kind of list of contacts, if so, then we can define a query going inside it, inside some kind of record node, then inside grab some kind of field, check if the field value does match something, and select that contact. And yep, this is perfectly valid code. All right, so that's LINQ. It's an interesting way to do queries on collections of data. In many cases, it can actually be simpler than doing normal cycles by normally going through a list and testing for some conditions. The only downside is it can sometimes be expensive in terms of memory and performance, but when not doing anything super performance critical, in many cases, LINQ is a great way to do quick queries on all your data. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about WinForms. This is how we can build visual applications in Windows. If you just want a quick and easy way to make something visual, then this is really great. You can just drag and drop all kinds of controls like buttons, scroll bars, labels, and so on, and everything is pretty easy to use. Then of course, all the C# code that we'll learn throughout this entire course, all of that works on any of these controls. Okay, so in this course, we've been mainly using console apps. They are great for focusing on the code itself, but sometimes you might want to build something a little bit more visual, something with a proper UI. And for that, for making visual applications, we have two main options. There's WinForms or Windows Forms and WPF or Windows Presentation Foundation. Those are the two main ones. And in order to be able to use them, we need to first install the modules. So open up the Visual Studio installer, and on your Visual Studio installation, let's go and modify it. Then over here under Desktop and Mobile, here we do see .NET Desktop Development. So you can see build WPF for Windows Forms and console applications using C# and so on. So yep, make sure you select this one and install it. In my case, I've already installed. And now if we open up Visual Studio and let's create a brand new project. And yep, right here we do see the things that we just added. So right away we have the two main ones that I mentioned. We've got WinForms or Windows Forms and WPF. Now for these two, WinForms, this one has been around for ages, pretty much for as long as .NET has been around. So it is very mature technology. Whereas WPF, this one is newer and has some more advanced graphics capabilities. They also have some very different architectures. WinForms, this one is very lightweight and very easy to use, while WPF is quite a bit more complex. Also, by the way, I should mention these are not the only two options. For example, one limitation of WinForms is by default, it only runs on Windows. So for cross-platform development, you have something called .NET MAUI. By the way, you might somewhere see the name Xamarin. That's what this used to be called, but Xamarin has since turned into .NET MAUI. This one is cross-platform, so you can write your code and then you can deploy it onto iOS, Android, macOS, or Windows. And also, just another quick mention. Remember how, even though Unity is a game engine, that does not mean that it can only build games. You absolutely can build normal applications in Unity. Unity is really just a rendering engine. For example, I've built a controller module to control my live stream overlay. This whole thing, this is really made with Unity, even though it's really just a menu with some buttons. I've also previously built a launcher to launch all my games. So just remember how you always have that option. If you're already familiar with Unity and you want to make some non-game app, then perhaps using Unity might be a good option. But over here, when it comes to WinForms versus WPF, WinForms is really great for its simplicity, and WPF is great for more serious visuals. But like I said, if I'm building something based on visuals, I'm just going to use Unity. So for making non-Unity apps, let's learn a little bit about WinForms. Now to create, we want to create the template. However, it is not this one. Remember the whole thing that we saw in the beginning of the course? This one is using .NET Framework. That is not what we want. So up here, let's search for Windows Forms. And if we see one without .NET Framework and one with it. So it's this one over here, the one without .NET Framework. This is going to be the latest .NET version. So let's go ahead, select this one. Now let's give it some kind of name. So WinForms C# core, something like this. And let's click on next. Then for the framework, yep, let's go with .NET 8. And yep, here it is. And right away, we actually do see a difference. So instead of the code that we saw right away on the console app, instead of that, now we see a visual window right away. And if we try running this, yep, there it is. Here we have a standard Windows window. All right, awesome. So on this, you can build whatever visual program you want. On the right side, we have over here the toolbox. If we go under all the controls, yep, here they are. You can see all the tons of elements that we can add. So for example, we can add buttons, we can add checkboxes, we can add a datetime picker, we can add some fonts, we can add a label for just some text, we can have a list view, just a panel, just a picture, and so on. So basically all the elements that you're used to in any kind of Windows program, you can all find them here. Let's do something very basic. Let's just take a button. So let's click and drag the button and drop it over here on our visual window. And yep, there's our button right here. Now here we've got the usual controls that you find on pretty much any visual program. So we can move it around, we can scale it, and so on. Then also on the right side, we do find over here the properties window. So this is kind of like the inspector inside of Unity. Here we can customize this object. We can modify pretty much anything. You can modify the font, the color, the text, and so on. So here, let's change the text right here. Instead of saying button 1, let's say click me. And then another very important one is to give it a proper name. So instead of button 1, let's name it the click me button. And yep, there it is. However, if we run this, there's our button, a normal Windows button. We can mouse over and change it and so on. And we can click, and it does work. We can click, but nothing happens. So let's give it some behavior. With the button selected, over here up top, we see these two little things. So this one over here is for the properties, and this one over here is for events. So here we can see all kinds of events. Now, WinForms, this is really all based on events. So you listen to a bunch of events like mouse click, and when that happens, then you can do some kind of logic. So you can hook onto any of these events. As you can see, there's tons of them. The simplest one is really just a click. So here you can write some kind of name for a click event function, or you can just double click for default. And if right away, it opens up a view with some code. So here we've got our event. So as you can see, standard event, so object and event arg. Here we have the event where we can write whatever we want. Now, just make sure you don't modify the code up here. This is the forms constructor. This is what actually runs and sets up the form with all the visuals. We can actually inspect over here the initialized component. So let's go to the definition to see. And up here is all the code for initializing and creating the form. You can see here we are constructing a brand new button. Then it is setting the button location, the name, size, and so on. And then down here, setting up the form itself, setting up the dimensions, the size, the name, text, and so on. So really what we are doing here in this visual interface, all of that is really being converted into code, which then actually creates our form. Okay, so here on the form1 code, when we click, let's just fire off a normal Windows message box. So for that, we go inside the message box class, and let's just call the show function and then show something. Okay, yep, just like this, super simple. This will show a message box with some text. So let's go ahead and run. And okay, here's our button, and I click. And if there you go, here's our nice message box. Okay, great. So this is really the basics of WinForms. You've got over here visual design. You've got your toolbox with a bunch of stuff. You really just drag controls and add whatever behavior you want on it. Now let's just see how to do some logic between events. So let's drag something else. Let's drag a label. So this is really just some text. So there you go, just a label. Then here on the label, again, the properties we can modify with all of this. For example, we can change the font. There you go, I just use a random font. We can modify the border style, we can modify the cursor. So let's make it with a nice hand cursor. For the border style, let's make it fixed 3D, just like that. For the padding over here, let's increase it by a bit. And that's it. As you can see, we can modify pretty much anything on our object. And up here, we also do see some events. So again, we can add anything that is going to happen whenever we interact with this label. For example, we can add some logic on click. That works perfectly fine. But now let's say we want to click our button, and on the button, change the text on our label. Now first, let's also just make sure that over here the name has a proper name. We're going to modify the text dynamically, but for the name, yep, here it is. Let's call it our text label. Okay. And now the way we access other objects is actually quite easy. We can look here on the code where we are initializing our form, and we can see, okay, we have the click me button, and over here we have the text label that we just created, and it has all the setup that we just made. And as you can see, this one is a text label, meaning it is just a simple field that is defined on this class. And this class, note how this one is a partial class, and the other one where we have our click code, this one is also a partial class. Both have the exact same name, meaning both are part of the exact same class. So to access other objects, we really just use the name, because again, this class shares the other class, which share the same field. So in this case, we named it our text label. So yep, here it is. There's our field, our text label. And then inside we can do whatever we want. So for example, let's change the back color. Let's call it color dot, let's say sandy brown. Then text label, let's change the for color. So this is the text color. Let's put it color.white. And then for the text label, let's modify the text itself and say, hello and welcome, I'm your code monkey. Okay, yep, that's it. Super simple. Let's test. And here we are, and there's our label. And by the way, as we mouse over, the cursor actually changes, so that's fun. Now we can click on click me, and there's the box, click on OK, and yep, there it is, there's our text. All right, awesome. So you can see on a mouse click, we easily changed a bunch of properties on a different object. Now also here we saw one interesting thing, which is over here, it's like this by default, and when we click on this, yep, there you go, look at this. It did not change the text right away. That is because this message box over here, this one is actually blocking the program execution. So the code over here basically stops when it gets to this line, and only continues executing the rest of it when we finally dismiss this window. Basically, this is now pausing the main UI thread, and when we click on OK, that one resumes, and yep, continues running the rest of the code. So this is where things like asynchronous programming become really important. It's so you can do all kinds of logic without blocking the main UI thread, which then is going to update the visual. Alright, so that's the basics of WinForms. This is how you can very easily and quickly build a visual window application. It has a very intuitive workflow by just dragging and dropping some controls. And of course, all the C# code that we learned in this course, all of that can be used with any of these visual elements. So if you want to make a quick, simple visual program, then WinForms can be a great option. But also remember how Unity doesn't have to just make games. So if you want to make non-game apps, if you want something visual, you can also just make a simple Unity window. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about DLLImport and the extern keyword. With this, we can interact with external libraries. So we're going to see an example of how to interact with the Windows API. Okay, so while building our program, sometimes we might want to interact with an external DLL library. In order to call that external code, it's actually quite simple. As an example, we're going to see how to interact with the Windows API. So first we need to know exactly what we're going to be working with, meaning that we need to know the exact function signature. So one excellent place to see all the functions inside the Windows API is this website, pinvoke.net. This is a great resource that shows all the libraries and all the functions. So over here on the left side, we can see all the various DLLs. For example, we're going to be working a lot with user32, or alternatively, you can also see all of that in the Microsoft documentation. So for a simple test, let's do a simple Windows beep. So for that, we have this function called message beep. This one exists inside the user32.dll library. And right away on this website, we can actually see the correct syntax. The function is going to return bool. It is called message beep and has a beep type, which is actually, we can see down here, it's a uint, as a uint named utype. So we just need to write exactly that. So over here in our code, let's do that. So make it public, make it static. We're going to return bool, and it's called exactly message beep, like this. And inside we have a uint for the utype. And yep, just like this, except of course, like this, we do see this error. It is telling us we must declare a body, but it also says here that we must declare a body because it is not marked as abstract, extern, or partial. And the way we're going to solve this is by using the extern keyword. So over here, just type in extern just like that. And yep, the error is gone. Basically, extern, this one says to the compiler that this function is external, meaning it is not defined anywhere in our program, but rather somewhere else. And now that it is marked as external, now we need to specify exactly where is it. So that's where up here we're going to use the DLLImport attribute. and this one exists inside of this namespace, system.runtime.interrupt services. So you use this one, and this one takes in a string for the DLL name. In this case, it's user32.dll. Yep, just like this. And yep, we have no more errors. So as you can see, it's quite simple to work with external libraries. The only important thing is really you just need to make sure to write the function signature exactly. So now for testing this, we really just call it like a normal function. So over here, let's just call message beep, and let's pass in the default one, so just 0. Okay, so let's run this and see. And yep, there's our beep, there's our sound. So we defined an external function and we called it. All right, awesome. So yep, here everything is working. And like I said, the function signature, this has to be absolutely exact. If we give it a different name, like just 1e, if we do this like this and call it, right now we see no errors. But if we try running this, yep, of course we have an error. It is saying entry point not found. Basically, did not find any entry point named exactly message beep. That is because the proper one has 2 e's. So again, you can refer to over here on pinvoke to see all of the various functions we can call. You can see the exact signature. So as another example, let's use the message box. So here we see the signature for this one. Or again, we can just look at the official documentation right here. We can see all the parameters, and over here on this documentation, we can also see all the various values. The only thing is over here on the official Microsoft, this one says our C++ code. Whereas over here in pinvoke, we see some proper C# code. So let's copy exactly this. So here we are, and let's paste it. So same thing. So we've got the DLLImport, and just has some extra parameters. Then this one is again, it's static, it is extern, it returns an int, it is named exactly message box, it has a pointer for the window, then it has a string for the text, another string for the caption, and a uint for the type. So yep, now let's just call this. So over here, instead of the beep, let's call our message box. For the window, let's leave it on 0. For text, let's say hello world. For the caption, let's say code monkey. And for the type, let's just go with 0. Okay, so let's try this. And if there it is, look at that. Here's our window, our title, our text, and our OK message. Okay, great. Now let's play with this a little bit more. Here on the Windows documentation, we can see the utype. This one is actually a very special thing. It says here this parameter can be a combination of flags from the following groups of flags, meaning this really Enum Flags or really just a bit mask. We already learned about those in the Bitwise Operators lecture. So here we can just select a bunch of these options. For example, we can have abort, retry, ignore. We can have those buttons, or cancel, try. We can have OK, OK, cancel, or yes, no. So for example, let's say we want yes, no. So here instead of 0, let's put yes, no, just like that. But this is a bit mask, so let's also use another one. So for example, over here we can see a bunch of icons. So let's go with this one, an icon with a question. And since this is a bit mask, let's make sure to use the or. Again, the bitwise or, just one pipe, just like this. Yep. So this should say the exact same message, but now it should have yes and no buttons, and it should have a nice question mark icon. So let's test. And if there it is, exactly like that, question mark, yes, no, absolutely perfect. All right, awesome. Now, if you want another example, you can watch my transparent Unity window tutorial. This is exactly what it sounds like. I made a Unity window with a transparent background. And the way that works is, again, by using some external function calls. So using that, I was able to make the background transparent. That's how I'm able to make this live stream overlay of the characters in chat walking around. This whole thing is a transparent Unity window. And another thing similar related to this one is called LIBraryImport. This one is also an attribute. This is actually the newer method for doing this. It has improved performance and compatibility. The only thing is it requires source generation in order to work, but nowadays most projects will probably support source generation. In order to use it, in terms of the code, it's actually mostly the same. So in here, instead of using DLLImport, we use LIBraryImport. And since this is based on source generation, instead of using extern, we use the keyword partial. And if we make this function partial, if so, then we need to make the entire class partial as well. And again, make sure we have the exact same signature. And this one is telling us that we need to use the marshal as attribute. Marshalling is basically the concept of interoperating data between managed and unmanaged data. So in this case, we just need to add the attribute to define the return type, marshal as unmanaged type.bool. That is this Boolean type, make sure that it works. And if that's really it, we have no errors. And if we call it, call message beep, and yep, we still have the beep and we still have our message box. So this is another alternate method for also calling external code. Alright, so that's DLLImport, extern, and how to work with the Windows API. With this, you can actually do some really interesting things. Like for example, you can show a message box or open a file dialog window. You just call those functions, you don't have to build those windows from scratch. Or you can build a transparent window like I did. The Windows API is really huge, so definitely feel free to browse it to see everything it can do. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to use asserts. This is a very interesting code validation tool. And then we're also going to talk about unit testing in general. Okay, so asserts. This is an interesting way to make your code much more robust and free from errors. It is really just a simple way to test for something. This way we can easily validate our code to make sure everything works exactly as expected. For example, here is a player class, and on the constructor we receive a string for the player name. Now let's say the name is never ever supposed to be null. Basically the rest of our code is making the assumption that player name is never null. So we want to make sure that rule is enforced. Basically if that happens, then it's an error in the code that should never happen. So we do want to know if it does happen. And one way to do that is with an assert. Now they exist inside the debug class. This one inside system.diagnostics. Inside we can call the assert function. And this one takes in a condition. We want to make sure this condition is true. So in this case, let's make sure the player name is not null. And yep, just like this, very simple. So now up here, if we construct a brand new player, if we do this and we pass in a valid name, so a proper name, if there it is works, nothing happens. Whereas if we pass in with null, if there it is, our code basically just stopped. Now importantly, this is not an actual error. The program did not crash, it is still running. Instead, it really just paused. So this assert really just acts like a breakpoint. That way we can use our debugger tools in order to figure out exactly what happened. And then if we want, we can click on continue to continue running the rest of the program. And if it continues, terminates, and so on. So basically asserts help you ensure that certain conditions are true. If it is not true, the program will pause. Now one extremely important thing is how asserts are meant for validating code only during development. This is not meant to be used during runtime. In fact, by default, this won't actually even run during the final build. It has to do with up here for the configuration manager for the various configurations. By default, this one, debug.assert, this will only run if you have the debug configuration selected. Now I talked about these configurations a little bit more in the lecture on preprocessor directives. So like this, if we select debug, the assert will run, but if we change this to release, this is what you would normally do when making the final build of your game. If so, then even if you pass in the wrong data, if you pass in null over here, nothing would actually happen. If you don't have the debug configuration selected, then it's as if this line of code does not exist at all. It is completely not included in the compilation. So keep that in mind. The goal with assert is to ensure your code is behaving exactly as it should be during development, and then after you verify that everything works, then you make a release build. If you do want to make some verification logic during runtime, for example in this case, let's say the player name was a user input instead of a hard-coded string by a programmer. If it was a user input, then you would not use this. If it was user input, you would make a simple if. So if player name equals null, then do something. So do remember that point. The goal with asserts is to validate your own code, and then you can use regular logic to validate runtime code. Now if you do want to do asserts in runtime, there's actually a way. So over here, debug.assert, like I said, this line will not be included in the compilation if up here we have release selected, but we can use trace.assert, and this one does pretty much the exact same thing, but this one is included in release mode. In general, that's really all asserts are. You just have a simple condition. You add these in various places in your code to make sure your conditions are always true, to make sure the code is running correctly. And if something goes wrong, then you simply know about it so you can fix it. Now, since asserts are all about testing your own code and making sure that it behaves as intended, let me just briefly talk about code testing, or specifically unit testing. This is a huge topic, so I'm just going to briefly mention a high-level overview. So when doing unit testing, that is when you write a bunch of tests to ensure your code behaves exactly as expected. So for example, over here for this player class, let's assume the player should never be null, but then let's also say this one doesn't make that assumption, it just stores the player name. And then let's have some kind of function, so get player name length, and this one just goes inside the player name and returns the length. Now naturally, if over here the player name is null, then this one is going to throw an exception. So if this was our player class and we want to test this, then basically just come up with a bunch of tests, a bunch of edge cases where your code could go wrong. Like for example, up here, define a player class, player, set it to null, and then call player.getPlayerName length. You would put this whole thing in some kind of try catch. And if it throws an exception, then simply we have the test failed. And if not, then test succeeded. So let's test. And yep, this one throws a null reference exception. And we can see indeed our test failed. So this is a basic example of a test. You set up everything to run the test, and then maybe it succeeds or maybe it fails. And if it fails, then you know you need to fix something. So you do that, you would fix that. Like for example, up here, you would add if this one equals null. If so, then set it to an empty string. And if now with that change, now the test does succeed. So this is really a very rough high-level overview of unit testing. You have a unit, meaning some piece of code. It can be an entire class or just a function. You have that, then you write some tests to test whatever you want. In this case, testing what happens if the player has a null name, and then we try getting the player name length. So you write all your tests, and then if all the tests pass, then the code is good, and if something fails, then basically you have some work to do. Then in order to write these tests, technically you could do it all like this, build it all from scratch, but there's a bunch of testing frameworks that can help simplify that process. The official one by Microsoft is called MS Test. There's a pretty simple guide here on how to start using it. So basically you have some kind of code that you want to test, then you create some kind of test project. You create the class that is going to test a bunch of things. For example, it tests over here that number 1 should not be prime, so it makes some assertions, does a bunch of things. And instead of having to write all that try-catch code that we just saw, it really just works based on adding a bunch of attributes. So using a testing framework like this can make it much easier to make some tests. Two other very popular testing frameworks for C# are, one of them is NUnit, and another one is called XUnit. So if you want to do unit testing, it is probably wise to use a proper testing framework. Alright, so that's Assert. It's a way to validate your own code and test your own logic during development. This way you make sure your code is running exactly as intended before making the final build. And here we also covered a high-level overview of unit testing, what it is, and the various frameworks you can use. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn how to write unsafe C# code. This lets us disable the safety features of C# so we can access raw memory and do anything we want with it. Okay, so let's see how to write unsafe code. Now this is a very advanced topic. When working with raw pointers, it is extremely easy to mess up. You can corrupt some memory and crash your program, or you can simply end up opening your program to all kinds of security vulnerabilities. So this lecture is very much just a quick introduction to the topic, just so you know that it exists. I myself am not an expert in unsafe code. I've never really used it myself in any serious project, I just know that it exists. In order to properly use unsafe code, you need to know exactly what you're doing. If you don't, you're going to cause a lot of trouble, so always keep that in mind. Now, before we cover unsafe, how exactly is C# safe? Well, C# actually has a ton of safety features, mainly to do with memory. For example, when working with a language like C, when you want to create a brand new variable, you need to manually allocate some memory for that variable. Whereas in C#, that is all handled automatically. So if you define an int I equals something, this automatically defines the memory for this integer and automatically assigns the value. Then when reading some memory, like for example a string of text, you need to know how far along to read. You need to read it character by character. Whereas again, in C#, you just got a string with something, and then you can easily read it and say something to it. When working with pointers, you can have pointers to invalid locations in memory, whereas in C# you simply have null. So that and tons more things. Basically, C# tries to protect you as much as possible. And of course, the downside of all of these safety features is naturally it makes the code a little bit slower to do all of these safety checks. That is why, in super performance-intensive applications, usually you write it with C or C++. For example, while you write game code in Unity and C#, while you do that, the engine itself, that one is mostly written in C++. The entire engine has an entire pipeline to basically have your C# code communicate with the backend C++. And the reason why it's in C++ is exactly to have access to all that raw power without that safety overhead. But again, the engineers that work on the Unity backend, they are experts, which is why they can work with pointers without causing all kinds of issues. Now, in C#, in order to write some unsafe code, it's actually pretty simple. You just use the unsafe keyword. Now you can mark an entire class as being unsafe, you can mark an entire function as unsafe, or you can simply define a code block, and just this code block is marked as unsafe. Now inside of this we can write any unsafe code, like accessing pointers and allocating some memory. Although right away you can actually see an error. It is saying unsafe code may only appear if compiling with the unsafe. So we need to first set up the project to actually support writing unsafe code. By default it does not support it. So for that, let's go onto the Solution Explorer, let's right click on the project itself, go into Properties, and over here let's scroll down, and over here under Build, we can see, yep, here's a checkbox to allow code that uses the unsafe keyword to compile. So yep, let's enable this, and yep, the error is gone. Okay, great. So now in here we can use pointers. For example, we can define an int pointer. And the way we define a pointer is first to type int, and then a little asterisk. So this is an int pointer. Let's call it like int array pointer. And in order to allocate some memory, we can use stack alloc. Then let's allocate memory for an int array with, let's say, 10 elements. And if this is going to manually allocate some memory for an int array, then for example, if we want to read the memory location for this, we can grab the int array pointer, we can cast it down to this type, the int pointer, and let's just print this to see what this says. So let's do a console.writeLine. Let's print out this. Let's just do a toString to convert this into hexadecimal. So toString with format of X. Okay, let's see. And if there it is, we allocated our pointer, our int array, and it ended up being allocated on this exact memory address. Now let's read the entire memory address location. So let's do a simple for int I equals 0, I less than 10, I plus plus, And for this int array pointer, we can access this as if it was a normal array. So just access that one. Let's do a console.writeLine on this one. Okay, let's see. And yep, it's all in zeros. Makes sense. But now let's see another thing. So we are allocating with 10, and over here, let's actually read 20 positions. And if you look at that, this did work. Usually, if you try doing this in non-unsafe code, in normal code, if you try to access this array on something bigger than the index, if so, then basically normal C# code would have a bunch of safety, and that safety would stop us from looking beyond the index bounds. If we tried, we would get an index out of range exception. But over here, when working with unsafe code, we don't get that. We can read the memory beyond the array, and doing so, we're basically going to get gibberish. So the first 10 positions, those have been initialized as new int array, so those are guaranteed to be initialized to 0. But these other ones can have really any memory. This memory does not belong to the int array, it belongs to something else. But as you can see over here, the unsafe code does not stop us from accessing it. So even though the int array only has a size of 10, we can go all the way up to 20 and even more. By the way, this is actually the basics for how hacking programs work, things like aimbots and wall hacks. Usually they read memory they're not supposed to, and then interpret it in some way, like for example display an enemy behind the wall. And the pointer itself, this one is also, like we saw here, it's just a position in memory. So we can take this one and, for example, let's increase it. Let's increase by some amount. This basically means we're going to look at a memory location for it, which again is going to let us read a bunch of garbage. So up here, let's read just 10 elements, which without adding this one, we would see everything with zeros. But now, yep, we see a bunch of garbage values. So pointers are really just numbers to a location in memory, and you can increase that number. You can do whatever you want to read a different location in memory. Now the asterisk over here, this one defines a pointer, and then another symbol, the ampersand, that one defines the memory address. So for example, let's make over here a simple struct. Importantly is that pointers need to work with unmanaged memory. Again, the entire concept of managed memory, that's a C# thing. C# automatically manages memory for you. But when working with pointers, when working with unsafe code, we are intentionally not using any of that. So when working with unsafe code, we're pretty much limited to just using unmanaged data. So that is why over here, let's find a struct for some kind of game data. Then inside, let's define some kind of value for some coins, and then maybe a bull is game over, something like this. So now up here, let's say we construct a brand new one, game data equals just a new game data. And now let's define a game data pointer. So this is not of type game data, it's a game data pointer, so game data pointer. And for this one, let's make this pointer point to this structure right here. So for that, we use the ampersand in order to get the actual address in memory of this game data. And yep, so now we have this pointer, and this pointer is going to point to this data. And now, for example, for accessing data inside a struct, for that, we access our pointer. And now, normally, when working with C#, you would do .coins, something like this. But over here, we are working with pointers. And when working with pointers, or when writing some C code, to access a sub-element of this object, for that, we do a little arrow. And then we access, for example, the coins, and we can set it to something. And then same thing for the other one is game over, we can set it to something. So yep, this is how we can access some members of some data, some type. We grab the pointer using the location memory, and then access those members and do whatever we want to. Then you can also declare pointers as function arguments. So for example, let's make here a function to raise something to the power of 2. So let's make a static function, just because over here we're in the static thing. Let's make it void and call it power 2. And over here, let's receive a pointer as a function argument. So instead of an int, let's receive an int pointer. Yep, just like this. Except, of course, we see an error. We can't use pointers. We can only use them in unsafe contexts. So let's mark this entire function as unsafe. And yep, that does work. And now we want to modify this value. So to modify the value, we access the pointer itself. And then we're going to set it to something. So in this case, power of 2, we want to basically put this value to the power of value. So let's do times equals, just to do the multiplication. And then times equals, again, the value stored inside a value. So not value like this. This is an error. We don't want to get just the pointer itself. Instead, we want to get the data where that pointer points to. So let's put a little asterisk to get that one, just like that. So that inside of here is going to multiply itself by that one, and that will basically do a power of 2. So then up here, let's use it. Let's find some kind of value. So int a equals 5, so just a simple integer. Now call the function, so power 2. But now we need to pass in a pointer, not that itself. If over here we use just a, yep, we have an error. It's telling us cannot convert an int, meaning just a simple integer, just simple value, to int star, meaning an int pointer. So we need to pass in the pointer, which means we need to pass in the memory location, just like this. And if that's it, that works. Now, one interesting thing, since we are working with pointers, meaning that this is going to point to the original position in memory, even though over here we are working with an int, which is a value type, And normally, if we made this kind of function and over here we receive just a normal int, with that, if we then multiplied it, we would only be modifying the copy itself and not the original data. But since over here we are passing the pointer itself, if we do a console.writeLine on this one, on A, if there it is, it says 25, so 5 to the power 5. So the function, this one modified the data on the variable itself, even though it's an int, and the reason is because we're dealing directly with pointers. Then some objects might move around in memory. If you have some kind of managed data, like for example, just a simple managed array, if you have something like this object might go into different positions in memory. So if you want to do something, you can use the fixed keyword, and this one is basically going to generate a pointer. So a byte pointer equals our bytes. And yep, basically this one over here, the fixed, this one is going to generate a fixed pointer to this object. So whilst inside of this fixed code block, we can make sure this byte pointer is valid, but when outside of it, this object might move to a different position in memory. Okay, so that's how you write unsafe code and deal with pointers. Like I said, this is a very, very advanced topic. It is very error prone, so definitely make sure you know what you're doing. Unless you're writing some code in some embedded systems or something super hardcore like that, chances are you really don't need this. C# has a ton of really awesome safety features that are meant to protect yourself. Those are really good, they help you write much more error-free code much more easily. So only disable those when absolutely necessary. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about asynchronous programming. Specifically, we're going to learn how to use the async and await keywords in C#, as well as how to use the task type. Okay, so first of all, what exactly is asynchronous programming? This is how we can have code that executes in a non-linear sequence. Basically, it's how we can have some code pending for execution while some other code is executing. One great example is simply to think about cooking. For example, let's say we want to cook some breakfast. We want some coffee, eggs, bacon, toast, and so on. Now, if we do it in a non-asynchronous manner, meaning if we do it all sequentially, one task after another, then first we pour some coffee, after that's done, we heat the pan, after that's done, we fry some eggs, then afterwards do this, and so on. So basically we do each task to completion one by one until the end. So in total with this, we would spend maybe 30 minutes. But obviously, looking at this example, you can probably see that this doesn't really make much sense. You wouldn't really make your breakfast this way. There's no point in standing around doing nothing while the pan is being heated. You can start some of these tasks at the same time. So the asynchronous method of doing a breakfast is like this. So we pour some coffee, and then we start frying the eggs, start frying the bacon, and start toasting some bread. We start these three tasks at the exact same time. Then while those tasks are making some kind of progress, we continue doing anything else. As soon as the tasks complete, we get notified and we can do more things. So for example, the eggs get done while the bacon is still cooking. Then the bacon is done while the toast is ready, so we start putting some jam and so on. So basically we start a bunch of tasks, and then in the background we wait for them to complete, and while we're waiting we can do other tasks. So in total, by using this method, naturally we would make it quite a bit faster. Although here, let me point out one extremely important detail. Asynchronous does not mean multithread. Meaning everything, all of it, still runs just on one thread. Making something asynchronous just means there's really a pending task and we're waiting for it to complete. So the common example in actual code is doing something like contacting a web server. We make the request, and then we just sit around and wait for that request to return, for the server to actually send a response. Meaning our CPU is not actually doing any extra work on that task. It sends out the request and just waits for it to complete. So always keep that in mind. Making our programs asynchronous helps us keep the program nice and smooth without freezing, but it does not make it multithread. Okay, so now that we've seen the theory behind async programming, let's learn the syntax in C#. So for example, let's say we have a function to contact a web server. So here, let's make a void contact web server. And now here we do something that takes some time. So we would make some kind of HTTP request. In order to simulate this, let's use the task.delay. This function basically waits a bunch of time. It's simply going to delay execution. It's not actually going to do any work. It just waits. This one takes some milliseconds, so let's wait for 3 seconds. Okay, so here we're pretending to contact the web server and wait for a response. Let's just do a log here. So console, let's do a write line, and let's print out contacting server. So we're contacting, and then we contact. Then let's say by this, the server has finished getting a response. So let's say got a response. Okay, just like this. And for testing, let's run this. Although this one actually quite worked, but let's test. And if that's it, just basically ran both of them at the exact same time. So it didn't actually wait any time. That's because over here, task.delay, note how this one says awaitable and returns a task. So this is an asynchronous function. This task object itself, this is what contains the data for the pending action. If we want to wait until this action completes, then we need to await it. So right before it, we write the keyword await. If just like this, this will basically pause the execution right here on this line until this task ends. And when the task ends, then it continues going on to the next line. Again, remember, this does not make it multithread. When we use await, this logic for the task.delay, that one is still going to run on the main thread. It is simply just going to wait until it is completed before continuing. And also here we do see an error. It is telling us the await operator can only be used within an async method. So in order to make this work, we need to mark this function as async. Yep, just like this. So now let's test like this, except it also didn't quite work. We can see it did start contacting the server, but the program just ended before we got a response. So let's make sure we keep our program alive, we keep it running while we wait. So for that, we can just do a while true, just an infinite loop, just so it keeps running forever. Then we can forcefully close it. So like this if we test. Okay, there it is, and contacted the server right away. And now after 3 seconds, yep, there you go, we've got our response. Alright, awesome, so this worked. Here we have the main asynchronous syntax. We mark our function as async, and then inside it, when doing some kind of asynchronous work, whenever we want to wait for something to complete, we use the keyword await, and doing so basically it will pause the execution of this function right here, and will only continue after this task completes. However, very importantly, note how up here it did not pause. So down here on this function, when we got to this, it paused and waited for 3 seconds before it ran this line, but up here, we ran this line of code right away, and we went inside the while true immediately. We can actually put a console.log over here just to see exactly, and let's see. And if there it is, it's constantly printing out dashes, so that code is running. This is very important. So we ran this line of code, which in turn started this action and then waited for it to complete. But whilst waiting for this one, the code over here on the main function, that one continued executing. So it did not stop on this function, it continued going on to this one and continued going on forever. So with that, we had 2 branches of code running at the same time, except they were not really running at the same time. Again, this is not multi-threaded, we have just a single thread. What we had was essentially 2 pending tasks. So whilst working on the main thread, our code was constantly testing, is this task done? Just doing a quick check, and if not, then just continue running the same code as normal. And then when this task completed, then continue going on to this, it finished this function execution, and everything else ran the same. However, also one very important thing, which is how up here, like we saw, the code does not stop. So we start contacting the web server, and then we continue running some logic. So if we do this, if over here our code does not stop, how exactly can we know when our task has been completed? So in this example, how exactly do we know in here when have we finished contacting the server? When can we actually get some data back? So let's say we get some data, so let's just define a string for the server return data. So you have this, and over here after we contact the server, let's get some data back, okay? So now the question is, how do we know over here in this code, well, inside of this while, how do we know that this data has been returned? If we just try reading it right away, so let's get some in for some kind of data length. Let's just access the server return data and get the length, just trying to access that object. If we do this, naturally it won't work since the data will not be set right away. It has to actually wait for the server. So if we test this, yep, obviously we get a null reference exception. The data has not yet been returned, so this one is still just defaulting to null. So essentially we need to know when is this task done executing. And for that, we can use the same task type ourselves. So over here on this function, instead of returning void, let's make it return a task. And up here when calling it, let's grab our task. And then inside of this one, we can access all kinds of things. So here we can get a bunch of stuff. And the main one is really over here, these properties, so like is completed. This one is going to be true when the task actually completes. So let's just check for this one. So if the task is completed, if so, then let's get the data length. Let's just do a print on that. Yep, so now while the task has not been completed, this code is not going to run. And when it does complete, then we have our server return data, and now we can run this logic. Also, by the way, alternatively, we could just call task.wait. This one would work, but this would block our main thread. So our code would not keep executing like this. It would stop right here until the task actually completes. Whereas like this while is going to constantly running over and over again until the task completes, and then it's finally going to run this logic. So let's test. And up here we are contacting server, and after a while we should be able to see, yep, there you go, we've got our length. Okay, great. So here we can see that our function waited until we were finally able to read some data. However, usually you actually don't want to use this method, the method of doing a while true and then waiting for the task completed. Usually the proper way is exactly like we did it down here with the task.delay, meaning we should use the await keyword. Like we saw here, that won't pause the execution of the rest of the function until it completes. So over here, instead of grabbing the task manually and then manually waiting for it to complete, instead of that, let's just await this function call, just like this. And then any code after here, we can assume this function has been finished, which in turn means we do have our return data. So we can get rid of these checks, we don't need them. Just like this, it won't work. So it starts counting the server and only continues running this code after the server has returned a response. However, again, when you use awake, we need to mark this as async, so we have to do it like this. But if we try this, if we try making main async, if there it is, we actually have an error. And the error is telling us program does not contain a static main method suitable for an entry point. So making this function signature async void main, this is not valid for a main function. However, we can definitely make main into async. We just need to make sure that for the type, instead of void, we return task. And yep, like this, it should work, so let's test. So here we are on the server, and we are indeed waiting. And after 3 seconds, yep, we get a response, we get the 4, and everything works perfect. So yep, just like this, it worked. We did not have any errors, because again, the program stayed on this line. It did not continue down until this function was completed. Then when this one is completed, then down here, we can make the assumption this has been set, because we do know this task has completed successfully. So now that we've seen this syntax, let's actually see that breakfast example. So for example, we have our functions to do all kinds of things. So let's do a static async, let's return task, say like cook eggs. And in here, let's do a console.writeLine in order to say that we are starting cooking our eggs. Then let's do the same thing. Let's pretend this is doing something. So let's use task.delay, just wait for a little bit. And let's say the eggs take 3 seconds. Then a console.writeLine saying that our eggs are done. Okay, great, like this. Let's make 2 more. So let's make one for cooking bacon. And for bacon, let's say it takes a bit longer, so it takes 4 seconds. And then finally, let's make toast. And this one is quite a bit faster, let's say 1. Okay, great, just like this. So we have our breakfast functions. And now up here on our main, in order to start running those functions, let's first actually see the sequential non-asynchronous method. So let's first cook our eggs, but let's await it in order to make sure the eggs fully finish cooking. Then let's do the same thing, cook our bacon, and let's also await for it to finish. And same thing for make toast, let's also await for it to finish. So this is essentially going to be our synchronous method, meaning we're going to fully cook the eggs, then fully cook the bacon, and then fully make the toast. So let's see this. And okay, there it is. Eggs are starting to cook. And after a while, eggs are done. Now starting to cook some bacon. And after a while, bacon is done, starting to make toast, and toast is done. So yep, with this, we met our breakfast, but we also wasted a ton of time. We can essentially do all 3 of these tasks at once, assuming we have 2 pans. There's really no need to wait for the eggs to finish cooking before we start cooking bacon or before we start making toast. So instead of this synchronous code where we fully finish one task before starting another one, instead we can start them all at once, meaning they all start cooking right away, and then we just need to wait for all of them to be completed. So instead of waiting it, let's grab the task from that, so the eggs task, and over here task for the bacon task, and finally a task for the toast task. So we have all 3 of our tasks, and again this code is going to run sequentially right away. So we're going to immediately start cooking eggs, immediately cook bacon, immediately make toast. And then after starting all of these tasks, now we do want to wait for all of them to finish. So in order to basically await multiple tasks, we can use inside the task class, there's a whenAll function. This one takes an array of tasks. So let's wait for the eggs task, the bacon tasks, and the toast tasks. And yep, this one is going to be an awaitable call. So let's await on this, which means the code is going to pause execution on this line until all 3 of these tasks are done. And then down here, we have our breakfast done. So console, let's write line, our breakfast is done. Okay, so yep, just like this, let's test and see. And if right away we can see cooking eggs, bacon, and toast, all of that starts and toast ends right away, eggs done, and finally bacon done, and we have the full breakfast done. All right, awesome. So we got our breakfast done, and we made it much faster because we started all our tasks right away, and we just had to wait for them to complete. So instead of cooking each task individually, instead of that, we started them all, and then they all finished. So this is really how async works. You start doing some work, and then while waiting, you can go do other work. Now with all of this, there's really only one thing missing, which is how do we return data from one of these functions? Right now, this is just returning a task, meaning it's actually not returning anything, but we can indeed return some data. So on the test type, we have a generic version for exactly that purpose. Then over here, we use whatever type we want. So for the contacting web server, let's say we want to get a string back, just like this. So instead of setting some kind of field, let's just return our data. And yeah, just like this. So now here, the way that we call this is we call the function, but we want to wait for it to complete. So let's await it. And in order to get results, we really just put it over here. So server return data, just set it equals to that one. And now we can do a console.writeLine on this one. And since we awaited, it's going to pause in this one before going into this one. So this one should have the correct data received from the web server. So let's see. And okay, it's calling the server. It's waiting for a little bit. And after a while, yep, got a response, and response was indeed data. Okay, great. So this is how asynchronous programming works in C#. We have tasks. We can start those tasks right away. And then we can wait for all of them, which will essentially pause the code execution until those finish completing. And then it continues running the rest of the code. Then if we use await on some kind of function, we also need to mark it as async. And when using async, we can either return void, which usually doesn't make much sense. Usually you want to return whatever task you are awaiting. So you usually want to return either task or the generic in order to return some more data. Now, like I said many times, and let me repeat once more, just because it's something a lot of people get confused about, asynchronous programming is not multi-threaded. All of this code right here, all of it is still running just on a single main thread. We're actually going to learn all about multi-threading in the next lecture. Alright, so that's asynchronous programming using async, await, and task in C#. It's how you can keep your program running and not freeze while waiting for some kind of external result to arrive. This is extremely important in order to make sure your applications stay nice and responsive. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about multithreading in C#. This is how we can create separate worker threads to do all kinds of work on multiple threads at the same time. When done correctly, we can improve the performance of our program by a massive amount by utilizing all the cores to their max. Okay, so multithreading. Right away, let me say this is a huge topic with many potential pitfalls. This is very much a definition of an advanced topic. Writing properly multi-threaded code is actually quite difficult. It is very easy to make mistakes. So here we're going to learn just the basics, but then do make sure you dive deeper into this topic before you start using it in production code. So let's start with the absolute basics. First, what exactly is a thread? Now, a thread is really just a unit of execution within a process. It does not automatically match up to a core in your CPU. We can technically create as many threads as we want, but usually you want to create as many threads as the processor has cores, and then you want to try to split the workload evenly in order to achieve 100% CPU core usage. That way, all the cores will be busy doing something instead of doing everything just on a single main thread, which is actually how a lot of code runs. And also, I should point out what exactly happens if you create too many threads, or if you have multiple programs, all of them running multi-threaded code. If you do that, then the answer is actually quite simple. The CPU will schedule the threads to run on different cores if possible, and if not possible, then it will simply queue up the threads. So if you have 10 cores and you make 20 threads, 10 of those will be queued waiting for a core to be available to do some work. It won't magically create 20 cores if you make 20 threads. It will use all the cores as much as possible, but naturally it can't use things that don't exist. That as well, like I said, usually first you check how many cores your CPU has, and then you define the number of threads to create based on that. Now here in C#, in order to create a thread to do some work, it's actually quite simple. Now first we define the function where we want to do some work. For example, one very common use case in game dev is doing some kind of pathfinding. You want the main game logic and all the UI and all of that to be running on the main thread. You want that to be super smooth and not freeze while waiting for pathfinding. And then you want to take advantage of all the cores of the CPU to make the pathfinding super fast running at the same time. So for that, let's start by making a simple function. So let's make a static void, call it calculate pathfinding. And now here, let's just start calculating pathfinding. And to simulate that, let's use thread.sleep. And thread, like it says here, exists inside of this namespace, system.threading. So thread.sleep. This function simply keeps the CPU busy for a certain amount of time, let's say for 3 seconds. So basically this is going to be simulating as if the CPU is doing some complex pathfinding algorithm. Let's just do some logs just to see. So console.writeLine, over here calculating pathfinding, and then over here, let's say pathfinding done. Okay, so this is our function. This is the work that we want to do on a separate thread. Basically we want to be running this logic while the main thread is doing something else. So here, instead of manually calling the function, this would just run it on the main thread. So instead of this, let's create a brand new thread. So we do new thread, and now inside we pass in the function we want to call, or alternatively, we can be more explicit. We can construct a new thread start, and inside use our calculate pathfinding. Now this function here takes in a delegate. It has to return void and have no parameters. So yep, exactly the same signature we defined here. Now this is going to construct our thread. So let's define this as our worker thread. So we have this, but just like this, it won't actually run just yet. All we're doing here is just creating and setting up the thread. In order to run the logic, we need to go inside of this one and call start. And yep, now this will start executing this function on that second worker thread. And then after here, we can run some code that is going to run on the main thread. So here, console.writeLine, doing some main thread work. And then afterwards, when we want to do something that depends on whatever result we have in this thread, after that, we can once again use the thread and call the function join. And this will basically block the calling thread, meaning the main thread. It will block it until this thread that is doing some work, until this one terminates. So we call join, and now down here we can run some code on the main thread, whilst assuming that the second thread has completed. So for example, if we were calculating some pathfinding, then over here we could assume the pathfinding has been calculated correctly, and we could use it to move some unit or something like that. So yep, over here let's just do something like this, just print another log, and let's test. And okay, there it is. Main thread is doing some work, recalculating pathfinding. After a while, pathfinding done and main thread done. All right, awesome. So everything does seem to be working. However, right now, you might also be thinking this looks a lot like what we covered in the previous lecture on async programming. If we replace what you used with the await and async, then this would actually look quite similar. However, like I mentioned in that lecture, async programming is not multi-threaded. In async programming, we were waiting for an external service to do some kind of work, like contacting a web server. All we were doing is really just waiting to get a response back. Whereas here, we are actually doing some work on both threads at once. We can verify that by actually printing some more messages. So over here on the pathfinding, let's do a for to print a bunch of messages. So let's do a thread.sleep and let's do a write line. Okay, so like this. And then on the main thread, let's do pretty much the exact same thing. So over here, we're going to be doing some kind of main thread work. And let's make this one a little bit faster. Okay, so let's do like this. And if there it is, calculating pathfinding, and we can see both the main thread and the pathfinding thread, both of those are working at the exact same time. Again, this is the really big difference. In async programming that we saw in the last lecture, there is really just one main thread. We simply have some tasks that are waiting to be completed, but we don't actually have two threads doing work at the exact same time, whereas over here we do. We can see the main thread is doing work and the pathfinding is also doing work at the exact same time. Whereas if we were just using the main thread without any extra threads, then we would basically be doing this. So this is fully main thread work with no extra threads. And if you look at that, it's first doing the main thread work, doing all of that, and only then starts doing the pathfinding work. So right away you can see the massive speed up difference. We can get literally double the performance by using multiple cores at once. So this here is really the basics of multithreading. It sounds pretty simple. You create a brand new thread to do some work, then you set it to do a bunch of work, and then it can do some other work on the main thread. So it looks quite simple, but beyond this super basic example, it actually becomes quite complex. One very common problem is what is known as a race condition. That is when two threads are trying to do work on the same data at the same time. So let's actually intentionally create a race condition just to see. So up here, let's define a static int for some kind of resource amount. And then let's make a function that is just going to add a ton of resources. So add resources, and over here, let's just do a giant for, let's say by 10,000, something like that, something super huge. Then let's first grab our resource amount, then we increase it by 1, and then we update the resource amount to this temp resource amount. Okay, yep, so we're really just going to be increasing the resource amount by 10,000. And now up here, let's just create a whole bunch of threads. So let's create a thread array for some kind of thread array. New thread array of, let's say, 10 threads. Then let's go, let's cycle through that array, and let's construct a brand new thread. So just do a new thread and pass in the add resources function. So yep, here we are going to create all of our threads. Then let's simply start executing all of them, and then let's call join on all of them to make sure they all finish. And after this, let's print out the resource amount. So console.writeLine on our resource amount, and just print the resource amount. Okay, so yep, just like this, super simple. We construct 10 threads, all of them running the same function. And on this function, we're going to increase the resource amount by 10,000. So 10 threads increasing by 10,000 means that the final number that we see printed here, that final number should be 100,000. So let's see if that's the case. Let's test. And nope, right away, we don't see that. We see 72,000. Let's try again. And nope, now we see 80,000. And now we see 83,000. And now 87,000 and so on. So nope, we do not get 100,000. And every time we run, we actually get a different number. So what we have here is what is known as a race condition. Basically, all of these 10 threads, all of them are running this function at the same time. They're all doing work at the same time on multiple cores. And they're all working on the same shared variable. So what happens is, for example, thread A starts running this line of code. So thread A reads, let's say, 15 resources and stores them in here. But then let's say thread B already ran that line of code. So thread B already read 15. Then thread B incremented it to 16. And then thread B updated the variable to 16. But then thread A, which again has already read the value 15, then thread A is going to increase to 16 and save it again. So because of that, we essentially lost one resource. And it's all because of a race condition. It is because we had one thread just reading some data while another thread was already doing some operations on it. Because they're both trying to execute code at slightly different times, we end up with different read and write values. So that is why the result is always less than 100,000. It is because some resources are going to be lost to race conditions. Now, you can imagine this would be very annoying to the player of the game, losing resources for no fault of their own, just because the threads all ran logic at the same time. That's pretty annoying. So this is really one of the big problems of multi-threaded code. It is very easy to end up with race conditions and mess up all your data. Now, to solve this problem, we have a very useful tool. It's called a lock. And to use it, we write the unlock keyword, and then within parentheses, we put some kind of object that we want to work as our unlock. Now, importantly, this one has to be a reference type, so if we use the resource amount, we can see an error. Int is not a reference type. So the unlock over here has to be a reference type. So usually we just create a basic object. So let's go up here, make a private static, make it of type object, and just call the resource lock. And let's construct it just to a brand new object. Okay, yep, we have this lock. Now, importantly is this lock should be shared, meaning we should not have one lock per thread. That would kind of defeat the purpose. We want the lock to be shared between all threads. So we define the lock, we construct it, and down here we use that lock, and afterwards we just open and close our code block. And yep, that's it. And just like this, let's test. And there you go, the resource amount, the total is indeed correct, 100,000. Try again. And there it is, 100,000. Once more, and yep, 100,000. So it always works perfectly. Basically over here, this lock, what this is doing is, like the name implies, it is locking this part of the code to a specific thread. So for example, thread A goes through this line of code, and when doing so, it essentially registers this object as being locked. It is being locked as being actively used by thread A, and then thread A starts running all of this code. And now here's the really important part. If thread A is in the middle of executing these lines of code, if then thread B comes along and tries to grab the lock as well, if so, then thread B cannot get it. The lock is already in use. So thread B has to wait for the lock to become available. It cannot run any of this code until that lock is available. So basically thread A, which has the lock, that one does its thing, reads, updates the value, and so on. Then when thread A exits, then it releases the lock, and then thread B sees that the lock has been released. So thread B registers the lock and starts running the logic on that thread. And same thing again, any other thread cannot go inside this code block until the lock is released. So by using the lock, we are making sure that only one thread can be running this code at once. Now, naturally, this does mean that you'll lose the benefits of multithreading. All threads are waiting for this lock to become available, and only one of them is actually going to do some work. So this is yet another reason that makes multithreading so difficult. Technically, you can avoid all race conditions by just putting everything inside of lock, but then of course you also have no benefit. So you have to be very clever as to how you use your locks. Use them as little as possible in order to make your code as parallelized as possible. You don't want to overuse them, but you definitely want to use them to avoid race conditions. Basically, knowing what parts of your code need to be unlocked versus unlocked, that is definitely a skill you need to learn in order to write proper multi-threaded code. Now, another potential issue is something called deadlocks. So this is where two locks are each waiting for the other one to be unlocked. So here's an example of that. We've got two locks, then we define two threads. So this thread opens up lock 1, and then inside it tries to open up lock 2, and then this thread opens up lock 2 and then tries to open up lock 1. Then we start the threads and then we join them. So if we call this, let's see what happens. Let's see if our program ever exits or not. Let's just return. Okay, let's see. And if there it is, then our program is basically stuck. The issue that is happening is over here, thread 1, this one immediately grabs lock 1, and then thread 2 immediately grabs lock 2, but then they are both waiting for the other lock. And that is never going to happen because thread 2 is stuck waiting for lock 1, and thread 1 is stuck waiting for lock 2. Both are waiting for the other one to do something, so nothing really happens. So when working with multiple locks, you also need to take care of this. Make sure you don't have interlocking locks. That in turn means that your program ends up frozen. Then another potential issue of multithreading is simply how it makes your debugging much more difficult. Usually if you have some kind of bug in your code, like for example pathfinding is calculating some wrong path, usually you can just follow the stack trace to figure out exactly what went wrong. You can see exactly what called this function, where the data came from, and so on. But when using multiple threads, those will not run in a deterministic fashion. They will run at different times depending on whatever else your CPU is doing. So you can have bugs that appear randomly every once in a while because the threads ran in one specific order. Because of that, it is really difficult to replicate the bug, which in turn makes it really difficult to debug. Yet another potential issue is simply the cost for overhead. So making threads, this is not free. Creating a thread has some sort of overhead cost, both in creating it and in the CPU managing all the active threads. So in some cases, multithreading can actually end up making your code slower. The CPU might be so busy trying to keep track of all the threads that it actually loses more time than doing some actual work. Like I mentioned, there's no limit. You can create 1,000 threads on a 10-core CPU, but then they're going to run worse than if you just use a main thread because of all the context switching involved. Now, if you want to just do some simple work without the overhead of creating an entire thread, for that, C# has something called a thread pool. Basically, it has a pool of threads that is automatically maintained by the .NET runtime. It efficiently manages all the threads, allowing you to easily reuse them. So you can queue up a bunch of work, and then thread pool also automatically scales up or down depending on demand. Now to use it is quite simple. So instead of creating a brand new thread, instead of that, we just use thread pool, and then we just call queue a user work item, and then we just queue something. This one takes in a wait callback. This one is essentially a delegate that returns void but has an object. So over here, let's make some kind of function for that. Let's call it just do work. This one takes an object. And over here, let's print the thread ID. So let's do a right line, go inside the thread, grab the current thread, and grab the managed thread ID. And let's say this one's starting, then do some work and then finished. So thread.sleep for something. Okay, yep. So we're going to do this work on this thread. And out here, we can essentially just queue up multiple of these. So let's just go for int I. Let's just queue up 10 of these to do this kind of work. Again, we are not creating threads. We are just queuing up some work to work on the thread pool. And then since we don't have a reference to some kind of thread that we can do on join, let's just do a while true just to stop our program so we can read our code. Okay, let's see like this. And if there it is, we can see a bunch of threads start and a bunch of threads finished. So we can see we did a bunch of work on multiple threads at the same time. And it's doing all of this without us having to manually create and start some threads. So thread pool is really great, but it is really meant for small use cases only. If you want to do some complex work on a worker thread, meaning something that does work in parallel for a long time, for that you should probably use a normal thread and manage it yourself. But for small things, thread pool is super easy to use. Now here we've been talking about C# multithreading, how you can create your own threads to do any kind of work. But if you want to properly use it, you need to make some sort of thread scheduler. So something that keeps track of a queue of work to do, and then each thread pulls something from that queue when idle. But if you're working inside of Unity, you don't actually have to build something like that from scratch. In Unity, you can just use the Unity job system. This one is really easy to use, and Unity handles all that complexity for you. It automatically creates a bunch of worker threads and then manages them. It manages those threads alongside a pool of jobs. So then you just create some jobs and add them to the queue, and the job system will pull some jobs and do some work. This one has a bunch of features. It has tons of safety in order to make sure you don't mess up yourself. So when working with Unity, definitely go ahead and use the job system. It is going to be much easier than manually handling threads yourself. You can look at my video on dots to learn how to use it, or you can check out my complete dots course, which also covers the job system, plus ECS, the burst compiler, and a bunch more. Alright, so that's how you write multi-threaded code in C#. This is an extremely powerful skill to know. It is very difficult to do it properly, but if you can do it, you can literally get 10x performance improvements on the exact same hardware. It has a lot of pitfalls like we mentioned, but also a very huge benefit. So this one is definitely a very valuable skill. Although also, like I mentioned, if you mostly work inside of Unity, then I recommend you use the Unity job system to run that multi-threaded code. The job system has a bunch of features to help you write multi-threaded code whilst also avoiding a lot of those pitfalls. Hello and welcome, I'm your Code Monkey. And congrats on completing the advanced section. We started off with an interesting advanced topic that I actually only started seriously learning recently. It's reflection. I had to learn this myself in order to make the exercises for the companion project. That's how they all work. So now you know how you can dynamically inspect your code and work with it without directly calling functions or reading fields. Next we had a simple but interesting lecture. It's how we can make function extensions. These allow us to extend a type with more functions without having to modify that type itself. So this is really useful when you don't have access to that type, when you don't have access to the source code. Then we learned about static constructors. This is kind of like the normal constructor, but they run just once for the entire class. After that, we learned about the type of keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then we saw a lecture on nameof. This one helps us get a string name of some type. This is really useful to help us ensure we don't use strings in our code as much as possible. Next, we learned about the sizeof operator. This one lets us get the size of our types. So for example, we can easily see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps us see how much memory our code will actually use. Then we saw a lecture on default. It's a simple and very useful operator to get the default value of some type. You can get the default value of an int, a bool, an object, and pretty much anything. So this is much better than hard-coding some default values. After that, we saw a lecture on expression-bodied members. This is a really compact way to write simple short functions. There's no need to write all the usual function boilerplate code. It's basically just a lambda. Then we saw a lecture on records. This is a super simple way to create immutable types to organize our data. Next, we'll learn about the null conditional operators. This is how we can easily test for null before doing something, like firing off an event. Then we saw a lecture on the null coalescing operator. This one lets us quickly test against null and return a default value. After that, we learned about the ternary conditional operator. This is an excellent super compact syntax for making a simple if. You have just a condition with an if and an else. Very tiny, very useful. Next, we learned about the main function in a console app and how to pass in command line arguments. This was a really important lecture because there are so many interesting programs you can build that don't actually need a UI. So just a simple console app that you can control with some command line arguments, just that is going to be an excellent option. Then we saw a lecture on Nullable. This is how we can make any type support null, even value types like int or bool. You can make them nullable to support null. So this can sometimes be much better than having to predefine some special value, something like -1. Then we saw a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create any new objects. It's really just basically a pointer, meaning this is insanely performant. Then we saw a lecture on Bitwise Operators. This is how we can work with individual bits of data. In this lecture, I also taught you the basics of how binary works. Next, we learned about Enum Flags. This is how you can turn your enums into bitmaps, which then allows you to make some interesting combinations. Then we saw the lecture on Preprocessor Directives. With this, we can give orders to the compiler itself. We can define some symbols and include or not include some code in the compilation. Next, we saw a lecture on the keywords ref, out, and in. These are really useful. They help us get more data out of a function than just a single return type. And they also let us work with types as references, even if they are value types. After that, we learned about data boxing. This doesn't have anything to do with punching people. It's just about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we learned about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields, even if, again, that type does not exist. We can write anything and we get no errors. The validation logic only runs at runtime. It does not execute at compile time. So this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, we can make our own custom types support access through an index, just like a list or array. We can add whatever logic we want and make it read-only or read-write. Next, we saw a lecture on attributes. This is how we can add metadata to our code. That metadata can then represent whatever you want. You can then use reflection to analyze it and do something to it. After that was an interesting lecture on anonymous types. This is a really quick, great way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that was the next lecture on tuples. These are somewhat similar. They also allow you to organize some data without first defining a type. In this lecture, I also covered the differences between anonymous types and tuples. Next was a lecture on using an IDisposable. This is a really interesting code block and an interface that helps make sure you don't forget any kind of cleanup code. After that, we'll learn how to create custom override operators. Using these, we can add support to our own classes to do things like addition or multiplication. So we can define, for example, the logic of what does it mean to add two custom player classes together. Then we also define the logic for comparing two custom types. So defining what exactly does it mean to do an equals. Next, we saw a lecture on LINQ. With LINQ, we can easily do query operations on any collection of data. So that can be a list, can be an array, XML, or some kind of database. We can query for some conditions to select just a few elements. We can sort something, do a union, do a join, and so on. So if you're already familiar with SQL, then LINQ was probably also quite familiar. Afterwards, we learned about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop components. Here I also talked about other visual program tools like WPF and .NET MAUI. And I also mentioned how Unity itself doesn't have to be used just for making games. You can make normal applications with it. Next was a lecture on DLLImport, library import, how to use extern, and work with the Windows API. This was a great lecture to learn how to interact with external libraries. Then we saw a lecture on asserts and unit testing in general. So with this, you can validate your own code to make sure everything is behaving exactly as intended. Next, we saw a lecture on writing unsafe C# code and working with pointers. Now, this is a very advanced topic. Technically, if you know what you're doing, you can make some very impressive stuff with unsafe code, but C# has safety for a reason. So while we'll learn the basics of it, definitely make sure you use this very wisely. Then we also learned about asynchronous programming, specifically how to use async, await, and task. This is how we can have some code that takes some time, like for example, contacting a web server, and keep waiting for a response without blocking our program. This is extremely important in making sure our program feels nice and responsive. After that was a super important, very advanced lecture. This one was all about multithreading. This is how we can take advantage of all the cores in the CPU and make them all do work at the exact same time. When done properly, you can get some insane performance improvements pretty much for free, but it is also very, very easy to make mistakes. So this one is very much the definition of an advanced topic where you must know exactly what you're doing. In this section, we'll learn a ton of very interesting, very advanced topics. And yep, all of that concluded the advanced portion of this course. So congrats again on completing this section and on completing the entire course. I hope you took your time and fully learned absolutely everything in this course. This course really started from the absolute basics of programming, like how code works line by line, and we went slowly, little by little, until learning some very advanced topics. So I hope that, regardless of what was your starting point, I hope you learned a lot and you find this course very useful. C# is really an extremely powerful language, and now that you have all this knowledge, now you'll be able to build so many awesome things. You can make games, you can make console apps, you can do electronic stuff, websites, AI, IoT, automation, really just about anything. So I really hope you put all this knowledge to good use. And of course, remember you can always come back to this course at any time. You'll really not expect to memorize all of this. Personally, I Google things all the time myself, and now that I actually have this course in my own words, anytime that I really need to relearn some syntax, I'm just going to come here and listen to my own lectures. So if in the future you need to remember something about C#, just go ahead and rewatch that lecture. So congrats on completing the entire course. I hope you learned a lot and I wish you the best of luck with your future projects. Hello and welcome, I'm your Code Monkey. Alright, so congrats on watching through this entire free video. I hope you learned a ton. I really hope you took your time and really focused on learning all the topics in this advanced section. This one covered quite a lot of very interesting topics. And if you watched this video, I hope you also watch and learn everything from the previous two videos, the one in the beginner and the intermediate sections. If you watch all three, and you took your time to actually truly learn all of this, if so, then now you have an excellent amount of C# knowledge. If you want to try out that knowledge and put it into practice, if so, then you can check out the premium version of this course. The companion project includes the interactive exercise, along with frequently asked questions and quizzes for every lecture in the course. Remember, you only actually learn by doing, so make sure you put what you learned into practice. Now to continue on your learning journey, if you want a course on making a specific game, you can watch my free Kitchen Chaos course. In there we build a really nice game from start to finish. There's also a second video on adding multiplayer onto it. For something more intermediate, check out my turn-based strategy course. This one is a really nice turn-based strategy game. It's got lots of actions, enemies, very cool. Or if you're an advanced user, if so, then check out my Unity Dots course. Unity Dots is an extremely advanced but very powerful toolset. It can literally help you write code that runs 100x faster. Or in general, for Unity, check out my Ultimate Unity Overview course. That one covers over 70 tools and features that Unity has. Alright, so thanks for watching, I hope you learned a ton, best of luck in your learning journey, and I'll see you next time.